Olá, muito bom dia. Eu sou o Sérgio.
Good morning, everyone. My name is Sergio Santos, and I would like to welcome you both here in person and online. We are getting started with our first international workshop on robotic surgery and artificial intelligence, promoted by ANVISA and ABRAIDI, and sponsored by Intuitive, Medtronic, Stryker, and Johnson & Johnson. Those interested in ask questions may do so via WhatsApp 5511. I'm going to repeat the number again. And it's also available through the chat online. We will start talking about ergonomics, usability, and human factors. The moderator of this panel will be Juliano Tesser, a specialist from the Management of Equipment and Technology with ANVISA. Please join us on the stage. Thank you.
Muito obrigado mais uma vez.
Thank you. Our speaker of this panel is Joe Cisa, Director of User-Centered Design in the United States. Welcome.
Os nossos... Juliano Tesser, a palavra com você.
So, Juliano, the floor is yours.
Bom, muito bom dia.
Good morning, everyone. It's a pleasure to be here again on the second day of such an important event. So now we are going to deepen our conversations. And it's a specific theme that we have today, which I believe, not to minimize the other subjects, but I believe usability and human factors is an essential topic, especially when talking about robotic surgery. So it's a pleasure to have an expert here with us in the usability area. I will try to summarize then Joe's background. So Joe is the Director of User-Centered Design at Medtronic. His team is responsible for the industrial design and interface design, human factor engineering, and research. His team supports a broad portfolio of medical devices, surgical tools, and important equipment for the OR. He's a member of the Committee of Human Factors at AMI, and he's also a collaborator of the Human Factors Review and the TRI. His experience amounts to 28 years in managing industrial design, consumer products, and medical devices. He worked at Fisher-Price, Ex-Medica, Kimberly-Clark Healthcare. He has a BFA in Industrial Design by the Cleveland Institute of Art and designed over 50 products that have been commercialized and holds 30 patents as well. So we have a very interesting background. And so, Joe, the floor is yours.
Okay. Working? Okay. Bon dia. Good morning. Thank you for having me. It's an honor to speak to all of you about a topic that's very near and dear to me. So today, I'm going to talk to you about... let's see, it's to work. Nope. Oh, it's down here, but it's not up there. Okay. Hang on a second. There we go. Okay. I'm going to demystify human factors in surgical robotics today. Everybody thinks that somehow it's special and it's, it's different, and it's not. So today I'm going to talk to you about why that is. So I probably don't need to introduce myself. It sounds like we just had an introduction, so I'll kind of skip through this slide. But I'm the director of user-centered design for Medtronic, so I have a large team of human factors engineers as part of my group. Disclaimer, very quickly, I'm going to talk a little bit about opinions that are my own opinions of how I interpret the FDA's guidance. I am not a member of the FDA, and nor do I represent their points of view. So wanted to put that in there. Okay, so what is human factors? And I say this a lot to people because people always ask me, so I simplified it. It's basically a methodology for researching, designing, and evaluating human interaction. And that's both physical and psychological. With an interface of a product or a process, doesn't have to be a physical product, for the purpose of reducing use error, optimizing work, and improving user satisfaction. So a lot of people think that human factors is ergonomics, and that is not true. Ergonomics is a piece of human factors, but they are not, ergonomics is not all of human factors. Human factors is much broader than ergonomics. So this is the crux of what I'm going to talk to you about today, okay? People are not engineered systems, okay? Now, if you look over here, you have a device, right? Devices are engineered systems. We design devices, we can make them predictable, we can test them to do the same thing over and over again, and we know exactly when it's going to fail, or we have a pretty good idea when it's going to fail. They're engineered. Environments, they're kind of predictable. Depends on a hospital operating room is a fairly predictable environment. It's got the same kind of lighting, the same kind of equipment in it, the same people that interact in that environment. But if you're talking about a product like a blood glucometer or diabetic would use, that the environment that they use that in is anywhere in the world. It could be in a car or in your house or on outside, or so the environment's unpredictable in that situation. But right here is the human. And this is a product system, okay? So the device, the environment, and the human, they cannot exist without one another. You can't use a device without a person in an environment. They all are symbiont with one another, symbiosis with one another. And so the human is the part of the system that we cannot control, okay? So the most important thing to understand is that humans are uncontrolled, we're unpredictable, we're unreliable, and we're inconsistent. So that's why human factors exist, because we cannot control this. Now, one of the things that is an important thing to understand in human factors, that when you talk to people and you ask them questions about what they do, they'll say one thing and they actually do something completely different. That's very common human behavior. We're not good at remembering things that we do. So this is important when we get into human factors, and I'll explain that as we move along here in the slides. So what is the scope for human factors in surgical robotics? So today's presentation I'm going to give to you guys, all of my slides are going to look very similar to this. I'm going to talk about, in the spirit of demystifying human factors in surgical robotics, I'm going to tell you all the things that it doesn't matter that it's a surgical robot. You have to do these things. It is true no matter what the medical device is. And I'm going to tell you what about surgical robotics, in addition to those things, make it different isn't the right word, but perhaps more. What in addition do you need to do? So that's how I'm going to lay this out for you guys. So the first thing we talk about when we talk about human factors is the user interface. So the user interface is the place where the human interacts with the system. It is the point at which we communicate and contact each other. And so understanding what that is and the scope of that is important when you're doing human factors. And understanding that there are different kinds of user interfaces. Most of us think of a user interface as a button or a screen. And that's true. You have hardware user interfaces. and you have software user interfaces. But you also have instructional interfaces like quick reference guides or instructions for use. The packaging of your product is a user interface. You have to read the label on it. You have to be able to peel it open. That's a user interface. Training is a user interface. Now, you might think, how is that a user interface? Well, the people that are using your device have to interact with the device and a person to learn how to use it. So that's an interaction point. So that is a user interface. And then things like labeling, you have labels on your device, that's a user interface. So understanding what that is important. For surgical robotics, same thing, except there are much more of these things, right? A surgical robot has hundreds of user interfaces, not one or two like a normal device. A smaller device, maybe a pen injector, might have 2 or 3, whereas a surgical robotic system has many, many more. And the other thing is that there are inconsistent experiences between the manufacturers, right? We all make different, our interfaces are all a little different from one another. And so what that does is it puts a little bit more of a cognitive load on the user to have to remember how to use this device versus that device. And that's not just true in robotics, that's true in all medical devices. But robotics, because there are more user interfaces, it makes that more challenging. So this diagram is actually from the FDA has this in their guidance document, but it's a very common diagram. This is basically the outflow of the user interface. So the first thing you do is you see or you perceive the interface, then you process it, you think about what it is, and then you act. And when you act, you're commanding the robot or the device to do something. And then from there, the device has an input, it processes, and then it gives you an output. Okay? And so the reason this is important is because there's these 3 pieces right here: perception, cognitive, and action. These are the core principles of human factors root cause analysis. Every kind of use, everything you do in the world today, no matter what it is, if you're touching something or interacting with something, the first thing that happens is you perceive it. Think of these as the 5 senses that the human has, right? Touch, smell, sight. You see it, you feel it. Your brain starts to think, what do I do with this? And then you act on it. So this is the information you need to know to be able to use anything. For surgical robotics, obviously more complex workflows, right? A lot more complex workflows with a lot more use steps. So this flow is much more complicated. And also, because a surgical robotic system uses teams of people to operate it, you may have multiple workflows like this happening one on top of the other all at the same time. You might have users over here pushing these buttons and the surgeon over here pushing these buttons, and that's happening simultaneously. So it makes it even more complicated. And I'm going to walk you really quickly through the process. So what governs human factors for medical devices, we're familiar with these ones on the top. Most of us probably are. IEC 62366. This is the governing normative standard for human factors engineering around the world. And that is the guidance that we follow. Also, 13485, 14971 is a very important one because it has to do with risk. And that is a big part of human factors engineering is risk. And then in the United States, we have FDA has their own guidance, which is loosely connected to 62366. They're not exactly the same, but they're close enough. And then we also have guidances like AAMI HE75, which I'm a member of. I'm one of the contributing authors of. And that's basically a guidance. You don't read it like you would read a book. You use it for reference. So if I want to understand how to design a handle, you would go to the hand tools section and you would read how to design for human factors. So it's a great document to help you with that. And the surgical robotics systems, at least in the United States, the FDA is looking at working with us on providing some kind of guidance around robotics with some of these guidances, but there's nothing official yet. So what does 62366 say? So I'll go through this very quickly. You have to prepare a use specification, which is documenting your users, your use environments, and your intended uses in your operation. You have to identify your user interface characteristics safety-related issues with use errors, identify your known foreseeable use hazards, describe your hazard-related use scenarios. You have to select the hazard-related use scenarios for summative testing. So when you go to your validation, that is really important. You have to make sure that that is documented. You have to specify the user interface, and you have to plan user interface evaluations, and you have to perform validation. If you have any kind of medical device, not just a surgical robot, that has hazard-related use situations, you have to follow this standard. So again, for robotics, nothing's different. So I'm going to quickly walk you through what this process looks like. This is just kind of a high-level overview of the process. Anybody who is familiar with product development process in medical devices, this will look somewhat familiar. The most important thing you have to do is you have to discover what your stakeholder needs are, what your user needs are. This is really critically important for human factors, because if we don't understand this, then you can't design the right user interface, and they won't be able to operate it the way it needs to be operated. So this is a really important point. You have to define, what those are, what the priorities of those are. Develop some concepts, right? You're going to build some prototypes and some models. You're going to test it with users. You're going to evaluate those, and then you're going to, once you get a final design, you're going to finalize it, and then you'll be ready to commercialize. If you look, this diagram is a circle. And the reason it's a circle is because if you don't do this right, and you don't do this right, you can't do this correctly, right? So you have to make sure, we're going to focus on, these are the important things you need to focus on. You need to make sure that your product designs, before you go to validation over here, you've built something that actually meets the user's needs. Too many companies want to hurry up and get to the finish line and just get it out the door. And I can tell you right now, if you don't do this right, and you just rush it through, and you get something over here, and you get to validation, and the design isn't right, you're going to fail validation. You're going to fail summative testing. And that's very expensive with surgical robotics. Very expensive, because you have a large team you have to usually recruit, and all those sorts of things. The other thing that's important is your post-market surveillance. This is why this is a loop. Because once you've got out in the market, human factors has to also monitor complaint data and complaint handling and make sure there aren't any use-related issues with the user interface. Hopefully you don't have any, because if you did this part right, then you don't have those problems. But if you do, then you have to start all over again, and you have to go back and rediscover what are the needs, the stakeholder needs. So here's some of the things that are the same. These are activities you do in human factors. And so you can see here, there's contextual inquiry. This is where you go out to hospitals, out to clinical facilities, and you actually watch people behave. This is different than interviewing them, because like I said at the beginning, people behave differently than they tell you one thing and they do something else. So it's really important that you actually do contextual inquiry, and you watch people in their natural environment and watch the behaviors that they have to figure out what problems they're having, where they're struggling to use the device. Workflow analysis. This is, again, just figuring out, like, what are the workflow, what are the tasks that they need to accomplish. Identifying your stakeholder needs and analyzing those things so you're designing the right thing. Anthropometrics. This is the measurement of the human body. So this is understanding, how far it is from my hip to my foot, and when I'm sitting down, what's that distance? And well, that's how I design a chair, or say a surgeon console. Brainstorming, ergonomics, user preferences, and formative evaluation. So for surgical robotics, again, nothing's different. You have to do these same things for any medical device. For surgical robotics, though, it's a much larger scale, a much larger amount of work that you need to do that has to be accomplished. And so that's what makes it more challenging. Now, I knew when I came here, there's a lot of people like, I want to learn about ergonomics. Tell me about ergonomics. This is human factors and ergonomics. I'm going to spend a little bit of time about ergonomics, but I'm telling you, it's not as big of a thing as it's important, and you have to consider it in your design, but it is not the whole totality of human factors. But in the spirit of that, one of the things I get asked all the time, for some strange reason, people are like, oh, tell us how you designed the surgical robot for Medtronic to be designed for women. That's a great story. Let's talk about how it's designed for women. All medical devices have to be designed for women. We have to design all medical devices for all intended users and all patients. There's nothing special there. There's nothing unique. We all have to do that. It's the law. So the idea that we would do something special for women and versus men, that's absurd. It has to be made that way. So yes, you have to do ergonomics. You have to design for the 5th to 95th percentile users and patients. You have to design for all genders. You have to design for all impairments. Do they wear glasses? Do they have, hearing impairments? How does my design affect that? Education, what's their educational levels? If you're designing a surgical robot, it's going to be for more educated people who went to university or doctors who are even more so, versus if you're designing something for someone who's like a diabetic who has no education, for example. And just to further this point, ergonomics and anthropometrics, this is where you go to find out more. HE75, which is an American standard, is a really great source for some of these diagrams here are from HE75 that talk about the measurements that you need to consider when you're designing a product. But ergonomics isn't just like, when you sit down, is it comfortable? It's also things like reading distances. How big does the font need to be able to read text at a given distance? How you design the fonts to be readable, and spacing of characters, and the design of connectors, right? So that mechanically you can't connect two things together that aren't supposed to be, because that could be a safety issue. So I figured I would put this in there just to fulfill everybody's need to see ergonomics, but that is not the full story I want to tell, but it is a big piece of what we do, but it's not all of what we do. Okay, so now the documentation, this is the same, right? These are the things you have to do when we present to regulatory bodies around the world of what is required of human factors. You have to present your plans and protocols, how you designed all your studies, what you did. You have to show all of your known use problems. This is both with predicate devices that you may have, as well as your competitors' devices. So you can go into various databases and find complaint data on your competitors. Because, at least in the United States, the FDA wants to make sure you didn't just copy your competitor's design and then not have any idea that their design has all kinds of use problems. And so now you have those same problems. So they want to make sure that you did that initially. And this is actually one of the first things you should do when you're designing, by the way. Use specification, again, documenting your users, your use conditions, operational use, interface requirements. What did you design? How did you design your user interface? Your use cases, I'm going to talk to you guys a little bit about that soon. Those are important. That's documenting basically the task flow. Your URRA, the URRA, we're going to have a whole nother section in this presentation about that as well. That's very important. That's your risk analysis for usability. Use-related risk analysis is what that stands for. Your reports of your formative evaluations and your summative validation testing. Again, for robotics, nothing's different. You have to do all these things for robotics, just like you have to do for every medical device. So the first thing you have to do is you've got to determine what your use scenarios are. So you're going to do some brainstorming. You're going to figure out like where are the areas where things could really go wrong with users, right? What if there's a patient emergency? What if the system has a power failure or the hospital has a power failure? What if the device fails? What if the users need assistance? These are all things you need to brainstorm when you're designing any medical device. Again, for surgical robotics, it's a little more complicated. This list is not exhaustive, but here's some examples that you might see that might be a little different for a surgical robotic system than you would have for other kinds of devices, right? The patient emergencies could be a little more difficult because you have this very large piece of capital equipment that's hovering over your patient or attached to your patient. That makes patient emergencies a little bit more critical with a surgical robot. Think about what happens there. How are you designing your interface to address that. Like laparoscopic procedures, robotic is also uses a scope to be able to visualize. If your scope isn't pointing at the problem, you can't see what's going on. It's another situation you have to be aware of when you're thinking about these different use scenarios. So I won't go through all of them, but these are some examples of things that just make robotics a little bit more difficult because it's tricky. It's a much more complicated system. Okay, so human factors validation. This is in 62366 and also in the FDA guidance. It's called summative testing. You may have heard that term, summative testing. This is summative testing, yes. And so this is the same for all devices that have to undergo this level of testing. Okay, so you have to, for use, you have to test all of your critical tasks. You are required by law to do that. Critical task is a task that if an error occurs from a user and you harm the patient, that's considered a critical task. You are required to test all of those tasks in your validation testing. You have to test all tasks that enable interactive use, the intended use of the device, right? Even if they're not critical. Your use environments have to be as close to representative as possible. And so this is a photo of we have operating rooms that we built in our facility that are basically a simulated operating room. It has all the equipment that a real operating room would have, the lighting, the sounds. You have to try to create that because the way your environment impacts how people use your device is important. So that's why you have to create these realistic environments. So we have things like, information that's on the screen, like we have a fake anesthesia, patient vitals going on, and you hear the beeping and you hear the sounds. We have, a bear hugger, a patient warming system that is under the bed that's making noise because in a real OR, there's going to be noise and I have to hear the alarms over the sounds of all these other things in the room, right? You have to emulate the tasks as best as you can. Now, I'm going to make a really important distinguishability here is that human factors testing, we don't test generally clinical outcomes. Okay, our job is not, that's the preclinical team's responsibility to test that your device can actually do surgery and actually complete the intended surgical outcomes. That is not what human factors is. Human factors tests whether you can operate the device to do surgery. So we're not as focused on like, can they do a prostatectomy? We're focused on, can they open and close the jaws and cut this vessel and, move this tissue out of the way? So we put real tissue in and they'll do tasks on the tissue, but we're not actually doing a real surgery. And then this is a really important one too. Your users that you recruit have to be representative users. You are not allowed to use engineers in your validation testing. Engineers are not doctors or nurses. Most of them aren't. You have to use actual surgeons and nurses. So you're going to have to recruit them and they have to come in and they have to do these tasks. So, and then you also have to emulate like critical scenarios, like a patient emergency, right? So you might have like a bleed or something that you simulate. For surgical robotics, this is important because you can't just pack up a surgical robotic system in a suitcase and just send it somewhere and do your usability testing anywhere you want. Unless you have facilities in other places, you're generally going to have to bring your participants to your facility. So cost gets a little bit more. The logistics of recruiting gets a little bit trickier. Also, you're recruiting teams. So you have at least a team of 3 people using a surgical robotic system. That takes a little bit of time. Some recruiters have difficulty with that. You run into all kinds of problems with that. And so you just have more resources that you're going to need to do the testing. And the testing takes a lot more time on a surgical robotic system because you have hundreds of tasks that they have to do. So it takes, it'll take you a day or even longer to do your validation testing versus, say, a pen injector that, you have 4 tasks and you're done in 10 minutes. So just another important consideration. Okay. Now we're going to get into the important part. This is risk management. So risk management is very, very important in human factors engineering. I'm not going to read this verbatim for you. Everyone in this room should have some idea around 14971. It's the normative standard that drives risk management for medical devices. You have to identify your intended use and safety characteristics. You have to identify your hazards. You have to estimate your risks of hazardous situations. You have to have your risk control analysis. You have to implement risk controls, and you have to have a residual risk evaluation. That is true for every medical device that has to do with safety. You have to do this in human factors, no matter if it's a surgical robot or not. Now, when you get into the use-related risk analysis, this is the document that human factors engineers have to create to make sure that you've developed a safe user interface. There are very specific things you need to do. You have to review the complaints of your previous device. We talked about this a little bit earlier. That's an important part of your risk analysis because you have to make sure you consider that there are other elements of your user interface, maybe that you copied, and you have to know what those risks are. You have to identify the tasks and steps the users need to accomplish the intended use. That's a very important part of doing your risk analysis. I'm going to talk to you about that in just a minute. Identify your prospective use errors and harms and the severities of those use errors. You have to identify the prospective root causes. The PCA, that's the thing I talked about at the beginning of my presentation, the perception, cognition, and action, the three ways that use errors can occur. This is where you put those, is in your risk analysis. You have to record what risk controls you have put into your design and how they mitigate the use errors and the harms that you have, and then you have to update this use-related risk analysis throughout the development and after commercialization. This is a living document. Anybody in here who's familiar with quality and risk management, you know that this document never ends. It's always alive. And so you have to constantly update it when you have complaints and things like that in the market. And actually, for surgical robotics, again, much more work. Right? You have a lot more use steps. You have a lot more use errors. And so you just have there's a larger quantity of work you need to consider when you're doing this activity for surgical robotics. But the activity is the same. You just have more to do. Okay, so use cases. I talked a little bit about this. This is an important step because you can't do a risk analysis unless you actually know what the steps are that they need to do to accomplish the goal. So a use case is very simple. It's basically, it documents the interactions between the users and the system. So, and it basically is broken into sort of steps or goals. You might call these use scenarios. These are things you have to think about. So I'll give you an example. On a surgical robotic system, your use scenario might be draping, right? Okay, what's the goal? Well, I need to drape the robot. Okay, what are the steps? Well, I need to go get the packaging. I have to read the label. I have to peel open the packaging. I have to remove the drape out of the packaging. I have to unfold the drape. I have to attach it to the robot. Those are the steps, right? So you're breaking it down into tasks and steps. You have to know who the user is. You have to know what's true to start, what's true to end, and then you have to describe the nominal workflow, and then you might have some alternate workflows. So that would be if you had a choice in a workflow. User can push the red button, user can push the yellow button. If I push the red button, these are the steps that happen. If I push the yellow button, these other steps happen. So you have to identify and document all of those alternate flows. So this is just a quick example of what this looks like, just kind of a made up version, right? So your task might be exchange the instrument from the patient with another instrument. Your user might be the bedside assistant. Your precondition is that the obsolete instrument is inside the patient. Your postcondition is that the exchanged instrument has now been put inside the patient. And then your use steps would be things like, release the instrument from the instrument jaws from the tissue, pull the instrument back from released tissue. So you're just basically gonna document all the steps. Okay? So then once you have all your steps, you have to identify what your use errors are. You're going to do a use error analysis on every single step. And for surgical robotics, there are a lot of steps. So this exercise is exhaustive. So a use error is a user interaction or lack of user interaction while using a medical device that leads to a different result than intended by the manufacturer or expected by the user. This is the 62366 definition. The FDA has a similar definition. They tweaked some of the words. I don't know why, but they did. And so here's what a use error is not. A use error cannot be caused by a device failure. And it should be causal to a deficient user interface design. So the reason I mention this is because of those of you, anyone in here who's in quality, and you've ever done a risk analysis, you understand that you always separate, you always assume that the other types of risk are perfect, so you isolate the risk you're assessing. So in a use-related risk analysis, you assume that the design is perfect. In other words, it works and it functions and it's operating as you've designed it, and that the process used to manufacture it is also perfect. And so the only thing you're isolating is the user and the user interface and the interaction. So that's why devices. So in other words, example would be if you go to brake the robot, right, and push the brake to lock it in place, and the brake pedal falls off. That's not a use error. That was someone in the process forgot to put a screw in that holds the pedal in place. And well, that's not the user's fault. You didn't manufacture it properly. That's an example. Okay, this is really important. Use errors do not blame the users. You'll notice that I've been using the word use error and I've not been saying the word user error. For those of us in human factors engineering, we cringe when people use this word. The FDA and certainly notified bodies do not want us using the term user error because it blames the user. Your root cause must be rooted in your design. It is your fault. You designed a poor user interface, and that's why the users made this error. So because that's why human factors exists in medical devices these days, because in the old days, they would design these terrible user interfaces, and then people would get killed, and then the manufacturer would go, well, it's not my fault that they don't understand it. Right, so it's our fault. We have to assess that. So don't use the word user error, it's use error. Okay, so getting close to the end here as we're wrapping up, use-related risk analysis. So there's risk controls mitigations that are required to address use errors. And the only way you can control, remember at the beginning I said we can't control human behavior, right? Humans are unpredictable, they're unreliable. We can influence the way that they behave. And the way we do that is through the design of the user interface. Now, if we have a good user interface that controls risks really well, then people don't get hurt. If we have poor ones, that's where this happens. So if you have a poor usability risk control, that can lead to the patient or the user to harm. And we must address that and mitigate that and go back to the design and redesign it until that doesn't happen again. That's why we do human factors testing with mannequins and not real patients, right? Because we don't want to hurt anybody. We let this happen in the process of product development where it can happen safely. Now, a use error can still occur, and you might have a really good usability risk control, and no harm occurs. So I'm going to give you an example of what I mean by that. This diagram I actually took from the United States FDA. They did a presentation, and they talked about their opinions on the strength and effectivity of risk controls for usability. The most important and most strong way to mitigate harm with the user interface is to eliminate that harm with design. In other words, your robot or your medical device prevents the user from doing something stupid, okay, right, or something harmful. So it's impossible to cause that harm. If you can't do that, and in a lot of cases you can't, then you have to guard against that harm. Maybe something sort of comes up and blocks you. It doesn't fully prevent you, but it kind of like stops you from what you're doing to redirect you. Then over here is warning. You might have warnings labeling on the product itself that warns you against doing certain things, or a message in a surgical robotic system where we have software. A message can pop up on the screen and say, hey, stop what you're doing. or lights can blink, or an alarm can go off, that's a warning. Now, if you look, and Mark's going to talk about this later at the end of the day, we're going to talk about training. Do you see down here where instructions is? Instructions and training is all the way at the bottom. There's a reason for that. And the reason is because no matter how much training and instruction you do, humans are fallible, humans are inconsistent, humans are unpredictable. We'll forget half the things you taught us, and the things we remember, right? So we need practice to be able to remember training. You can't rely on training as it is not a very strong risk control at all. And the FDA understands this, and other notified bodies understand this, that it's not that you don't have to do it, you still have to do it, but it is your ability to rely on that as a strong defense against a harmful situation, not so good. So you have to make sure that you're doing everything you can in your design to prevent the user from doing the wrong thing, and don't rely on training as, oh, we'll just train them to not do that. If it's something harmful where you could kill the patient, how confident are you that your training is going to prevent them from killing someone? You better be very confident. And a surgical robotic system is very complicated, and so, again, makes that problem, even exacerbates that problem. Okay, so the last piece of use-related risk analysis and risk management, this is an example URRA. And what I wanted to show you in this slide is obviously, you document what the use scenario is, you write down what the use step is, what the failure effect is, and then you're going to brainstorm these things, right? So you're going to have your use steps, and you're going to brainstorm what are all the use errors that could occur in these use steps. And that's how you figure out what these are. Sometimes what happens is you do usability testing and you put your prototype out there, and then they make mistakes, and then you're like, oh, well, that's actually, I'm going to put that down here because I saw it happen. But this is an important piece. Your risk control measures have to address the causes, not the use error. So I'll give you one example here. Here's one where I have just a fictional dial they have to rotate. And the cause was that the user didn't see the labeling on the dial. This is a perception cause. Well, my risk control measure has to address that. Otherwise, I won't be able to fix it. So labeling is present on the face of the device. Labeling is in a contrasting color, right? Those are examples of requirements you might have that address the cause. That's how you do risk management for human factors, because it's all about human behavior. It's about PCA. So those are the things you're addressing. Okay, the last couple slides here, training and documentation. I just have one slide on this, and there's a reason for that. Because no matter what you do in any system, surgical robotics or not, if you are providing training to your users as part of your commercialization, in other words, I'm basically starting you up in your hospital with this product, and I'm giving you training, it must be included in your human factors. It's required. So you have, then that training has to be representative of the actual training. So in the United States, the FDA requires that we show how the training we used in summative validation is equivalent to the actual commercial training that you're giving to your customers. They don't want you cheating. That they don't want you helping them and giving them more information in your testing training than you would give them in the real world. That's cheating, because you're basically making it easier for them to pass. They don't want you doing that. Documentation, the IFU, quick reference guides, all that has to be included, has to be present in your validation testing. You are not allowed to direct your users to the instructions for use in validation testing. Anybody know why? Because in the real world, you're not going to be there to go, oh, here, look at the instructions for use if you don't know what to do. You're not going to be there to do that. If they choose to not pick up the instructions for use and read it, that's what happens in the real world. And we all know that's what happens in the real world, right? They don't actually read the instructions. So you're not allowed to do that in human factors testing. Now, you can do what's called a knowledge task, where you can, a separate test, you can give them the instructions for use and ask them to read excerpts from it, and you can confirm whether the information that you've given in them, information for safety, is good, and they understand it, and they can comprehend it, and they can find it. You can do that, But in the main body of the validation testing, you're not going to be doing that. Now, there's different parts of training. You're going to have your instructions for use that's present. You might have electronic learning. You're going to have reference guides, like quick reference guides that the device has. You might have some kind of VR training that you're going to do. You're going to have instructor-led training. All of these are all different kinds of training that you might see for a surgical robotics system. We have to do all these things. All these pictures were taken from our validation. You have to do this in your validation testing, so it has to be included. Okay, the last piece here. This is another question I get a lot, is how do I know that I passed or failed human factors testing? Now, this is opinion of the FDA, and this is my interpretation of that opinion, but in my years of doing submissions, I found this to be true. You cannot have quantitative acceptance criteria in human factors testing. Now, I'll explain why that is. You're not allowed to go, oh, well, 90% of the time they didn't kill the patient. Why? Yeah, right. Why is 10% okay? Right? So you're not allowed to go, well, of all the use errors, I'm going to accept 90% of those. And then whatever else happened, it doesn't matter. You can't do that. And also, so usability validation is seen as a qualitative exercise. In other words, you're going to have use errors, and you have to explain why it's okay that they stay there. It's okay that you weren't able to mitigate them, right? And so that's basically the point, right? You can have this. You're going to have this. In fact, that pie is probably not correct. It's probably much larger. What you have to do is you have to explain to regulatory bodies why that's okay through your residual risk analysis. That has to be the reason, and you're going to explain to them why that happened. Again, back to the very first slide I showed you guys. Humans are unpredictable, humans are unreliable, inconsistent. Regulators know this. They understand that humans are fallible. They know that we're unpredictable. They expect that mistakes are going to happen because why? We are not engineered systems. We're humans. So this is an excerpt of the FDA guidance right up here, and I'll read it to you. It's practically impossible to make any device error-proof or risk-free. Some residual risk will remain, even if the best practices were followed in the design of the user interface. All the risks that remain after human factors validation testing should be thoroughly analyzed to determine whether they can be reduced or eliminated. So regulators know you're not going to have no use errors. You're going to have use errors. It doesn't mean that you failed validation if you have use errors. But what you do have to do is you have to identify the issues where those errors happen, and you have to ask yourself, did we do everything we could that was in our ability to do to prevent this from happening? And was there more that we could have done? If the answer is no, or the answer is yes and no, then that's your residual risk, right? So your pass-fail is determined by the root causes. We talked about that, the PCA. Focusing on both individual issues and patterns of issues for unsafe use. I'm going to explain that one really quickly for you. You could have 15 users using your device, and one person out of all of your testing makes an error that kills the patient. Is that less important than the other ones where they made everybody made 20 mistakes? No, it's just as important. So the quantity, the amount of errors you have is not, you should not be measuring that. It's the severity of harm that occurs is what you're measuring. You could have one event and no one else makes that mistake, but you can guarantee that somewhere else in the world, someone is going to make that same mistake. If you have 1 out of 15, that's, what is that, 8 out of 100? That's a pretty bad risk level. So again, we make mistakes. And then lastly, the benefit risk analysis, you have to do that. The benefit of the device has to outweigh the risks, and the harm could not be further mitigated. So again, guys, it's exactly the same on a surgical robot as it is on any other medical device. You have to do this on all medical devices that introduce harm to patients. And it's the same here. It's just you have more to do. So in closing, it's not different from other medical devices. Human factors work is more complicated due to complex workflows. There's a lot more use steps and behaviors you have to do. The amount of work to design and evaluate and test the user interfaces is much greater. It's going to cost you more money to your companies, but you have to do it. It takes more time to complete the work required for human factors. This isn't just testing, it's all the risk analysis, writing all the use cases, writing the reports, which can be hundreds and hundreds of pages, depending on how much work you did in the actual testing itself. And then your residual risk analysis needs to show evidence that any use errors are acceptable and cannot be further mitigated, and the benefits outweigh the risks. This is true on all medical devices. So thank you for your time, and I'll take some questions. I'm gonna put my, I'm gonna put this on. See if I can get that. Hang on one second.
Thank you, Joey. Muito obrigado.
Will you interpret? Oh, actually, I'm just gonna use this. I'll use this. Yeah.
Bom, eu não sei vocês, mas
All right. I don't know about you, but I find this theme fascinating. This is something that, those of you who's already had the opportunity to do a course in usability or go deep into this topic, you will understand how this is essential for the development of a project. I tend to say that usability is as important as any other development, performance, or research. But I, particularly 8 years ago, had the opportunity to do a course on usability here in Brazil. We've had 2 Canadian experts coming over to the course. Maybe Joe knows them. And we've had a 2-week course that was extremely fruitful. And with that, I would like to, let you know, for those of you that don't know yet, Brazil has some usability labs that are very well rated. Even, for those watching us online that do not know, or maybe the domestic industry, the university in the city of Itajubá with Professor José Alberto has a very well-rated lab. So if you have the opportunity to visit it, there's other lab in the Catholic University in Rio Grande do Sul. And when we take one of those courses and see a simulation of a medical device, then you understand, even though a project developer is there cracking up codes and trying to create a product that does not have any error for the user, once they develop that and go to the simulation phase with a nurse, for example, they will identify an error. And that is, certain that will happen. I'm not sure if any of you had the opportunity of, writing an article on that. Or actually, when you're writing an article, you're reviewing that document, and then you think everything's fine, but when you give it to someone else to read, they will always identify an error. It could be a typo or something else. And that's, the same with usability. Even though engineers and manufacturers are developing the product and know all the aspects of the product, once you move that to a third person to use it, then that third person will have a different view. Human beings are different, right? And that's what's fascinating about usability for me. ANVISA has been working with this normative for a while now. We have just reviewed our resolution on medical devices in 2022. We have the RDC 751, where we included as mandatory the use of the item on usability in human factors, and that's already mandatory for electromedical devices. It also has other requirements on usability and also Regulation 6266. And it's important to mention that we consider those standards on process and not standards of product, meaning that it's a standard with which you develop your project, but it's not a standard where you conduct fail and pass tests. So you develop those products through studies and concepts. So it's really fascinating for me. Okay, so moving on to questions. I will start by asking the first question, and then we will open up for the audience. So, Joe, my question is actually regarding the cycle of evaluation of the usability of a piece of equipment. We know that the usability evaluation does not end once you finalize your project and put the product to production. It's essential for you to continuously evaluate the usability, especially when the product is already launched in the market. So I would like to know if you can mention a concrete example or a product in robotics where you perceived a need after the product was launched into the market, and then something had to be changed or modified regarding usability. Do you have anything on that, an example?
Yeah, so good question. I probably, for maybe legal reasons, wouldn't disclose exact, I'm not going to get into our complaint handling for our company. But I can tell you that in our summative validation testing, we had instances in the workflows where we did not see use errors simply because we got lucky, maybe is a good way to put it, where they went through the workflow, none of the participants in our study made any use errors. And then when we got into the market and they started using the device on actual humans who were alive, not my mannequin that they're not going to kill, they behaved a little differently, right? There was a different level of risk where they're like, you know what? I can't make this mistake. And it seemed like they maybe got concerned or maybe had a little bit more reservation about what they needed to do, and then they made mistakes. So we did notice an uptick in use errors in the market after we launched that had issues that we didn't see in validation. That is why human factors is required to be part of your complaint handling, because we would look at the use errors that were coming in and we go, we didn't see this in validation. Why is this happening? Right? And then we would have to go do investigations. So that is unfortunately a common thing that happens, because when we do our validation, it's simulated, right? There's no actual patient that's going to die if they make a mistake. So their behavior changes when they get into the real world and the patient's life is at stake, and they start to maybe question, and they get a little, oh, is this the right thing? What do I need to do here? And so that becomes part of the problem. Yeah. So that is true. Unfortunately, that happens. And again, that's why we're involved.
Thank you.
All right, thank you. So we have some questions coming in from people watching us online. First question is, considering anthropometrics and culture, and thinking about a Japanese surgeon, for example, and a Viking, for example, what are the main challenges when you think about developing a product of intensive control?
Yeah, you mentioned Japanese anthropometrics. That's an interesting one, because the Japanese are the shortest population on Earth, and I believe the Dutch are the tallest. So, if you take into consideration the shortest 5th percentile Japanese female, which is, I think, 4'10". Sorry, I'm using English imperial metric. I don't know what it is in meters. but 4'10", and then a Dutch male is 6'3". Is it, so you're talking about a large range. If you evaluate your design for those sizes, you should cover 95% of the world's population. So, but that's a good question because we have to consider all different sizes of human beings, not just Americans.
A segunda pergunta,
Okay, so we have a second question.
assegurar que os
How to make sure that procedures with robotics are integrated in surgical workflows with physicians, anesthesiologists, nurses, without causing interruptions in the process?
I'm not sure I understand the question. Is it you're doing surgery with a robot?
Bom, eu acredito que a pergunta tenha sido no
I
sentido
think so. I think the question is in the sense,
do uso, no fluxo do uso do robô,
in the workflow of use of a robot, the interaction of the doctors and the nurses, if in terms of usability, for example, that is evaluated, because these three healthcare professionals can maybe be using the product. I think that's what the question is about.
Yes. Yes. So when, as I noted in the presentation, when you do validation testing, you have to do it as you would just like in the real world, you have a team, a surgical team that's operating the device. You have to do your testing with surgical teams. So you would evaluate the surgeon and the nurses together, all working as a team to operate the device. And so you have to make sure that you capture those dynamics. An example would be the surgeon is talking to one of the nurses at the bedside, and the nurse can't hear the surgeon because the surgeon's sitting at the surgeon console and the nurse is on the other side of the robot where the patient is. And so maybe that's a consideration in your design, right? Is there some way that they can communicate better with one another? So yes, that team dynamic is critical, and you have to make sure that the workflow is representative of the real world situations in a surgical scenario. That's especially true when there's a patient emergency. Because one of the things we found is like the surgeon, and typically in robotics, the surgeon is not scrubbed. They take off their gown and then they're just sitting in their scrubs. If there's a patient emergency, they get up and they come to the bed and they don't care about scrubbing in at that point because the patient's life is at stake. So those are the kind of like behaviors we watch when we're doing usability testing as a team. Yeah.
Bom, eu vou abrir aqui para o público, se alguém quiser.
Right, so now I would like to open up for questions from the audience. I think we're a little bit over our time, but I think we might squeeze in a couple of questions. Good morning. My name is Fabio Santana. Joe, thank you so much for your presentation. It was a very interesting presentation. It's very well connected with everything about regulation that we need to do. So my question is actually regarding interactions. I work with manufacturing. So a lot of what you say, and because of the characteristics of these pieces of equipment, so electronic controls, servo motors, pneumatics. So we've gone a long way in the industrial area, and that is being put in the OR now. So how much of that length in terms of OQ, PQ, risk management, and all the framework implemented for the industrial area, I wonder if that's being implemented in surgical robotics.
Yes, it is. And I think one of the things that you have to consider is that failures when things like mechanisms and motors and electronics fail in a surgical robotic system, the user is exposed to electrical hazards or mechanical hazards or those sorts of things. So you have to design into the device mechanisms that would prevent the user from being harmed. Again, as I said, the design failure isn't part of use error, but a design failure could still hurt the patient. or hurt the user. And so things like, you know, if you have a short in your electronics, the system has to shut off, right? And so you're going to evaluate in your manufacturing process that all of that is correct and that it was assembled properly and that those mechanisms actually work when the device is in use. If something should go wrong, that it's going to stop or prevent or the user from being exposed to those hazards.
That's IQ, QPQ documents used in the industrial robotics could be helpful to evaluate and to validate the systems?
Yeah, I mean, your IQ, OQ, PQ, you're using that to make sure your manufacturing process is as you've intended, right? And so, yeah, yes, I think it can. Yes, it should be similar, yeah.
Can get the same templates and the analysis, the risk management.
That's correct, yeah. Yep.
Tem mais uma pergunta?
There's another question. Hi, my name is Marcelo from InMetro. My question is a very quick one, actually. So for ergonomics, usability, and human factor analysis, do you believe that this is inside the quality assurance system, or where does it come in the process when you're evaluating quality?
Yeah, so ergonomics, the way it fits into the quality process is that you have to ensure that your risk control measures and the mitigations of your design actually, in relation to ergonomics, is that any mistakes you would have made in designing the ergonomics of the device don't contribute to harmful use errors. So in that regard, yes, absolutely, it would be part of your quality system. If not, you know, it's kind of on the fence. If I have a button, you know, that someone is uncomfortable pushing, but they're still able to activate it, and the pushing of that button, whether I push it or not, has no impact on patient safety, probably not. But if it's something like the ergonomics of the surgeon console, where the surgeon is sitting here for 6 hours doing surgery and, you know, their arm starts to hurt, or one of the things the FDA asked us about was we have a 3D system, as our competitors do, and they wanted to know if you could turn that 3D system off, because if people got headaches or, you know, got dizzy from the 3D, right? Those are questions where they're asking us, like, did you consider as part of your risk profile that people could be uncomfortable in a way that could make them perform differently than you would expect them to? That's an example of where it could be part of that.
Bom dia.
Good morning, I'm Marcia from ANVISA. Congratulations on your presentation, it was amazing. And talking about the IEC that is applicable for a usability evaluation, today in the methodology, everything that is in the regulation and the standard. So in your opinion, is there a need to change or adapt, considering the numbers of equipments that have been getting into the market, modifications, updates, so the innovation that has been surfacing? Do you understand that today the regulation or standard is in accordance with everything? Or should they have a kind of modification to include new parameters, new criteria, or change the methodology? That's my question.
My short answer is no. And the reason that my answer is no is because 62366 doesn't address design. It addresses a process for executing human factors, no matter what the medical device is. So in that regard, it seems pretty straightforward, and it's pretty accurate into the types of activities that we need to do to make sure that devices are designed safely. So I would say in that regard, no. If you're talking about things like, are we addressing the differences in different kinds of medical devices and the risks that those pose, I don't think 62366 is the place for that. I do have an opinion about the proliferation of these different devices that all have different interfaces and all work differently. I think that there may be a world where If you can imagine that we all drove cars and every car had a gas pedal in a different place, right? Or the brake pedal was in a different place than the gas pedal in every car from car to car. I see that being more of a problem in the future than really the guidance for doing human factors, I think is good as it is. But when we talk about other safety-related issues related to the user interfaces, that might be something that regulators might want to start looking at and addressing in the future. I can give you one very quick example. 60601, IEC 60601, has a standard in it that says all alarms on all medical devices must sound exactly the same. Everybody knows that bump, 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 right? You know that sound, right? Every medical device that has a high-level alarm sounds like that. There's a reason for that, because if everybody made a medical device where those all sounded different, and you had critical alarms on things, nobody would know what any of that means, right? So that's where I see maybe some headway that we could make in the industry about, looking at interfaces and making them more common in some ways. But as far as the process goes, no, I think the process is good. Thank you.
Ok. Obrigado.
Thank you so much. We've gone over time a little bit, so I would like to thank you, Joe. Thank you so much for your presentation. It was a very, very helpful. You brought light to a lot of issues. We learned a lot from you today. So thank you again for being here and participating. Thank you, everyone, and we'll continue with the event. Thank you.
Também agradecemos a
We would also
Juliane.
like to extend our thanks to Juliano Tesser and Joe Cisa for this panel. I would like to remind you that on our online app, we have over 100 people following this event on Zoom. What we're going to talk about now is design control in robotics, innovation and safety in harmony. To lead the panel, I will invite Francisco Iran Cartacho Barbosa. He's a specialist in the G-Quip area of ANVISA. Welcome once again.
A nossa conversa online.
Now we will have an online conversation with John Olkowski. He's the Senior Manager Quality Engineer at Johnson & Johnson. Thank you so much for coming and welcome, John.
Thank you for having me at your event. It's a pleasure to be here.
Ok, passo a palavra agora.
Okay, now we go over to Francisco Barbosa. Good morning, everyone. My name is Francisco. I work at ANVISA in the area of medical device regulation. I'm a mechanical engineer by education. I specialize in software as medical device regulation. I have online with me John Olkowski. Olkowski, Senior Manager Quality Engineering at Johnson & Johnson, and he is responsible for leading the implementation of the VELIS robotic surgery device. So John, you have the floor. Welcome.
Thank you very much for having me. I'm going to talk to you today about design controls and how they are the same and different from other medical devices and how we implement and apply applicable standards throughout the industry and the world. I'm going to share my screen. Please let me know if you can see it.
We had a scene.
Wonderful. So the history of design control around the world has been an evolution over the last 40 or 50 years as we've gone through the Code of Federal regulation in the United States and different standards throughout Europe, Brazil, Japan, China, all over the world. We've launched different standards, and these standards are very similar to one another. I think we've really rallied around a lot of the same points in design control. And these things have evolved out of the aerospace and the automotive industries for medical devices, and they continue to be heavily applicable to what we do. There's a very famous graph that you'll see throughout some of my presentation in the bottom left of the screen, which is relating the requirements of traceability of validation, verification, design inputs, outputs, and how that relates to your process as you develop a medical device. The standards between the United States and Europe read very similarly. There were slight differences in them, and the FDA actually recently made a change to even come even closer to the standard language. And we apply this essentially with very little change throughout the world in different places. We apply many different regulatory standards on top of this. And as part of our process, we look at applicable standards. So when we have a design and development plan, we'll come in as part of one of the first regulations in design control is have planning as part of your design. What has happened is we've evolved the industry. The first things that launched in the industry that were classified as medical devices were implants. And then slowly we began to reclassify instruments as medical devices. We've evolved what we've classified under those regulations. We've started applying new materials such as plastics, and eventually we started to launch surgical robotics in the 90s. And into today, we continue to evolve with cobots such as the VELOS system and full robotic systems that act as a robot would with oversight from our medical partners and practitioners. All of these things lead to increasing complexity in the device, and all these things still rely on the same thing for their design controls. They have user needs, they have inputs to the medical device, and they have outputs of what they are. We need to verify and validate them the same way. But what gets more interesting is how critical those things are and the interfaces that they have beyond just mechanical devices. These are electromechanical devices, and there's integrated software and firmware in these devices. Everything needs to work in harmony. And without that, you cannot have a successful system, can't have a successful surgery. Overlaid on top of all of this, all these risks that we normally inhibit in a clinical situation, we have cybersecurity risks, which has become a major push in the industry from regulators as well as from private industry. There's been a huge notice, not just in medical device and pharmaceuticals, but cybersecurity of any device. In the Internet of Things and the Internet of Medical Things, cybersecurity has been very apparent in hospitals, and it drives into our design cycle as well. On top of this, we have environmental regulations that apply much more significantly to electromechanical devices, including capital equipment and robotics, than they normally would to metal and plastic devices. So these are RoHS REACH, Prop 65, and other standards around the world related to the waste stream and different biocompatibility elements of restricted substances. As our last presenter, Joe from Medtronic, just presented, 60601 is a driving force in these standards. It also goes into usability. 60601 covers usability. It points a lot to 62366, but it also has standards for risk management overall. It relates many different things. There is a 80601-2-77, which is applicable to robotics in particular. What I'm going to go through are three major pillars. What I would say are important to the design controls is requirements traceability, so applying the design controls. So how I'm going to go through that is go through a simple way. We'll go through the FDA standards, and then we'll go through risk management, and then we'll have a short session on project management and how that is slightly different. So how we do business has changed as we apply surgical robotics. So, like I said, design and development planning is the first regulation in the CFR. I'm not going to read each of these statements to you, but what is important here is the number of interfaces in this planning in a robotic device and capital equipment is significantly different and more complicated than traditional implants or instruments. There are many more interfaces that need to be planned for that require different specialities in how we work on these things and plan for them. We need systems engineers, we need mechanical engineers, we need software engineers and biomedical engineers. We need tons of different people that need to work in harmony. And we need to plan for all that. We need to resource these things across the development cycles. We need to make sure that our processes are in place to make sure that all these things launch. And then when we get into the project management side, we need to make sure not only these things are funded, but they're operating in an efficient way and at the right timeline to move with each other. One thing I won't get into a lot, but is happening at the same time with all of this is the supply chain, which is also significantly more complex than you would see in a standard machinery for medical devices. In our design inputs, we have some quotes from the FDA guidance here in the top right, with design inputs being the most important design control activity that you'll come across as you design your devices. And this single phase of your project may consume as much as 30% of the time in the entire project, including building long lead time devices and testing them, as well as going through the usability testing and all of the different things that are very important and critical. But if you don't have the right requirements down, you didn't make the right device. You'll find that later in time, and you'll make a lot of design loops if you do this incorrectly. Making inputs that are smart is extremely important. A good design input will have three major characteristics. It's necessary, verifiable, and attainable. If you don't have all three of these things, you'll result in having, if you miss the attainable, for example, you'll never arrive at your project. You're not going to be able to create what you set out to do. If you're not able to verify your design inputs, you're not going to get past your verification stage. You will fail your testing. It will result in design loops. And if it's not necessary, you're going to add cost to your device because you have added features that were never meant to be there. What's very interesting about robotics is how many more conflicting requirements you may have. We have lots of requirements on the mechanical and electromechanical side that you need to work with your patient or your user to work on the in the field with the patient. And you need these devices to house electromechanical equipment. You need to carry signals across cabling. They need to be generated from PCBAs. You need to do all this stuff while having, for example, a small footprint in your operating room. And the more safety boards you have, the more cables that you have to generate and throw these signals around, the more operating room footprint you're doing. So these things conflict with each other. You need to come up with creative designs that are able to tackle these conflicting requirements. And all these need to also meet the necessary, verifiable, and attainable piece. So if you come up with a very slick design to save space, it still needs to be attainable. So you may come up with something very futuristic, but it may be too far ahead of time, or it might be 10 years away and you need to launch in a much quicker time frame. In this design input phase, one thing that we are new at, which is a very big thing for the industry, is designing for service and repair. Traditional implants and instruments are designed for inspection and manufacturing. We're very used to creating the number of devices we need so we can get them out to patients in time, so we can keep people moving. In that, if they're not manufacturable, you're not going to meet your yield requirements. You're going to have quality issues in the line that can result in non-conformances in time, or in the worst case, if things get out of control from your quality management system in field action and recall. Design for inspection is a very similar thing. If you don't have a device that can inspect it, you're not able to manufacture it in the same rate or inspect it in a good way. It might take you more time. These things all apply to robotics in the same way. We have the same thing for design for service. If you can't service your product in the field, you might have a great working one, but eventually something will break. These things do not last forever, nothing does, but these things are used over and over and over again, and they're incredibly complex. You might know from your phone or your computer, these things wear down. They need to be rebooted sometimes, or a component might fail. If you're not able to service these things, you're not able to fix them. And if you can't do that, you could be throwing away $1 million device potentially because you didn't design the right panels or accesses or things to change out. This is a giant risk to how we design devices, as well as how we operate as a company, and our customer satisfaction and the hospital's operating costs as well. They can't use these robots if once they break, they can't be fixed. Design outputs are largely the same as what we have in mechanical traditional devices. So not a big delta here compared to what we would have in robotics. Our maybe not huge, our big difference is we have a lot of software output. So I have a short slide on software design controls in 62304, but it's not the focus of this presentation, but these things are happening at the same time. You need to run your software to work with your hardware. Your system needs to have everything come together and be one output. So that's something else to look at as you go through your output phase. The next clause of the CFR is regarding design review. Design review needs to be held. Design review holds the entire process together. Design review makes sure that you are mitigating your risks correctly by cause of independent reviewers. Anyone who is too invested in something can miss sight of something that is maybe obvious to someone else. It also brings experience to go and look at what you need to get done. What we've done at Johnson & Johnson is we have design reviews that are completed throughout phases as part of mandatory design reviews. And we also have ad hoc technical reviews that could be called at any time from across the business. This is very valuable because it can bring insights that we don't normally get. You might bring in experts externally to review parts of your design as well as your documentation. We need to record these results, and we need people. This is what's very important and critical in robotics, is you need expertise in all the areas of the design. Robotics, if you just have someone who comes in with let's say a mechanical engineering background and you have them review software, you're not going to be successful in having a thorough review of what you've done. Same thing in reverse. If you're just reviewing, if you just have a software engineer come and review complicated mechanical and electromechanical designs, it will not be successful. So you might have multiple reviewers. You might have manufacturing reviewers as well. There's lots of things to go through. These design history files can be enormous. One of the project management things I'll touch on is compartmentalization. And you may have multiple reviewers or different reviewers for each compartment of your design history file, depending on the subject. Design verification and validation. So design verification is confirming that you designed what you intended to do. Did you design this device correctly? Does the output meet the input that you set forth? Validation is making sure you made the right device. So did we make this, does this meet all of our users' needs? What we have in the CFR and in the ISOs is essentially that we need to maintain procedures for validating this design, and that they need to conform to these user needs. There is guidance around user needs, but that interpretation I've seen vary a bit across the industry. One of the things we've been doing and taking a lot of care at is a wider definition of who our users are, because there's not always one user. There are multiple users of your device. And in robotics, especially, you have scrub techs, you have biomedical engineers, you have the surgeons, you have many different interactions. You have service engineers that use your device to get it up to speed. You have many things that come together to make this appropriate, and you're going to want to validate each and every one of those things to make sure that you have the correct device to go to market. On the design transfer requirement, this is the short and sweet requirement from the FDA. You need to maintain procedures to ensure the device is correctly translated into the product specifications. This short one sentence results in countless hours of work as we go through our design transfer processes in what is a very complicated electronic supply chain. One of the things that is very complicated for us and across the industry is in electronics, it's largely a consumer field. So there are medical targeted electronics. They're not always what you would want to use or is required for an element of your design. Some robotics or things may not be medical devices or classified as those things. It's a very high volume industry. There's a lot of consumer electronics out there. They sell millions and millions of devices. And surgical robotics are low volume devices by design. There's only a limited number of hospitals in the world that can afford a surgical robot. And procuring devices like that, we saw throughout COVID, became very difficult. It shut down the automotive industry a few years ago, and it can really drive into your overall project. So making sure you have the right supply chain set up for your design transfer phase is very critical. Another thing that you're going to want as some of your inputs is possibly having requirements into the obsolescence of your devices. So electronic components get phased out over time. They don't last forever. This creates a lot of complexity in our transfer phase because we may want to have backup components. And you can't just qualify and transfer a single one like a main component. You want to make sure that everything that's possible to use in that device works to the specifications as per the regulations. So having all these backups requires extra work, requires extra certs for your RoHS and REACH, a lot to do on design transfer. Computer system validations and complicated tests for in-process and final inspection also drive a lot of project time. Robots are complicated. Robots that check robots are also complicated. So we have a lot of test methods to ensure that our things are working properly. It's like an assembly line in a lot of ways. And those things can be very heavy on resources to make sure that they meet the regulations and they get out the door properly. I touched on this a little bit about design changes. So this is the same as all medical devices. However, some electronic components have short lives, and this creates an increase in the change volume that you may have as you go through obsolescence of your devices. So same requirements, just more of them. Also, your interaction basis goes up. So as you close out one component, you're not just looking necessarily at the components it touches or mates with. You're looking at everything in the entire architecture that this component might interact with. So a cable may interact with a PCBA, which launches a system, which carries a firmware, and you have to look at all of these different things. And these may be different experts. They may be working at different companies. And because of the different expertise that you need to design these devices, which creates even more complexity in how we assess design changes. Design history file, the only complexity here is the number of them that you may need to create one design history file for your system. This is the overview of the requirements traceability matrix. So this is the essentially mechanism we use to capture user needs, design inputs, design verification, and validation. We like to do it in an ALM. So in this way, we have traceability throughout the device. We know which inputs trace where, and it's interactive. Traditionally, we've used Excel files for this task, and we're looking to get a little further along with how the tools that we use on an RTM, but they serve the same function. So you're making sure these things trace through, and you can keep track of these and make sure they're all fulfilled and you meet all the requirements of the standards. These things all go through the design control process. As I said earlier, your early phases consume a huge amount of your planning. Partners in the field and with our users. We find all the appropriate applicable standards. We create those design inputs. That takes a lot of time, as we discussed. This goes through, and then we go through our gates. We go through phase 2, make our outputs, make all our CAD drawings, make all of our Gerber files for our PCBAs, make I'm sorry, is there a question in Portuguese?
John, I believe that we are having some problems with your audio. Can you go back a few minutes, a few moments to explain again?
Can you hear me?
I just heard you.
See? I'm sorry, if there was a question, I need it translated to English.
No, there is no question, just that we lost your audio for a few moments. I believe you can proceed if you are ready.
Hello?
John, I'm not sure if you can hear the room. Can you hear me?
I can hear you, Catherine.
Okay, so what he's saying in the conference room is that they lost your audio.
I hear the room, but not the translator.
Ah, okay. I'm hearing it in English. So basically what they lost your audio for a few minutes. They were wondering if you can go back to the slide deck, maybe 1 or 2 slides. And then present, just repeat the last few slides that you presented.
Okay. From here?
I would say
We are
from
not seeing your screen.
I would say from slide 15.
Yes, from here.
From here.
Yeah. So from here, we move on to through the phase process. And in this, we go through design verification and validation. As our previous presenter brought up, a large part of our validation is also hand in hand with our usability process. Usability is throughout the design. Early in prototyping, we will use formative usability studies to drive design inputs, drive that through our process according to 62366 and through our risk management process as well. Of that, we'll need to complete it in our validation phase to make sure that all of our users are able to meet all of their needs, which include ergonomics. Our final phase of the projects, as we go through design controls, is related to design transfer and process verification to make sure that our supply chain is up and running and we meet all of the transfer of the product specifications for the standard. At the same time as all of this, we are going through the software lifecycle process. 62304 goes through this in a V pattern between requirements of the system, software, and design as we go through coding, review, integration testing, and finally system verification testing. All of this passes through in the system. It'll go through there, but it needs to be completed on the software side before it goes over to the system. Requirements need to flow between the system and the software. Inputs need to be created that match the system's requirements, and they need to be hand in hand with our electromechanical hardware. If you don't have the right processing power to run your software, or if you can't run Windows or Linux or whichever system that you're doing on the hardware that you created, if you don't have the right design inputs, you will not have a successful launch. If you create software changes that don't match your hardware, this will get picked up via 62304 in your verification and your student integration. All of this needs to work together. It adds complexity to how we do things. It also adds complexity to how software as a medical device or standalone software is done, because it needs to work together with medical devices and robotics that we're creating. All these things are interdependent with each other. I have a lot of acronyms in here. Between voice of customer, what we call a target product plan. This is the business process. It's not required by regulation. PM or product map, which is our translation of the steps of a process. The RTM, the requirements of traceability matrix, and the DFMEA. The purpose of this is to show that engineering, business, clinical needs are all being translated together to come through a project. And all these teams need to be communicating across from each other. All of these inputs and outputs need to mesh together. If risks are identified during your testing, they need to go through your risk management system. If risks are identified via the risk management system, they need to be designed out via inputs, potentially in your requirements matrix. They could also be identified via the voice of your customer. Okay, I need my robot to hold a certain force, or do a task, or block out a certain visibility to the user, or provide something to the user. Everything needs to come together to be successful. And it requires many different interactions from many different people and groups. This is how we do our process in a lot of ways. And this is just to convey some of the complexity and moving things across our specifications, which tie together what we're talking about, our design transfer, our risk management, and our design control. These things happen at different times, but they happen together with each other, and it's a web that leads to success of the product to meet all the regulations. All these things need to have flow back and forth to each other as well, because if something's discovered in the design transfer phase, for example, it might lead to an input to change how your device might function, updates the drawings, might require re-verification or validation depending on the extent of the change. Everything needs to flow together. With that, we go through risk management, being a closed loop process. This is happening at the same time as your design control process. You're assessing, controlling, accepting risks, managing them, documenting them, monitoring, and communicating them out. There's flows in here as well, back from post-market surveillance once you do go and launch your product. that can be continually reassessed throughout the life cycle of your product in the field. This is not different than how we do any medical device. The regulations are not different. The big specification that we have out there is 60601-1 and -1-2, which really help us hone in on medical electrical equipment and medical electrical systems. Additional specifications including what's out there today in 14971 on those things. It's in harmony with that standard, but it's hundreds of pages of information about how those things need to do and different requirements that you need to make sure you have the correct MOOPs and MOPs to protect your operator and your patient for your risks being beyond single fault. So your patients and customers are safe. If something does fail, they need to fail safe. So that's all part of designing a successful robot. This is another slide. I'm not going to go through all of it, but it's just to show the risk management process contains lots of documentation. All of these things are serving that purpose above. They are addressing each and every step of the regulation and trying to get at what are your risks, quantifying them, mitigating them as far as possible, and creating a risk management report to assess the risk-benefit analysis of your product. No different than how you would handle any other medical device, just more complicated. Again, very long process. Not going to go through all this eye chart, but it goes to show how many steps you may have to create a successful risk management process. One of the tools that we use extensively across the industry is FMEAs, PFMEAs, DFMEAs, UFMEAs. They're very advantageous because they provide structure in how we mitigate our risks, and they can flow from any hypothetical risk all the way out through how they get mitigated. It is a quantitative device where we will use severities and occurrences to necessarily necessitate risk priorities. The reason that we want to do this is for focus. So all risks need to be mitigated as far as possible, but understanding which risks are the most important for us to attack is necessitated by this. As recognized by the regulators, there's no way to make a device that is risk-free. What we can do is mitigate those risks as far as we possibly can. Every risk must be mitigated, and that is identified and foreseeable. In that, you have the opportunity to create different scales of how these risks are handled. There's other tools to use, but FEMA is a very popular one. One of our flows for how to create a FEMA is with a product map. So this is like a flow chart of the steps, the inputs, outputs of those steps, expectations of the customer at each of the steps, and then what could go wrong at those steps. What's the clinical event should those things go wrong? Linking of the causes of the failure modes. So at each step, what could go wrong? How does that work? This can get very detailed. This takes dozens and hundreds of hours to complete as you go through a complicated surgery. Same thing with the causes of the failure mode, the occurrence rates, and continuing on through the recommended actions that you might be taking, which could be simulations, might be testing, might be design changes, and might be any number of actions that we can take to mitigate out those risks. So this is an example of what a product map is. I know I referred to it, but it's, let's say, and this is a spinal example. So inserting the implant into the disc space, so an intervertebral disc. That is the step, and then you have certain things that you can control and some things that are noise that you cannot control, and noted here by C and an N. This is the output of that step, and then you go to the next step with the same kind of thing. Doing things step by step, make sure you don't miss anything in your process. There's other ways to do DFMEAs. This is a good way to make sure you have every step of your procedure covered. which gets very important in robotics because steps get very complicated. The number of interactions are very important. Other ways to do them are by risk category or type, material risks, biocompatibility risk, etc. This is we found a very good way to do. I know I'm on time, so I'm going to go to cybersecurity. Cybersecurity is shifting. There's just in the last 10 years, a huge change in what people expect of cybersecurity and what we need to offer. There's also a change in the regulatory landscape for what is required of different countries in what we need to do for cybersecurity and privacy. There's increased requirements. There's more risk. There's a lot of lawsuits around cybersecurity. The risk of data getting out is a threat to the people who have data on those devices, the surgeons and patients, as well as to the company, which doesn't want exposure to those types of things. It's also constantly evolving. New threats evolve all the time. People get better at breaking things. People learn new ways. New innovations are created that are able to go around firewalls or work quicker. This might be a market competitor, but it's not necessarily important to the regulation, but it is important to our design cycles. And then our customers and patients expect it. Like if 8 years ago now, Facebook had Cyberlytical and Anikla, and the trust of that company fell completely based on their risk there. That could happen to any company, and we don't want it to happen to us, and I'm sure our competitors are looking at the same thing. Over the last 10 years, initial guidance had been released, and these things have evolved. You can see huge government regulations being launched across the world. Just in the last year, Japan and Singapore have released new cybersecurity documentation that we need to be compliant to when we launch in those countries or when we're there. These things drive a significant amount of work as well as design changes to meet these regulations. For project management, all of this is happening in phases. The right people need to be applied according to your design and development plan. You need to know what you're committing yourself to, what the opportunity is, what the concept will look like. You need to get the right voice of the customer. You need to have the right amount of money to be successful with your project. And in robotics, that's extremely critical and important because these things are not inexpensive to create. If you don't have funding throughout your project, you're not going to be successful. Design, production readiness. So this is our process. These are not requirements, but this is how J&J at a high level goes through these things. What's important to take away from this is project management and compartmentalization. It's necessary to be successful, but all of these things need to work with each other. So the system needs to house, as a design history file, all of the interactive parts of your robot and your capital equipment. All the risks throughout there need to be communicated to each other and flowed down. And your software, like I said before, your software and your machines need to work together, but you don't have the same people doing that work. There are not many software, electrical engineer, hardware, mechanical engineer gurus who all do the same thing. You have different people doing these things, and it can be very efficient to silo them to work on things and then have communication happen throughout them rather than have one big pile of documents. This gets very complicated for your project management organization or the people who are leading your projects as they try to get everything to come together. If your software is completed with its code, but you don't have hardware yet, you don't have the right things to test it. So you need these things to all flow at the right time. What this leads to is a change in how we do normal project management. This is a change that's happening right now in the industry between traditional waterfall and then also traditional agile or software development processes or Scrum. These things are very different from each other. Waterfall is, like I showed before in design control, you make your requirements, you make your outputs, you design it, you build them, you test them, you verify and validate them, and then you make your specifications and you get them out the door, one after the other. In Agile Scrum, you have requests, you design, build, test, and you do things in very manageable chunks. You have retrospective reviews to make sure that you did the amount of work that you signed up for, what went well, what didn't, and you go through these things. The idea is to be work very quickly, get things out, work on the process as it goes. Full Agile is very difficult in medical device because the amount of verification and documentation is required by 62304, but it is very efficient at developing software. What is happening now is a lot of people are working on a hybrid approach to what needs to get done. So these are Agile Scrum kind of sprints that happen within the structure of a waterfall and have outputs and reviews that are throughout those projects. This requires more effort from a project management organization, but it does result in faster development and deployment of robotics. So it's a really very cool innovation in how we manage our projects. This is more of a business process than a regulatory one, but it's very related to robotics because robotics is really a coming together of our software development processes and our hardware mechanical, electromechanical development processes. And everything needs to work together to have a successful robot that meets all of your regulations and is done without spending $1 billion. So thank you very much. I'll open it up for questions and I hope I can hear you. So I'll stop sharing at the time.
John, muito obrigado por sua apresentação.
I hope you can, John, thank you so much. I hope you can hear me.
Can you hear me?
Me?
Yes, thank you.
Okay. So, então, como primeira pergunta,
So, okay, let's go to the first question. With your experience on the Velis project, I wanted to ask what kind of techniques we can use to implement autonomy, or what do you plan on implementing in the near future to help to optimize the system performance in general, seeking to increase the speed of the robot's actions, precision at superhuman levels during a surgical procedure? And which techniques for project control do you understand are necessary to control those aspects of the project? I don't know if you think the current techniques are appropriate, if we need innovation in this area, or if there is innovation actually in terms of project controls for this specific type of implementation.
Absolutely, thank you. So Velis, TKA for total knee arthroplasty, is a cobot. So it is meant to work in harmony with the surgeon. And that's from the voice of our customers. They do not want a robot that is doing the cutting on its own at super speed. They want to have controlled and measured cutting that's in line with their surgical planning and acquisitions that they want to do for the knee to achieve a well-balanced knee according to the surgeon's specifications. To achieve such a thing, it needs to work at the speed that the surgeon works. It can't be superhuman. It needs to be superhuman in how it interprets the data, how it knows where it is in space. If it needs to turn off and on faster, for example, then a human would be able to stop a saw, which it does. So in these ways, I think these things are very good and meet the needs of the customer. So this goes back to talking about design controls. It's what our customers want is something that works with them. They do not want, and it would fail our user needs and our validation if we had something that was totally automated.
Thank you so much for your answer. We do have another question for you. Creating a parallel with the pharmaceutical industry and the development of new molecules, the development of innovative products such as this, what is the proportion of ideas that are declined due to safety issues that are checked when you start the evaluation of the process?
Thank you for the question. I'm not aware of the rate that pharmaceuticals fail out, but I think it's higher than the rate that ours on the medical device side do. There are lots of ways that projects can fail, whether they don't meet the needs of the user in our early feasibility and voice of customer or usability settings. There are, as I said in the question, possibilities that things are risky. So if a solution is developed, and what we do is we do a lot of early on voice of customer, formative usability labs. We do them in various settings to try to get them as close as the clinical performance could be while being safe. And if risks are identified in those processes that cannot be designed out, so this will go through your risk management process, which starts as soon as you start developing a product. What are your biggest risks? What are the risks of similar devices in the market? This can go into your risk management planning to look at what is the field, what is out there. And as you design those devices and you work through what is your requirements and you identify new risks, it may fail your project. It's absolutely an outcome that has happened and happens across the industry. It's not the most common cause of failing a project. We're very good at mitigating risks with design changes, which is a lot harder in pharmaceuticals when it basically changes your entire product if you change your molecule.
Thank you so much. Do you have any questions here in the audience, guys? Those were from the online viewers. Okay, so I'm going to ask my own questions then, because I have some. I was wondering if, of course, you can tell me, what are some of the redundant security systems that are implemented to minimize failures and protect patients from harm during a surgical procedure using this kind of technology?
Absolutely. So redundancies are built into the electronics, for example. So if something shorts, we have redundancies in a lot of the way that things are wired in that they would not fail and hurt a user or a patient, for example. We also have redundancies in safety signals that may, depending on the risk level. So this all goes through our risk process and design inputs that we might need to say. So if the risk is not at a level that is acceptable, if something should fail in a single order, we would introduce backups. So depending on the device, you may have multiple levels of redundancy, and depending on the severity of the risk. The severity of those risks will change depending on the clinical setting of your device. So if you are doing neurological surgery, your risks are very different than if you're doing orthopedic surgery, and they're very different than when you're doing general surgery. So you may have more or less risk mitigations and redundancies built into your device depending on the clinical application.
Muito obrigado. Uma última pergunta. Como são estabelecidos procedimentos?
So next question is, how are established the procedures to monitor the system during the surgery and respond to any adverse event in a quickly manner? So how do you build that procedure to monitor the system while the operation is ongoing?
So it depends on your device. So different robotics have different applications that may require monitoring as a risk mitigation or may not. In some devices, you don't have live monitoring. In some devices that you would have certain signals that are being monitored. So, for example, on navigated surgeries and navigated robotics, if in a cutting plane or in a drilling plane, if you are outside of the intended cutting area of, let's say, a burr or a saw, the robot is monitoring itself to make sure that it's where it's intended to be. So these are achieved generally through navigated instruments in infrared or near infrared. There's a shift now, and as we look to markerless solutions to save operating room efficiencies. But generally what is happening is the oversight is on the robot to make sure safety is achieved. And a big balance here is in usability, because you do not want an overreactive system. So one of the things that's happening right now around the world is we have a lot of cars that are coming out with self-driving systems. They're coming out with adaptive cruise control or lane assist. And one of the things that drives people against using those at all and any adoption is they don't like when things are fighting against them. So if the car is pulling you in direction that you do not want to drive, you will stop using the feature. And that might be less safe than, because you as a human are fallible, and a fully automatic system from a car potentially could be way safer than you as a human driver. But if you're not willing to use those systems because they're overreactive, then it's not safe. It's not safer because it's not being used. So there's a usability balance to what needs to get calculated into your risk management and to the, and this applies to robotics and medical devices as well in exactly the same way. So we need to be aware of these things in our usability testing, and that process is hand in hand with our risk management process to get it through 62366 and through the design control process.
Muito obrigado, John, pela sua resposta.
Thank you so much, John. I don't think we have any other questions in our audience. So thank you so much again for participating in our event.
Much appreciated. Thank you, everyone.
Agradecemos a Francisco Irã
So thank you, John Okowski and Francisco Cartaxo. We apologize for our technical issues since this is a live event transmitted online. Sometimes we are subject to these issues. So now we are moving on to ER, VR, and digital twins in medical education. So I would like to invite Cristina Quimelo to be the moderator of this panel. So Cristina Quimelo is a specialist with ANVISA. Thank you so much for being here. And online, we have Catherine Demaray. She's a Senior Director of U.S. Education with Johnson & Johnson. Thank you so much and good morning. Thank you for being here.
Good morning.
Catherine, consegue? Ok. Passo a palavra agora à nossa moderadora.
So I give the floor to our moderator. Good morning. My name is Cristina. I'm an expert in regulation with ANVISA. We evaluate equipment in the pre-market phase.
I'm going to present you. Catherine Desmorais is the Senior Director of Global Education for Johnson & Johnson's MedTech Joint Reconstruction Business. In this role, she leads the global strategy and delivery of world-class education for Johnson & Johnson arthroplasty and robotics platforms. Catherine has a doctorate in education from Vanderbilt University, where she researched leveraging education technology to improve patients' outcomes in low-resource settings. And Catherine is in Boston, Massachusetts. Okay, Catherine, are you ready?
Wonderful, thank you. Can you hear me in the room and online?
Yeah.
Yes, okay, wonderful. My name is Catherine Damaris, and I'm the Senior Director of Global Education for Joint Reconstruction and Robotically Enabled Arthroplasty Surgery at Johnson & Johnson. I'm pleased to be here with you today to speak about the new model for robotics medical education. It is a very exciting space. So what are we going to cover today? Our agenda has 4 topics. The first, do we lead in this new world or do we chase? The field of robotically enabled procedures has grown exponentially in the past 10 years, and not just in the arthroplasty space. We can be leaders in this new frontier, or we can be followers. The growing trends in technology are filled with opportunity, but they also represent change. We're also going to talk about what does it mean to lead in this new world. The way education has always looked has changed, and so our goals have changed too. What exactly is the new goal? And once we define that goal, how do we reimagine what medical education looks like in order to achieve our new goal? Here, we'll spend some time looking at a few examples and some real-world experiences. And then lastly, is this new way of educating working? Are we achieving what we even set out to accomplish? Robotically enabled surgery has permeated nearly every discipline of medicine, and it's here to stay. So whether you're a scholar, a practitioner, or an industry partner, we can either lead or we can follow. But one thing is absolutely for sure, and that is technology in medicine will only continue to grow more and more prevalent and mainstream. A recent study from the Journal of the American Academy of Orthopedic Surgeons states that within 5 short years, 50% of total knee arthroplasty cases are expected to be done robotically. With the trend clear, we have to acknowledge that the learning curve is different. Yes, it's steep, but the good news is that the robotics learning curve is well studied, and it's also well understood. In addition to volumes of scientific evidence on patient outcomes, there's also a growing body of academic literature focused specifically on how surgeons learn robotics. Industry and academia have made significant advances in education technology experiences to help learners overcome this learning curve and reduce their time to mastery. In good news, when you consider robotically enabled procedures, the learning curve, while real, is the last thing that should be a barrier to adoption. So, what is this new goal? It can be summarized in one thing: accelerating time to mastery. When surgeons accelerate their time to mastery, they get to where they want to be faster. And the very first place they want to be is improved patient safety. Whether that's reduced complications, reduced revision rates, reduced infection, whatever that looks like, it's about patient safety. It also means optimizing patient outcomes. So in the case of orthopedics, this means less pain, restored function, and getting patients back to moving. And finally, accelerating time to mastery means getting to increased efficiency and lower costs faster. Accelerating through the learning curve and getting over to the other side to mastery faster is the key that unlocks every other benefit of robotically enabled surgery. Okay, so you might be saying to yourself, great, let's accelerate learner time to mastery, but how are we going to do that? Well, firstly, let's acknowledge that what has made us successful in the past isn't necessarily what's going to get us where we want to be in the future. Let's take the good from the traditional medical education models and build on it. Let's turn from looking at education as a one-time event and start to consider education as a custom, personalized journey or pathway. Remember, when we're educating adults, we want to meet the learner where they are. And each learner, each adult learner, is starting from their own unique background of experience. Learners are not one size fits all, and their education pathways shouldn't be either. Let's also involve the entire care team in the education journey. Medicine is a team-based discipline, and involving the entire team isn't a luxury, it's a necessity. Everyone who impacts patient care has an opportunity to learn and to contribute. And then lastly, let's consider a multifaceted approach to education. No more one size fits all. The new world of education technology is about a 360-degree offering of experiences to learn and to master. As I've mentioned, the learning curve is real, and that's true, but it's not impossible. One study from the archives of orthopedic and trauma surgery, researchers found that once surgeons reached 11 total knee arthroplasty cases robotically, the learning curve specific to using robotics in the procedure versus an entirely manual procedure was over. In other words, after 11 cases, the robotic surgery times are similar to those for the conventional manual technique. Now, this is just one study and one endpoint, but there is a body of academic literature across medical disciplines filled with other examples. The findings of this study stand to reason. As with anything you learn to do, whether it's learning a new language, cooking a complicated recipe, or trying out a new hobby, the more you practice, the more you do the work of trying, the better and more efficient you get. Does the old model still apply? We can all remember the old expression of see one, do one, teach one as the gold standard of medical education. Does it still hold true? Well, the answer isn't as simple as yes or no. It's yes and. Yes, observing a procedure, doing a procedure, and teaching others about a procedure are valuable parts of learning. But in today's new education technology world, it's a little more nuanced, a little more complex. Now more than ever, we have the technology to adapt learning journeys to the adult learner. We have the ability to take their unique backgrounds and experiences and build on them. Now more than ever, we have the ability to harness the power of technology to create something personalized and something individualized. Let's imagine for a minute that we're going to teach a group of 4 people how to bake a cake. Are they all starting from the same place of knowledge and experience? Not really. Maybe one person in our class grew up baking with their grandmother. They know about mixing ingredients to achieve the perfect texture and the perfect flavor. Now, maybe our second student has a background as an artist. They're a painter and a sculptor. They know how to use icing to make the most beautiful decorations. They can decorate cakes so beautifully, they'd appear in a magazine. And then we have our third student. Our third student likes to eat cake at parties, but they really love to bake bread. They've never baked a cake. And finally, our final student worked in a bakery for 10 years. Every day, they order the sugar and the flour for the bakery. They make sure the bakery has mixing bowls and cake pans, and they even clean up after everyone has finished baking, but they don't actually bake cakes. If we're going to teach this group of students how to bake a cake, are they all starting from the same place? Definitely not. Like all adult learners, they come to the table with a mix of knowledge and experience. They have skills and strengths in some areas and not in others. Our starting places are all varied, but what we do have in common is that we all want to bake a really good cake. We all want to get to mastery. So if we're all starting from different points and we all want to get to the same place, mastery, how do we as educators design a way to teach everyone? And that's where the personalized learning journey comes in. Leveraging the power of AI, we can develop some very simple questions that we use to create an algorithm to craft a learning journey to meet the adult learner where they are, to incorporate their previous experience and provide them with tailor-made options to teach them. I mentioned before that medicine is a team sport. And so before I dive deeper into individualized learning, I really want to acknowledge that we need to educate the entire team. Attendings, the surgeons doing the surgical procedure, are of course the primary focus of these learning journeys, but they're not the only ones. And for that reason, we've leveraged the power of AI to also create learning journeys for residents and for fellows, for OR staff, and even learning experiences for hospital administration who don't need deep clinical knowledge, but have to make important decisions about acquiring new technology for their institutions. Each of these people play a critical role in patient safety, patient outcomes, and in cost-effective, efficient care. The key is providing each individual the right amount and type of information to help them master their role. So what exactly does a personalized learning journey look like at J&J? Here's an example from our robotic assisted solution. You can see we have 4 different surgeon types and an OR team. With a few simple questions, we can design a pathway for each learner. Take surgeon 1, for example. This surgeon doesn't have any experience with our implant or with robotics technology. So we design a pathway to help them acquire foundational knowledge about our knee implant. We take some time to talk about the theories behind navigation and knee alignment philosophies. We also spend a good amount of time imparting knowledge about the hardware of the robotics solution, and of course, the software that powers the robot. Next, we give them the opportunity to engage in a variety of hands-on experiences to build their skills. And this is a mix. It's digital hands-on and cadaveric hands-on. We want to help these surgeons develop confidence in their abilities. Maybe we offer them a preceptorship to observe an experienced surgeon, or a digital interactive resource guide. This is all in preparation for their first surgery. Finally, after they're working their way through the learning curve and they're on their way, we help them focus on mastering the procedure. This could be through more advanced alignment content, engaging in a proctorship, or joining our community of other users. You can see here, we have other surgeon types built out with other starting points. The starting point isn't what's important. Getting to mastery is what's important. And these customized learning journeys are how we accomplish that. So at J&J, this personalized approach is powered by the Johnson & Johnson Institute. Here, we offer learners a single place to find a seamless blend of digital content through online modules, access to webinars from world-class faculty, opportunities to engage in preceptorships or telementoring. We offer nursing and OR staff training experiences, software simulators that allow the entire care team to engage with robotic software from the comfort of their office or their home. We offer augmented and virtual reality experiences so that learners can explore hardware, but also procedural flow through virtual reality. And then finally, we offer ways to access valuable in-person bone model or cadaveric hands-on training. Is it working? That's a key question. And the answer is yes, it is working. We launched a robotic assisted solution for knee arthroplasty about 3 or 4 years ago in the US. In that time, we've learned a lot and have adjusted our approach along the way to better meet the needs of our learners. And we're constantly measuring ourselves to see how we're doing. So if you look on the left side of the screen, we asked US robotics users what event category most improved their comfort level with our robotic technology. And the overwhelming majority cited their education experiences as the most important component. If you look on the right side of the screen, Just last month, we asked some of our European users which modality they would be likely to use following their hands-on cadaveric training. And amongst all of the digital offerings, the software simulator ranked the highest. The good news here is that thanks to this personalized approach, powered by the Johnson & Johnson Institute, learners have the ability to go back and revisit all types of content and learning experiences for what they need on any given day. To end, is it possible to get to mastery in robotics? Absolutely. Yes, there is a learning curve, but through a personalized approach, we can help learners not only get to mastery, but enjoy the journey while they do it. Thank you so much. I'd like to open it up for questions.
Thank you, Catherine. Eu tenho uma pergunta. Está ouvindo inglês? Ok.
It's not translating yet.
It's not translating?
Está traduzindo?
E agora? Está ouvindo?
Can you hear me now?
Yes.
In English?
Yes.
Okay.
Yep.
Ok. Vou falar em português.
I'm going to
ok?
speak Portuguese if you don't mind.
Okay.
O foco.
So the focus of your presentation is training, medical training, and of course, training the staff and everyone that works with robotics. But I wanted to ask a question about if you feel, if you have some kind of insight that this kind of virtual reality could be maybe overflowed, let's say, in the future or in the near future, for us to be able to do project validation, validation of medical devices, equipment in general, or even for preclinical validation. So instead of using animals, for example, we could use VR. Do you see that as something feasible? And even due to a regulatory issue, do you think that that's possible?
I think anything's possible in the world of education technology. One of the areas I'd like to see more development is in the tactile and the haptics field of virtual reality. Virtual reality is very effective for understanding procedural flow. We also have the ability to collaborate. So I can be sitting in Boston and you sitting in Brazil, we can be in the same virtual operating room. But what is not there for virtual reality yet is the tactile haptic component. So I think maybe someday, but that's not today.
Yes.
Okay, we have a question from a virtual participant. So considering the use of AR, VR, and other advanced techniques for robotic surgery, what are the ethical issues here?
I think data privacy is, of course, one issue that we're very careful about. When we have a software simulator, for example, and we've loaded live patient cases in there to make it as realistic of a learning experience as possible. We, of course, want to be sure that we blind any patient data. So while these are real images, we have the consent of the patient to use them in this setting. We are very, very careful and go to great lengths to make sure that there's nothing that could possibly identify the patient. But like with any technology, I think that there are going to be ethical considerations that come up along the way. It's a constantly evolving, constantly moving field. And as we also realize that as we launch these technologies globally, different markets are going to have different concerns about or different parameters or standards for ethics, for data privacy, for any number of data collection initiatives. So it's right now, I don't see it as a major ethical debate around AR and VR, but it could be in the future.
Yeah. Another question. What is the percentage of the robot surgeries globally in the comparison with the mechanical ones after these 40 years?
Yeah, that's what we're, with our surgery, with our robot in particular, I'm not sure what the exact percentage is, but there was a study in the AAOS journal that expects that within just a few years, the percentage will be 50-50 mechanical versus robotic. And we're starting to see that as residents and fellows come out of med school, residents in particular, they are looking for education on manual procedures because what they've seen at their academic medical center are a whole lot of robotic procedures, but they haven't had as much experience with manual procedures. So it's really flipped. So we are trying to offer a balanced approach to focus on both manual and robotic, but the trend is very clear. And that is that the procedures are going in the direction of robotics.
Okay. Tem alguma pergunta?
Do we have any other questions here from the audience on site?
No? Se não
No
tiver,
questions? Because I do have questions. So if you guys don't, I will ask another one. Okay, so Catherine, you mentioned the base levels of people who are trained. So the starting point, right? Even among surgeons, everyone has their own previous experience before that training. So do you have any kind of evaluation to check parameters and see the starting line for each surgeon? So then you can design the individual personalized training. Do you have a technique for that?
We do. So we ask about five simple questions. And the first question is, do you have experience with our knee implant? Because there's no robot on the market that isn't designed to work with a very specific implant. And so our robot is designed to work with our implant. And we want to know, do you have experience with our implant? If not, that's okay. We can absolutely educate you. We also want to understand what your role is in the operating room. So are you a nurse? Are you an attending? Because that's going to establish whether or not we need to teach you about the sterile drapes or not. We ask a question around your years of experience. We ask a question around prior experience with robotics and also with navigation. Because if you used a competitive system, you have some ideas and you have some experience with navigation in general, and we want to build on that. And so it's really only about 5 or 6 simple questions that allow us to get to a very personalized pathway for each learner.
Okay, great. Thank you so much. There are questions here. Just a minute.
Okay.
Bom dia.
Hi, good morning. My name is Marcia from ANVISA. I wanted to ask you, when we're talking about arthroplasty, we know that we have specific instruments and equipment to do it that are directly associated to the company's implant, like you mentioned. When you think about robotic surgery, do you have this direct association between equipment, the implant, and the procedure? Or does your equipment have the ability of being used to implant another implant from another company? But I want to ask, do you have this connection? Johnson's equipment can only implant Johnson implants, or how does it work? Because I was concerned about that, specifically because it's a robot, it's a huge equipment. How would you work in that situation when you are involving orthopedics that are going to be implanted?
That's an excellent question. Johnson & Johnson's knee implants and robot are designed to be used together. They're studied together and they're validated together. And our software, arguably the most important part of the robotics procedure, is designed to be used with Johnson & Johnson's Attune implant. It cannot be used with a competitive implant.
Thank you.
Questions? No? Okay. Thank you so much, Catherine. It was a great presentation. Thank you so much.
Thank you.
Bye-bye.
Estas foram Cristina Quimelo.
So we
Ana
just had
Torres, Catherine
Christina and Catherine, thank you so much for the information that you provided us with today in this panel. You are watching the first workshop for robotic surgery and artificial intelligence promoted by ABRAIDI and ANVISA. We have as our sponsors Intuitive, Medtronic, Stryker, and Johnson & Johnson. Now we're going to take a quick lunch break. Compared to yesterday, we'll be back in 2 hours. Right now, it's 11:15, so we'll come back at 1:15 p.m.
Muito boa tarde a todos.
Good afternoon, everyone.
A segunda
We
parte
are
do
starting the
primeiro workshop
second part of the
internacional
first
de
international
cirurgia
workshop
robótica e
of
inteligência
robotic surgery and artificial intelligence, sponsored by Intuitive, Medtronic, Stryker, and Johnson & Johnson.
Neste quarto painel,
In our
nós vamos
fourth
abordar a
panel,
questão
we're
da
going to talk about
certificação de equipamentos
certification of
eletromédicos. Para esta
electromedical
conversa, eu chamo aqui
devices.
ao palco como
I'm going to
moderador
invite to
o
the
senhor
stage as a
Geoffrey
moderator,
Moraes,
Mr.
superintendente do
Geoffrey
ABNT
Moraes,
CB
Superintendent
26.
of
Por gentileza,
ABNT
seja muito
CB 26. Welcome.
Obrigado.
Thank you.
Também farão parte
Also joining us on this panel, we have the engineer Marcelo Carvalho from InMetro, engineer Davidson Silva from Anatel,
engenheiro Wilson
engineer
Bonato,
Wilson
da Associação
Bonato from the
Brasileira de
Brazilian
Avaliação da
Association for Conformity
ABRAC.
Assessment, ABRAC,
E também o
and
engenheiro
also engineer Anderson Pereira from ANVISA.
Eu passo a palavra para
Now,
conduzir esse debate, então, ao
let's
senhor
go over
Geoffrey
to
Moraes.
Mr. Geoffrey Moraes to lead this conversation.
Certificação eletromédica, precisa ligar o microfone.
We need to turn on the mic to talk about certification of electromedical equipment. First, I would like to thank ABRAIDI for the invitation. I want to thank Dr. Sergio Madeira that very kindly extended the invitation to us so that we could represent the regulative environment. I also want to thank all the speakers joining me on this panel. The concept for the electromedical certification actually goes beyond the standard environment and conformity assessment. It actually comes from a history of a very robust series of discussions on the regulated sector as well as the regulators, so those who create the standards and those who enforce the regulation, the certification process also. And this is something that actually lasted throughout this whole period where the electromedical certification in Brazil was designed. We've had some very important pillars. ANVISA as the regulatory agency, giving us the rules and dictating what is the correct way of producing each standard. InMetro as a partner that executes the certification process, believing that the certification boards and the labs were all designed so that that person requesting, whether it's a manufacturer or an importer, could at any time request those tests to the labs directly, and afterwards the organ that certifies that product would then evaluate the production line as well as all the tests and the reports that were done during those tests. So it's a very robust process nowadays. It has gotten better through time, and it's actually been taking space thinking about the international environment. And in this process, we have ABNT, which is the entity that actually dictates the rules and sets for the market what are the rules and requirements that this entire process needs to follow. Of course, nothing that is strongly imposed. I usually say that ABNT is an entity where we can see parity and equity in its positions. So manufacturers, importers, as well as labs, organs, the government itself has participated. ANVISA, there's hardly any meeting from the CB26 commissions have ANVISA not present. So CB26 is the Brazilian committee that was assigned to discuss standards and regulations for electromedical devices. ABNT has over 200 technical committees in Brazil, and we have as our structure something around 20 study commissions among the several types of devices and services for the sector that we've been discussing here. Some coordinators are here, some people participate as well. So this is some of the context of ABNT in this certification environment. Just so we can have enough time to discuss and each speaker can say their opinion, I will very quickly invite Marcelo Carvalho. He's from InMetro, responsible for the sector that we're going to discuss today. And I'm going to ask him, are you going to speak from there? Do you want to stand up? Do whatever you feel is best. Hello?
Hello.
Okay. Let me just use the clicker. Oh, we can follow the slides down there. Okay. So firstly, I would like to thank all the organizers, ANVISA and ABRAIDI for this workshop of robotic surgery and AI. And thank you for inviting InMetro for participating. I think that our main point here will be to clear up some questions and mainly have a conversation. But it's also important to present to all of you InMetro, because a lot of you don't know what InMetro is. And actually, our activity with ANVISA is an activity to evaluate conformity. So ANVISA is the regulator under sanitary vigilance, and InMetro through a cooperation term, we are the National Institute of Metrology, Quality and Technology. So we have regulation and rules for safety requirements. These are established to evaluate conformity even on the technical barriers to trade agreement. We have this part also to maintain and spread all the national standards, which are very important for product traceability and etc. We have legal metrology that actually publishes legal regulation with weights, measurements, everything to ensure consumer safety. We have the international area. So we have international articulation, which maintains technical barriers from the World Trade Organization. And we monitor the market in terms of the products that are within our realm. So in this case, we don't have duplicate of action. ANVISA is the regulator, so ANVISA is responsible for product certification and audits, and InMetro actually works with support. This is InMetro. It's an institute located on Serra do Mar, which is very close to the city of Petrópolis. It's a very interesting facility with a lot of labs. And our work with ANVISA is related to a cooperation term, because we either have a function that belongs to us in that case, or through cooperation. In this case, this work is through cooperation. We have 3 terms that determine this work that we do together. So Inmetro supports ANVISA with the structure that we have. We have also agreements with IAC, EAF, and this is very important to make the process of certification in the country easier. So we maintain the organs that are nationally accredited for product certification and several activities in conformity assessment. We have a specific one for electromedical certification, and we have the bodies that evaluate conformity. Besides that, we also evaluate labs so that they follow the same international standards. Considering legal metrology, now connected to our theme, which is electromedical certification, there are two products that, due to the metrology of the institute, it's our own competency. So we have two ordinances that are specific, which is regarding the pressure measurement and also temperature. So products that use these two technologies actually go through the certification of electromedical certification and also Inmetro certification. That is defined in an ordinance where we work together, ANVISA and Inmetro, the Brazilian Association for Conformity Assessment, and other laboratories. The whole society and universities as well have participated, ABNT as well, to create this ordinance that actually does not distort the evaluation of products in Brazil, so that we are all aligned with international practices, allowing therefore that our products can reach other markets and vice versa. So this is an important condition so that, you know, processes do not deviate. The ordinance is also important towards safety. So they are based on ESC's standards. The ordinance is normally published by ANVISA because the standards are always being updated from time to time. So ANVISA sometimes publishes new normative instructions applied to this ordinance. This ordinance provides the scheme of quality assessment. I mean, the step-by-step to obtain the certification for specific products, because ANVISA also regulates and they have their criteria to establish which products have to be certified and others that will only require registration. So basically, our work together with ANVISA is a partnership, really, and our institute receives a lot of consults, so we try to solve, you know, questions from different entities. We have different consults that come to us, and others are actually directly to ANVISA. So with that, thank you very much, and I'm open for questions.
Muito bem. Como parte
All
da
right.
evolução, né, que eu comentei,
So, like I mentioned before,
aguardei para apresentar agora o Davidson Silva.
now I would
da
like to introduce Davidson Silva with Anatel.
Acho que foi boa a tentativa. Então, a Anatel também
So,
regulamento
Anatel is also a regulator
que trata de
and basically deals with equipment that are in a wireless environment.
Então, por favor, Davidson.
So, Davidson, the floor is yours.
Bom, boa tarde a todos. Eu já ia até
Good
comentar
afternoon,
quando o
everyone.
microfone não funcionou, eu falei, ó, não está homologado.
I was just going to say, when you tried to open up the mic and it was not on, I was going to say, well, this is not certified.
Brincadeiras à parte, boa
Well,
tarde
jokes
a todos,
aside,
né?
good afternoon,
Eu
everyone.
sou gerente de certificação da
My name
Anatel,
is Davidson
tá?
Silva. I work with
Como
Anatel.
já foi falado, né, a questão de telecomunicações,
And
né,
just
redes
like
sem fio,
mentioned
serviços de
before,
comunicação
the wireless environment, all these pieces of equipment are part of our daily lives. So we have wireless communication in different environments. So today we have, microwave ovens, we have washing machines, we have all of that that can be commanded by artificial intelligence, like Alexa, for example. So everything is in our lives is basically interconnected through communication. Here we have some medical equipment that you already know. We have electromedical equipment whose functions are interconnected by sensors, interfaces, controls, and storage of information. And information normally gets transmitted. So today you might have a heartbeat monitor and you can transfer that information, and that sensor is connected to the cardiologist system, and the physician is controlling that patient remotely. And here, in summary, we have basically sensors, a control and process of the information, and action, and that is transmitted through electromagnetic waves. And today we have the wearables as well. So we have smart watches, we have, glasses. I wish we had, automatic glasses that would increase or decrease the grade. And that is all done through telecommunication. But what is telecommunication? What are radio frequencies? I had a boss that said that the radioelectric spectrum is something that you cannot see, but it exists. So he used to say that the electromagnetic waves are a physical phenomenon of energy transportation, and this energy transport can allow for communication. And everyone thinks that you can use radio frequency endlessly, but unfortunately not, because the radio frequencies that we use are limited, even when you think that there's an infinite limit. And for example, radio frequencies are like tuning to the radio station. So in a simplified way, you can connect your cell phone to an antenna. It uses a specific radio band, and that's the same for medical devices. And since this is finite, everyone asks me, okay, so for example, in Brazil, you have Anatel, and why am I not able to import a product? Because unfortunately, the frequency bands are not the same. So this illustrates what I'm talking about. Here you see on the map the division of the world by radio frequency. So Brazil is in the same region of the United States and Mexico, but not the same as Europe, for example, and not even in regions like China and Japan and Australia. And there's another complicator. In the same region, you can have countries that use different bands. So that means that if I bring a device from Europe, like a robotic arm to perform a surgery that uses radio frequency communication, if I import that to Brazil, then it's possible that radio frequency is used for another thing, and that arm might stop communicating during surgery. Here's another example that we have during audits. So for example, electronic nannies. You normally have that if you're a parent, you have these baby monitors. but these baby monitors are normally imported from Paraguay. And in turn, in Paraguay, they come from China. And the radio frequencies that they use are the same from cell phones here in Brazil. And sometimes a baby monitor in Brazil, when it used, can drop the radio frequency for cell phones for a whole block. It's, cutting communication from cell phones in the same region here in Brazil. Imagine if someone next to you needs to call an ambulance and your baby monitor is dropping that communication. So that's why Anatel, within other responsibilities, is responsible for managing the radio electric spectrum. So we define the standards and regulations for the use of radio frequency in the country. And in order to guarantee that that product works in the country, we have certification processes, just like in Metro, together with ANVISA. And then you have the electromedical equipment that use these radio frequencies. So this is an overview of the regulatory requirements based on Resolution 715. That's our umbrella resolution. And then we have Resolution 680, because that deals with most of electromedical equipment. It deals with radio frequencies for equipment that we use normally for the medical environment. And then we have the acts that are equivalent to the ordinances from in Metro. And we also have as a reference some international standards like IEC 60950, CISPR 1132 and 35 that are very well known in the certification scenario. So our certification process via Resolution 715 is a process that was simplified. Before that, all Anatel resolutions were approved by the board. So we had sometimes a regulatory process that took, 2-3 years to get approved. And today, with Resolution 715, all our procedures for the operation of certifications are approved by the technical area. Of course, with public consultation. But all that process got streamlined, and we can get approvals in 2 or 3 months. And if it's something urgent, we can do that in even 2 weeks. So this process that we have conducted is very agile. So whenever there's a new technology or a new product that needs a change, we can study that and conduct that very quickly. And that has shown itself to be very efficient. We use traditional models of conformity assessment, certification, conformity statements, and so on. And just like I said, Resolution 715 is a simplification with a risk analysis. And I will make this, this presentation will be available to you as well. And the products that we approve, we have 103 that are approved via certification. And this model is based on the simplification of procedures for a quicker approval. The regulatory political issues may continue to be approved by our board, but technical issues are now approved by the technical department. We also use 3 standard models of certification, Type 1A, Type 4, and Type 5. The process of certification that we have is exemplified in this workflow. For example, a representative of a manufacturer comes to us. They provide the specifications, we conduct tests and assays, and that gets sent to Anatel, and if all is launch the product in the market. Here we have the technical requirements regarding restricted radiation. And what do we have, what have we been working currently? We have already started our activities of evaluation of security for products. So products that went through this process established by Act 77. We have been thinking about including in the labs and certification institutions. We have been studying the impact of AI in telecommunication equipment. We conducted a forum last week, actually, to discuss AI topics. We will also review our certification processes. So from 2019 till today, we've had, 4 or 5 years of tests and evaluations on this model, and we've seen some simplifications that we're able to do. And we also have, new technologies. We just launched 5G in Brazil, but people are talking already, engineers are talking about 6G. So by 2030, we might have 6G available. We are studying the transition of the 2G, 3G systems to 4G. We know that some medical equipment still have 2G, 3G, and we are reviewing Resolution 715. And I would like to highlight one topic here, which is the importance of sealing before importing. So we are reviewing to remove that with Anatel. That was it. Sorry, I just, flew through the presentation because the time was short, but I'm available for any questions that you might have. All right, so Davison, Marcelo, thank you very much. We have already noted that there are some differences between certifications promoted by ANVISA and Anatel. There are different models and periods. So I think we will have, a lot of information to discuss. So now I would like to ask Wilson Bonato, representative of the Brazilian Association for Conformity Assessment, to say his remarks. All right, so on behalf of ABRAC, I would like to thank you all for having me. It's such an important event, and I believe that you have discussed very important aspects for the advancement of technology and then procedures and processes as well. So my name is Wilson Bonato. I'm the technical manager of NCC certifications, part of the Bureau Veritas Group. ABRAC, the Brazilian Association for Conformity Assessment, was founded in 2009 and includes over 70 entities, including certification, inspection, and test institutions, and they represent the majority of products and processes that are certified today, including electromedical equipment. With that, the association gained credibility and trustworthiness, and it's the main connection between different regulating bodies. NCC certifications was founded in 1999. It has important professionals, experts in medical devices. We have over 20 professionals working specifically with that. The NCC certifications is a leader in certification of products, was a pioneer in the IEC certification scheme for explosive atmosphere, and is the first audit organization in Brazil to participate in the MDSAP program in the medical area.
Qual seria, então, no momento aqui, né, falar da importância da certificação?
So, what is the importance of talking about the certification? When we have parameters such as quality, reliability, and product performance, supporting the pillars of safety, environment, and health, the certification is going to bring an amazing and very important value, and it will increase the level of trust from the consumer and the user if it is a medical device that they're using in their practice or hospital. So this is actually a very good mechanism to evaluate conformity. Now talking about digital transformation, you guys seen that a lot in this workshop, but I just wanted to see a quick highlight on SAMD, which is software as a medical device. And the International Forum of Medical Devices, MDRF, defined it as a software that executes functions. However, it is not directly connected to a hardware device. For ANVISA, we have RDC, I'm not sure if that's the correct one though, 657 that talks about the use of software as a medical device and how it should be regulated. So there is a risk classification and a whole analysis done by ANVISA in this RDC that will allow you to use that product. The conformity assessment is very important, as we can see, when we're talking about software as a medical device. But we have some considerations in terms of the software reliability. I'm going to say a few. Failures that happen in software are due to project errors, deficiencies in the development process, and maintenance process as well for the software. So we're going to introduce more failures sometimes during maintenance. There is no wear and tear of software. I can use it, and there's no any kind of wear and tear as the mechanical equipment does. It's impossible to repair it. It's impossible to maintain the reliability. So there's no repair to maintain that reliability, to maintain a level of quality and reliability. The only way to do that with the software is to completely redesign it, removing errors that happen without introducing new errors. Software reliability is not related directly with time. Failures happen because a specific step of the program was executed with an error. So in that case, there's a failure. The external environment doesn't affect this reliability except for when the input data is affected. And reliability cannot be improved with redundancy, like we see in cases of hardware when we can't have two programs in parallel, because if one program fails, the other one will have the same error. The only possibility would be for us to have a program that was written by different developers, analyzed by different people, so that they can actually execute that function. You heard today and yesterday a lot about AI. I'm not going to read everything, but I'm going to just talk about how important it is to have a conformity assessment that is going to make sure you can have safe application, equal application, and efficient application of AI when we are thinking about a healthcare scenario. Something else that's important is remote activities. When we talk about remote surgery, training, technical assistance. So nowadays, this is already a reality to have robotic surgeries from a distance. We saw some examples on our workshop of that very activity. So people use high resolution cameras, all of that, and they're able to from a distance, perform that procedure with the specialist somewhere else in the world and not exactly where the patient is. Trainings and meetings are more economically feasible when we do them online. When the pandemic came, started having meetings online on Teams, on Zoom, or whatever other app, and they kind of stayed and improved. So there's a lot of scenarios where we can use remote communication. And certainly I wrote to remove, to decrease the carbon footprint, because this is an important point when we talk about ESG. Something I can do from a distance is to check and adjust the software. Nowadays, it's common to, work and we have some kind of issue with the machine. We call the technical assistance or IT in our companies. And then through your permission, they're able to go and access your computer remotely. They do whatever needs to be done, delete a program, update, or this or that, and everything comes back to normal. And they can do that off-site, remotely. So in that sense, the conformity assessment is more effective through remote activities. As Davidson said very well, we have Anatel, which is a regulator. So we're saying, oh, let's use remote things, distance remote surgery. Of course, the communication equipment has to be there, otherwise it's not going to work. So Anatel is the regulator for this aspect of the radio electricity, and they certify the projects and products that can use that communication or not. In Metro, as Marcelo also explained, among other activities, it's responsible for managing conformity assessment programs. In Metro nowadays, it's a very important brand for credibility in the products that are certified. I'm a bit older than most of you, actually, and before we would say in Metro certified, it's actually not in Metro certified, but we used to say that. And certainly, it includes medical devices that are regulated by ANVISA, like Marcelo also said. In this context, we created the 384 ordinance that approves the requirements for the conformity assessment for equipments that are under health surveillance. And there is a software evaluation. The software evaluation is already in this ordinance, and it's not yet related to an SAMD, so software as medical device. We could include that also inside the conformity assessment. It brought something very important, which is recognizing MDSAP for the factory audits. MDSAP is the medical device single audit program where 5 regulators see with a lot of challenges said, hey, let's come together and we're going to do something that I'm only going to go to a supplier once, manufacturer once, but I don't have to go there 5 times. The regulators are Australia, Canada, Brazil, through ANVISA, Japan, and the US. And there are others that we call the observers in this context, and they will probably end up migrating to using MDSAP. That was it. Thank you so much for the invitation. Thank you, Wilson. Definitely, the pillar of the conformity assessment really goes beyond the limits so that organisms or entities can always pay attention to what's changing and what are the expectations for new technologies. I think that people will most likely recognize the image of someone in a bathtub with a lot of wires hooked to them. And we're talking about something that was decades ago and how long it took us for them to be able to evolve. And it's the same with past technologies. When we talk about software, we also mentioned here that now we've started creating guidance and requirements for you to evaluate software conformity. And now software is learning on its own, it's walking on its own, upgrading itself. So how do we discuss all of those issues? And we're talking about something that wasn't even 1 decade ago. So these are challenges that we definitely need to discuss in these forums and really make the most of this time. Great. So now Anderson Pereira from ANVISA. He is the equipment manager for ANVISA. Good afternoon, everyone. It's a pleasure to be here today. I would like to thank ABRAIDI for the organization of the event, Marcelo from Metro, Davidson from Anatel, Wilson as well, and Joffrey. We've been friends for a long time. So thank you, everyone. Actually, using what Wilson said about the software resolution, not going into any certification yet, it definitely put out there all the requirements that we needed and we had clear in the standard, and it made it more flexible. Perhaps it's one of the countries that does have this more flexible option changes in terms of bug correction, a functionality that wasn't working properly, something that needed to be corrected, for example. The company has autonomy, of course, since it's a regulated company. That's why you need to have a legal technical person that's responsible. It's a dynamic product because you have a version today and tomorrow you'll have another one to fix a bug. And replacing the software that is already in the market is also a very dynamic action. So we do software uploads to new versions. These changes don't need a protocol in ANVISA. It's different than an equipment that has a technical alteration, then you need to have a protocol for the change. In this case, the company is responsible and they are able to make these corrections as needed as they are so that the software can function as best as it can. So I just wanted to say that first. And even though it's recent, from 2022, it's already being reviewed to actually be able to include items that are being discussed on IMDRF, the Forum of Regulatory Agents, to be able to include the pre-controlled software change program. And as you said, software is learning on its own. How can we regulate it? So let's get started with my part of the presentation. Let's focus on the certification. We have people that don't really know the organization, some people from abroad. They are not aware of how ANVISA works for medical devices, but we have a general management area for health products and medical devices, where we have clinical research coordination, CP Pro. It is a subsidiary and actually helps the equipment areas, which are the management of equipment technology, which I'm a part of, the management of in vitro diagnostic products, and the management of materials, hospital materials. And linked to the management of materials from ANVISA, we have a coordination of orthopedic materials. So a lot of people here know this, but a lot of people that may be here may not know this. In vitro diagnostic programs, so we have the glucometers, lab material in general, the reactive strips, tubes. Recently, there was a publication of a new resolution that is substituted RDC 36 that actually just started now in June 3rd, that it came into effect. and it was a considerable review.
Área de materiais,
Material
tem
area,
todo tipo
so
de
we have every
material.
kind of material.
O que não
um,
foi diagnóstico in vitro, então,
What isn't
equipamento
in
vai
vitro
para
and equipment
materiais.
usually goes to materials. So we have, for example, condoms, syringes,
bolsa de sangue,
blood bags,
e etc.
and all of that.
Odontológico,
Any kind of
lente de
dental
contato,
equipment, contact
válvulas
lenses,
cardíacas,
cardiac valves.
uma infinidade de
So there's a lot
produtos.
of products that are regulated by this
E
area.
alguns desses
And some of these, I'm not going to talk about this in the whole electromedical certification process, but they are a part of certification. So like syringes, breast implants, and others. They are a part of this process, and they also use the conformity assessment. And the equipment part, this goes from an electrocardiogram equipment to a hearing aid, a pacemaker, surgical robots. Everything goes into this category.
Seguindo aqui,
Now,
conforme o Joffre comentou,
as Joffrey said, this conformity assessment program is not new. The first agreement that we had was an ordinance from the health ministry. It was 2043 from 1994. So before ANVISA even existed, there was an agreement with the Ministry of Industry and Commerce, to which InMetro is connected to. There was a revision. I just put the latest, which is 692 ordinance from the year 2009, in which, well, at the time, I wasn't there yet, but the Ministry of Health had a proposal of two options, either setting up a lab and having product testing, and us knowing that there were labs for other products such as tires, toys, lamps, and other kinds of products. There was already a lab, there was already an infrastructure that was used successfully to do the certification process for InMetro, that InMetro was coordinating. So we had this partnership so that we could use the evaluation, the conformity assessment process, using accredited labs and the product certification entities. From there, the system evolved. In 1999, we created ANVISA, so there was the creation of ANVISA. We published the first resolution, which wasn't even called RTC, but RE444 from 1999. We had, I think, 3 labs. One of them was X-ray equipment, if I'm not mistaken. So very few labs were available and very few equipment was certified at the time. This is just a summary of how the system works for conformity assessment. SBAC. ANVISA has a partnership with InMetro, and InMetro is the manager of the program. InMetro accredits or creates a certification for the entities that can certify products. I think we have 17 accredited certifiable entities, and also accredits the labs. I think we have around 30 for different types of standards. So the amount of labs increased, the amount of certified lab organs increased, so that we can get this range that we're going to talk about today on the last normative instruction that has a list of standards that is going to come from the revision of international standards, updates, and the availability of labs in Brazil. So we can't evolve without having labs in Brazil. Here I have, just to illustrate, we talk a lot about certification and thinking about an OR with a surgical robot. What we're looking for, actually, we usually talk about conformity assessment, but what we want is patient safety. That's going to be for the entire medical team around it, and they're going to be operating this equipment that is inside a surgery room, an OR. in the hospital. So imagine if this system didn't have the electromagnetical protection, and then the next room, if they had an electronic scalpel, they wouldn't be able to do that. They wouldn't be able to move it. So the precision that is exactly the focus of these robots, which is, precision, the accuracy of the product, everything would go downhill and patient safety would go with it. So today, we are sure that if you go into an OR or any other hospital environment, of course, if it's not illegal equipment, you can rest assured that the equipment is going to work within its restrictions, of course. There are all the safety protections, electromagnetic compatibility, it will have the correct performance. Exactly. So, okay. So ANVISA has been evolving since Resolution 549, and it has been publishing new reviews like RDC 27, then RDC 32, and now the latest one, which is RDC 549 from 2021, that provides for the process of a mandatory certification of equipment under the health vigilance, not only electrical equipment, but actually mechanical beds, for example, hospital beds, wheelchairs. They are also, subject to certification, even if they are not electromedical equipment. We also have the in Metro Ordinance 384/2020, which replaced RDC 350. Oh, I'm sorry. 54, actually, from 2010. And so this ordinance made some items more flexible because they actually, needed the regulated sector actually demanded that type of flexibilization. Before Ordinance 384, every 5 years, even if there was no change, the equipment had to be retested and recertified. So today, there's no expiration date of 5 years, so you do not need a recertification anymore. However, the manufacturer has to maintain equipment updated. So if there's, a new amendment to a normative instruction, that they have to conduct the complementary tests to maintain the validity of the conformity certification. That is, to maintain the safety of the equipment based on new updates. So today, this normative instruction is connected to the RDC 549/2021, and we have published a list actually of standards. So there are 86 new technical standards of types of equipment that are actually certified. They are certified within our system of conformity assessment, and that is besides materials that are not in the scope of this normative. So this normative instruction is periodically updated. Every 2 years, ANVISA will publish a new resolution, updating it by the international standards, accreditation of laboratories.
So this is a dynamic resolution, really, that has the participation of laboratories to check if they have accredited under some standards from ANVISA, and if there's the intention of implementing a new laboratory to conduct some normatives. So we collect all of that information from laboratories. Then we consult ABRAC, and then ABIMO, ABIMED, ABRAIDI. And we also determine deadlines for the implementation of the normative. For example, new standards, if we know that there's a lab that is already accredited, in this new normative instruction, we provided 3 years. For other things that are less complex, 2 years. For amendments that will impact a larger number of equipment, there's also an amendment from the electromedical equipment, then we provided 4 years to be compliant. And then we provided those deadlines for the associations, and some others that we were considering only 2 years, we extended that deadline according to the information that was provided by some associations, including, for pulmonary ventilation. We had NBR ISO 8081. We have extended that for an extra year, so it will be required actually in December 2024. So this is a dynamic process, and we will always, count on the participation of laboratories and associations so that we are able to advance with this subject and move on with this certification process.
Esse aqui é só exemplinho, desenho
So basically, this is an overview of the process of certification. So in Metro accredits the laboratories and OCPs. It audits the manufacturers. Then the manufacturer sends the equipment to the laboratory that conducts all the tests that OCP informed, sends all the results, and then the certification, or actually the certifying entity issues the certification, and that certificate gets annexed to the process to ANVISA. And that adds a lot of value for us, because only the technical dossier does not provide the verification of performance and quality of the product.
E agora o processo de certificação com essa nova
So considering the certification process according to InMetro's ordinance, we have the maintenance audits conducted by the certification entities, and whenever there's an amendment or change in the project, the company has to conduct complementary tests to maintain their compliance certificate. So I just, mentioned that this is an ongoing work together with Anatel and Metro, OCP's laboratories, to actually improve the Brazilian system of conformity assessment. That's what I wanted to present to you, and I just wanted to say that ANVISA participates as well as very much involved in Mercosur, and also with the International Medical Device Regulators Forum, is also part of the MDSAP, the Medical Device Single Audit Program.
que eu não comentei
And I
anteriormente, a IN
forgot to mention
IN
that
de lista
the
de normas
list of
de
technical
normas de certificação
standards of
aplicáveis aos equipamentos,
certification
a gente
standards
só
applied to
utiliza
equipment.
norma internacional.
I just wanted to say that
O
we only use
NBR, que é a
international standards.
NBR-IEC,
So
da International Electric
NBR
Commission,
or
ou
IEC
ANBR,
or the
ISO. Então,
NBR
são
from
normas
ISO. So these
internacionais
are
para
international
evitar barreiras de
standards
mercado, e a gente
to
sempre frisa
avoid
norma
market
internacional
barriers. So
para
we
esse
all
processo de
only use
certificação. E
international
também
standards for this
contribui
process of
para as
certification.
empresas brasileiras
That
que querem
contributes also
exportar o produto
to
e
Brazilian
tem a
companies
certificação
that
pela
would like
norma
to export their products already
internacional, padrão
certified by
internacional.
international
Não era isso,
standards.
essa aqui é só as fotos
These are the
da nossa
pictures of
equipe,
our team,
não só de equipamentos, mas
not
toda
only
a
the
parte
equipment
materiais,
division, but also we have
de
people from
pesquisa
materials and clinical
isso.
research and everything. So thank you very much for your attention.
Muito bem. Obrigado,
Very well.
Anderson.
Thank you, Anderson.
Assim como a todos.
Thank you, everyone.
Tivemos aí uma
I think
rápida,
we've had the
rápido
opportunity to
painel de
have a
fundo,
quick
né, para que a gente
overview
possa
of the different
tentar,
entities
alguns minutos agora
so
que nos
that,
restam, discutir
you know,
pouquinho.
we're able to discuss a little bit in the
Para muitos aqui
next
não
couple of
foi
minutes
tema
that we
novo,
have.
né?
For some of you, this
Mas
is
eu acho que a
nothing
gente tem
new,
agora a
but
oportunidade
now I think we have the opportunity, you know,
dessa mesa aqui.
having this panel here.
Desculpa, eu ainda falo mesa, tá? Eu sou do tempo da mesa.
I actually
Essas
said
poltronas,
table, round table, but we do not have tables anymore.
nos auxiliarem aí com algumas dúvidas que
So
venham a
let's
surgir.
take the opportunity
Eu vou
to
começar
discuss.
com uma que chegou aqui para mim, né?
So
Eu
I'm
acho
going
que é
to
pro Marcelo.
start
O
with
Metro
the first
pretende
question. So
reativar o comitê técnico para a
does a
revisão
metro want
do hack
to
de produtos para saúde de equipamentos,
reenact
próteses,
the committee
etc.
for prosthetics? Well, there was a period of extension of these technical committees, but nowadays we tend to have, you know, meetings again, just like ANVISA has been organizing, and to have an active participation in discussion fora regarding standards, regulations, because in this workshop, we've seen, you know, that there's been an advance in terms of technology, and this progress is really quick. So without a communication and a group dynamic, you're not able to keep up with the pace of change. And that is problematic for the conformity assessment. And just like Anderson said, it's about the safety of the teams operating equipment and so on. So our concern is safety with the use of equipment, so that we're able to have an assessment that is internationally recognized with the same process, with the same methodology. And also the international methods have been changing, you know, because they have to adapt to changes. So we're all on the same boat. We're all trying to keep up with the changes. And even if we do not have a committee, a technical committee like we used to have, there's a need for debate and conversations among all the players involved, you know, manufacturers and so on. That is essential, or else the process will not evolve.
Bom, evidente que a pergunta foi provocativa,
Excellent.
né?
Of course, this was a provocation, but we did not expect a yes or no answer, because this is, you know, from the institutional area, from a metro, and some committees do not exist anymore. But Marcelo, please, you know, let in Metro know that these committees were very important and had very fruitful discussions. So now I would like to open up for questions from the audience. Please identify yourself and ask your question, please. Good afternoon. My name is Angelica Marquez. I'm from ABMed. My question is from the associations. we've seen that an area from Inmetro CJEC allowed remote inspections for the accreditation of institutions. During COVID, these remote audits were important for access to medical devices. Considering that today even surgeries are conducted remotely with the use of medical devices approved and certified by you, I would like to know if ADECONF will apply the same rule and will go back to allowing remote audits from manufacturers. Look, right now, we have been going through different situations that actually required that type of action. I cannot speak a lot about accreditation, but I understand that there's a concern from the Institute, which is, the case of Rio Grande do Sul and the case that we've had in Israel and also during COVID. Some actions and decision-making were necessary, including the use of doing things remotely. This is a tool that got stronger during the pandemic, and now we realize that we are using the same resource to make things more flexible due to the volume of work. Of course, I cannot answer to that question individually, but I can take that concern to the board because it's a very interesting consult. And especially considering this workshop where we've had, the participation of incredible experts that provided a lot of contribution to our discussions. I mean, the use of technology, which is something that we've been discussing, I mean, it provides infinite benefits. But the structure and the how to do things, like I said, I cannot answer on behalf of the board. And the accreditation has actually a specific detail. In order to have the accreditation within the same institute, this is an independent coordination. It works independently because of the international agreements. So basically, is a black box for us from ADConf, but we observe and are aware of everything that's happening considering the Institute. And we know that there's a need for modernization. I even believe that a lot of remote technology has been used for monitoring of several situations. So I'm going to take your question and your comment to the board because we're here actually to, get information and produce an internal report so that we're able to discuss these issues. I believe that we act as a great tool for manufacturers as well, because manufacturers are not able to enter any market if they do not have complete trust in what they're doing. And that trust, that reliability takes a lot of effort, a lot of tests. It's really a lot of tests, considering also the reality that we, saw here and the risk analysis and everything. So this is a regular routine. And I thank you for your question. It is very important, and now we'll circle that back to the Institute. Thank you very much. Do we have another question from the audience? Hello, my name is Silvio Bachega from Audis Consulting. My question is for Davison. It's not really a question, but a comment. And I would like to take advantage of this moment because this panel represents 99% of the regulation in the medical sector. So I see that this panel here in collaboration can promote a lot of evolution for our sector. And I'm actually really happy to see Anatel here. I saw you at the hospital trade show, and we need the presence of Anatel as well as the presence of Inmetro in many other situations. And I can already say that throughout the last few years, those that faced the difficulties from Inmetro from 15 years ago, I can already say that Inmetro is in a much better situation today. The Institute has heard a lot of our asks. There has been a lot of technical exchange and collaboration. And I can say that we're not at an optimal point, but it's much better than in the past. And so regarding ANVISA, I think we've come to a high level of demand from ANVISA, but at the same time, it's very possible to be compliant too. And Anatel is in a different position. It's really difficult for our sector to comply with Anatel's requirements. I would like to actually apologize because during the hospitalar trade show, I was really blunt in my comments to Anatel and their representative there at the trade show. But nevertheless, within our sector, we have a lot of regulations. One single product sometimes has to comply with the requirements from 90 countries. And whenever we conduct one change, that will need the approval from the vast majority of those countries. That means that a change in the project for us is not something that we do very quickly. It's common for one change to take 1 to 3 years to be implemented. And if we're talking about Brazil, that's really different because products are developed to serve a market that will dilute the cost of development of that product, and possibly that product will come to Brazil. This is our reality, and it's much stronger for the medical sector because most of our products are imported. With that said, what are the difficulties that we have with Anatel? That's the import of products for laboratory testing. When we need to import a product, and this import has to be done every so often, and we're going to talk about it in a bit, the importance of a product only for testing is a huge burden. If you've ever had to import anything, you know what I'm talking about. When we're talking about certifying one Bluetooth USB, okay, that's fine. We can import it in an easy way. It's easier to manage storage. It's not medical device. Great. But when you need to import a medical device that is large or even medium in size, costs around $250,000, and then send it to the lab, this shows a challenge on its own. The other challenge is following up on these tests. A lot of the time, these products need an engineer to follow the tests the whole time. The lab on its own can't put the product in enough testing scenarios to be acceptable. So I think all of us have gone through having a call or video chat in the lab and showing the connection, the testing equipment. And it's something that happens a lot, as well as bringing in engineers. I've had to have 4 or 5 engineers for one test. So this is a huge challenge that we have as well. And the other challenge is on repetitive testing. So every so often we need to repeat the test. So certification on its own, I know that it's essential. We need to have the certification, and this is a differential of those who are compliant with the regulation and those who aren't, definitely. However, it needs to be a little more agile and practical. So the first topic that I would like to talk about is the
understanding memo.
Durante a feira hospitalar comentou das questões das
On the
dificuldades.
hospital fair,
Só
I
que
remember we talked about these
essas
challenges,
mesmas
but
dificuldades
these
a
same
gente ouviu do
challenges
Inmetro
were
10
heard
anos,
from
15 anos
Inmetro
atrás.
10,
Por
15
isso
years
que eu digo
ago.
que a
That's
colaboração
why
pode ser
I
muito
say that
importante.
collaboration between the
Qual foi a
agencies can be
solução que
very
o Inmetro
important.
encontrou?
So what was
E
Inmetro's
eu não sei
solution?
as
And I don't know the
dificuldades, aí o
challenges for
Marcelo vai
that, and
poder,
maybe
vai
Marcelo
poder
can
contribuir
let
aí.
us know.
Mas o Inmetro, ao invés de
In
fazer um
Metro,
memorando de
instead of
entendimento
having the
para
memorandum of
acreditação dos
understanding to
produtos ou
accredit
para
products
certificação dos
or for
produtos,
product
fez memorando de
certification, they
entendimento
had
para os
the
laboratórios.
MOU for
E aí a
labs.
certificadora se
So
encarrega
then
de
the
checar e verificar se
certifying agent is going to
teste
make
realmente
sure that the
atende à
test is
regulação, à
in
necessidade
compliance
brasileira.
with Brazilian needs for
Então,
regulation.
não há uma
So
aceitação
what I
mútua
mean
entre
is
países. O que
there
há
isn't a
é a
big
aceitação
acceptance between
de
countries. What we
testes
do have is an
laboratoriais.
acceptance of lab
Isso por si só
testing.
faria uma diferença
This
enorme,
on its own would make a
porque
huge
você ter
difference.
laboratório ao lado
Having a
da
lab
equipe de desenvolvimento
together
já
with the
faz uma diferença
development
enorme.
team makes a huge
E
difference.
só para
And
exemplificar
just to give you an
a
example
dificuldade nesse
of how
caso,
challenging this can be, sorry, just a second.
talvez eu tome pouquinho
Maybe
mais
I'll take a little bit more of your time
para explicar a
to
situação.
explain.
Temos outras
It's because we
questões.
have other
É que eu acho que a
questions.
gente precisa aproveitar
Yeah, but
esse
I think we
momento
need
que
to
ele é
use this
único.
moment because it's a unique opportunity.
Num caso de marca-passo,
In the case of a
é necessário ter
pacemaker,
produto
it's
comum,
necessary to have a
marca-passo
common
comum,
pacemaker, common product,
aparelho
and
completamente
an
modificado
equipment
com
that is
software
completely
diferente.
modified
Ele
with
foi
different
aberto,
software
foi
because it
colocada
was
uma antena dentro,
open, there
foram
was an
colocados
antenna
fios para
in
fora
there,
para
wires
controlar
came out to
e
control it,
fechado
and then it
novamente,
was
porque
closed
precisa ser
again because
testado
it
na
needs to be
condição
tested
de funcionamento
in its
convencional.
regular
Só para
working
desenvolver
condition.
software para fazer isso
To
leva
develop
tempo
that
absurdo.
software takes a long
E
time.
esse software não é
And
software
this
de linha de
software is
produção,
not
é
a
software
production
que foi
line software.
desenvolvido para
It's software that was
então ele
developed
também pode
for
ser propício a
prototype,
falhas.
so it can
Isso
also
exige
be
então a
prone to
importação de
failure.
uma amostra
So then you
exclusiva
need
que foi
to
feita
import an
somente para
exclusive
isso,
sample
o
done only for
acompanhamento do
that,
engenheiro.
an
Esse software pode
engineer
falhar durante o
following up.
laboratório,
The
precisa de
software can
modificação,
fail.
a gente precisa fazer
There
download de
is a
software
change.
para
We need to
mandar a
download
amostra
the
de volta
software,
para
send the
ver
sample
trazer de
back to be
volta.
changed and bring it
Então a
back.
gente está falando de
So we're
níveis
talking about
técnicos
technical
muito
levels that are
altos,
very,
que é muito
very
difícil
deep.
atender quando a gente
It's hard to
tem que fazer
comply
isso no
with when we need to
laboratório.
do this
E
in the
nós
lab.
enfrentamos isso
And
no
we go
passado
through
quando
this.
era
We've gone through this in the
obrigatório fazer
past
testes
when it
aqui
was
no
mandatory to
Brasil,
test here in
lá
Brazil,
pro Inmetro. Então
according
esse é o
to
primeiro
Inmetro.
ponto.
That's the
O
first
segundo
topic.
ponto é a questão
The
de
second topic
produtos que, por
is
exemplo,
related to
USB
products like a Bluetooth USB
médico. A gente está
for a
falando de
medical
produto
device.
médico, por
So we're
exemplo,
talking about a
escala de
medical
produção na ordem
device
de 20
that has a
unidades, 200
production
unidades
scale
ano.
of maybe 20,
Quando
30
você
units per
precisa ir ao
year.
mercado
When
e
you need to go to
adquirir
the
esse USB
market
Bluetooth, você
and
não
buy
consegue
the
acordo de
Bluetooth
fornecimento com o
USB, you can
fabricante
have a
que vai
deal
te dizer,
with
vai te
the
garantir que ele vai te
manufacturer
fornecer
that's
por
going
5
to
anos de
tell
produto
you
sem
that they're going to
modificação.
give you that product for
Então,
5 years
a
without
indústria
any
médica,
changes.
com toda a
So the medical
regulação que ela
industry,
tem,
with
todo
all
o
the
peso da
regulation and the
regulação que ela tem,
weight
ela
of the
pode ir ao
regulation,
mercado comum
we need to go to the
adquirir
regular
USB
market to
Bluetooth
buy
sem
a
acordo com o
Bluetooth
fornecedor, sem
USB
saber
without
se
any
aquele
deals with
produto
the
vai ter
suppliers,
continuidade.
without knowing if
E
that
aí,
product will remain
a gente não consegue
unchanged.
acordo com o fabricante para
Therefore, we
fazer a
can have an
homologação desse USB.
agreement with the manufacturer
Então,
to
esses
certify
casos
that USB.
exclusivamente
So
dentro do
these
setor de
cases in
saúde
the health
também
scenario
precisariam de uma discussão.
need to be
Como que
discussed.
a gente vai dar
How are we
continuidade para esse
going
produto? Se
to
trocar
continue with
USB
this
Bluetooth
product
envolve
if
alteração
we
de
change a
projeto,
Bluetooth USB? Because
envolve
that's going to
todo
be a
aquele
change in
ciclo que eu
project.
comentei
So
que
it's
às
that
vezes
whole
pode levar
cycle that I
alguns
mentioned
anos.
that can take up to 2 years to
Então,
change the
essas são algumas
USB
das
port.
dificuldades.
So these are
Dito
some of
tudo isso,
the
só para
challenges.
encurtar, senão o Jofre
And
vai me jogar uma pedra
all
aqui,
that
eu
said,
não.
just to shorten the time, otherwise I'm
Até
going
às
to
8,
be
né? Só para
in
encurtar,
trouble.
o pedido
To
que eu
make a long
faço
story
é que a
short,
Anatel
my
abra
request is for
discussões com
Anatel
o
to
mercado,
open
não só
discussions
com
with
os
the
reguladores que
market,
estão aqui,
not
que
only
têm uma
with the
experiência
regulators
que
who are
pode fazer
here because
diferença
they
na
have an
Anatel,
experience that could
mas com o
help
mercado, com o
Anatel,
setor,
but with the
e
market
aqui
and
eu
the
acho que a gente tem
sector.
gente
And here I
disponível
think people
a
are
vir
available
a
to do
Brasília
that,
e tudo
and they
mais,
can
as
go to
associações
Brasilia
aqui,
and to where the
para
associations are
discutir
located
essas situações
to discuss these issues so that we can actually treat the health sector with the attention that it needs. I know, and this was an argument from Secundino, that Anatel has a huge scope, but in Metro also does. And in Metro was able to find ways of acting in certain sectors. So our request is for you to look at the health sector with a different outlook. And I would like to also thank you guys in 2020 with Act 4088. Anatel removed the demanding of having the seal. So it's the only sector that has this area. This was removed only for the medical sector. So I wanted this to be a continuous view. Thank you. Okay, let me just have some comments. I think from the end to the beginning. We're always open, and whenever you come to us, we are available. So I think maybe you needed to talk to us. In the case of import, people sent an email. I think it was Angelica. I recognize her. Nice to meet you, Angelica. And we are always open. Whenever you guys ask something, we respond. Any sector that comes to Anatel, any sector, we are open. So you can come to us and we can discuss things with all sectors. There are no closed doors. I just want to make that clear. About labs in general, here's the thing. Let's think about it this way. Inmetro is a part of ILAC. Due to the legislation, they do have a difference. The field of telecommunications is different all over the world. It's not only in Brazil. So in the telecom area, we have mutual recognition agreements, and you can't just say, okay, I'm going to accept this. But no, why don't you do that? If I simply open for any sector, for the medical sector, if I allow to receive that, I can't, I'm going to have to do it for the other ones. I can't have a differentiation in this case because trials need to be done for all sectors. So every time we discuss mutual recognition agreements with other countries, like, oh, I'll accept yours, I'll accept theirs. And sometimes it's unfair with the sectors that develop in the country, which are the labs. They promote research and development. A lot of the products that you use are done by the labs, are created by the labs. So it's the same thing as opening the doors to China. Like, hey, everything can come in. And what about the Brazilian sector? So we need to handle things in a way which is we discuss it as equals. Whenever there's an agreement, we are open. We talk to all countries. With Europe, we were a part of the agreement that Brazil participated in. Anatel was there. It wasn't implemented because Mauricio hasn't approved it yet. We had an agreement with Chile, but we have been talking to different countries about this, and our stand currently is to not accept it unilaterally. It has to be a mutual acceptance so that those countries can have benefits. So that's why it's not specific to a sector or anything like that. It's mostly handling and countries treating each other as equals because all of us want to develop our own sectors. So that's, to summarize, that's it. But regardless of that, we have rules to accept foreign reports. If the cost is high, we will accept it. If it's a low-scale production, we can accept it. And also the modules. If the module is certified, you don't have to bring the product. So all of that, in general, is, as I said, lab depends on mutual recognition agreements. Okay, we had two questions that came in online for Anatel, but I think they were already answered, which is related to ELAC and the acceptance of tests done outside of Brazil in regions that have the same radio frequency. I think that was already answered as well. Good afternoon. My name is Patricia from Johnson & Johnson. I want to thank you for this panel. It's a very incredible panel with all the agencies. And my question goes specifically to Marcelo from Inmetro. Marcelo, we heard a lot about the new regulatory model from Inmetro. Until last year, we heard some movement and we saw some changes regarding tax and migrating that to ANVISA. And then my question is, what is the new regulatory model in Inmetro like, specifically for the medical devices sector? So in what way would we be impacted? That's my question. Thank you. It's a great question. So far, this work with ANVISA is a very different kind of work. As I said, we have the cooperation terms if you check the InMetro Foundation, we have product regulation that don't have other regulators, or they can be done through cooperation terms like we have with ANVISA. So there is a decision from the ministry above InMetro. We can say that it's an ordinance, but our ministries have established this is going to happen. And as Anderson said in a very well put way, this comes before ANVISA was even formed. InMetro has always participated together with the entire industry in the sense of helping the industry. That's why InMetro was created. Initially, we wanted our products to be able to reach markets, and actually all sorts of problems happened in this case. For you to get ore that wouldn't get to the other port with the correct load, so it had to come back because the weighing of the shipment wasn't correct. So the need for national standards, traceability, quality chain, traceability chain, this is essential. Myself, working with ANVISA, and in this panel, of course, but we've been doing that for a long time, I really defend in InMetro this kind of situation. It's a situation that transcends the new model, because it's not a decision that can come from InMetro. It's a decision that came in a superior instance from the ministries, Health Ministry and MDIC. So until we can have change from the Ministry of Industry and Commerce, maybe we could justify doing that. But we have internal work in InMetro that I didn't mention, of life sciences and all that, that are related to Fiocruz, actually, in Rio. And this is very important. This term helps to create the operation between several regulators. So us working with ANVISA is already a great load of work. InMetro does have the technological aspect, and we kind of join forces because there's some things that are important. Geoffrey mentioned this when he asked the question. I remain in a defensive position, I would say. Of course, nowadays we have different president, different board, but I also felt a positive vibe to this understanding, because the electromedical device is not covered by InMetro certification, and there is a lot of discussion around this kind of work. But I think that even the opportunity of participating on this panel and what I can bring back to InMetro, because here we talked about risk management, software, and even our colleague from Anatel talking about Internet of Things, other than Internet and medical devices. So all of that, if we don't participate in these forums, we are unable to keep going. So I've always really complimented ANVISA on their work, and I still do, because ANVISA is always looking at the most modern things that are available and bringing into this cooperation with InMetro, being able to develop that internally. So it's continuous development for all of us. It's a segment that matters to the manufacturers, for the entire research sector, whether it's from abroad, from Brazil, and here we're discussing mutual interest topics. And at the end of the day, something that is going to bring great benefit to the population. Our concern cannot lose focus on having patient safety at the center of our ideas. So right now, I don't have any information that the current model could affect that relationship. I think me being here actually even starts a better discussion in that sense. My boss has already asked me to go back and talk to her, and I want to write a report because I think there's a good technical report that could talk about everything that was presented in this forum. Awesome.
Acho que temos espaço para
Do we
mais
have more questions?
Talvez eu acho que dá tempo, Geoff. Vamos lá. Fazer para o Davidson.
I can ask a question to Davidson. I'm going to make the most of the fact that you're here. I've already asked you this question. I already know the answer, but I think it's important to use this moment and maybe you can clear it up and talk about the specificities that Anatel has thinking about the certification process. We know as a regulatory agency, we have a job of regulatory convergency at a world level. And we have the harmonization of requirements. Thinking about the world, we know that there's globalization, and the example that was given, products today in medical devices, 70% of what is recorded in registered in ANVISA is imported products. Especially in a world of medical devices, this is very relevant, and the harmonization is more and more demanded by regulatory agencies. And we can talk about the fact that even nowadays, following international requirements and conformity assessments, doesn't this mean that ANVISA could follow Brazilian laws? There's always that question. When you follow a specific standard, Brazilian standard, could ANVISA, if justifying it, thinking about health risks and all of that, this isn't what we've done right now? And is there a possibility of having something very specific in this region of the country? We can actually be questioned due to technical barriers to commerce for the World Trade Organization. This could be questioned. And I had the opportunity of asking you how Anatel deals with these issues once we have the specificities that you showed with the regionalization of radio frequency bands. So I think it's important for you to present that and talk about, if you are being questioned about that, how do you deal with this topic that is actually very specific to Anatel? I think it's a good opportunity to clear it up. Just for the record, Juliano Tesser is from ANVISA. Sorry, he didn't say his name, so I was just letting you know. As I said, the telecommunication sector is specific because each country, or even within the regions, countries create specificities. So within the telecom sector, talking about the agreements, even when we're discussing an agreement, there's always a little footnote. This is before the telecommunication sector, because there are differences. And telecommunication was different because of conflict, war. In the past, countries would have war and they would use proprietary systems to communicate between the armies. And this happened. So each country created their own communication system when there was a free frequency band. That's why this was created. So actually, Anatel does get this question, but in this area of telecom, we usually discuss a lot. We always talk about the union of international telecommunications because there are some specificities and some things like you mentioned, and I think it's also related to the other question about some things that Anatel has that are different than the other countries like ANC. Every time that we create a certification process, we have a study in the Brazilian network, and it's actually an old study about what happens in the network, equipment, and we saw that, for example, the air humidity level of impulse in the network or electromagnetic pulse on the network. In the US, they use ANVISA, not IEC. So there is a study. We didn't say, oh, let's be different. There is a study that bases on that.
That's why we adopted those criteria, just like other countries. So whenever there's a question, we'd like to demonstrate, this is done for the consumer safety based on normative from IEC and also based on this and that standards. Right, Juliano? That's why. Thank you so much. All right, with that, and to close this panel, I think we've had excellent discussions, and this actually opened up the doors for other conversations. And so the idea is that we have this production sense and this interaction, sense, so that all the peers can talk in a proper manner. So I would just like to state that everything that we have discussed here, all the processes, the resources, we talked about tests, involvement of the government. None of that will actually work if at the delivery of the equipment we do not have proper structure, trained personnel, and really an evolution of the environment and of the structure that where this equipment will be implemented. Risk to say that the structure that has been created is a robust structure. So if manufacturers and importers have all these steps and comply with all these requirements, it's hardly, difficult for this equipment not to be proper for use, considering it provides all the evidence. But none of that is good if the technician of the hospital wants to, connect two pieces of equipment together. And, so I think we have to evolve in this discussion and talk about, the audits and vigilance. And I would, also like to state that there's this, challenge for this forum for us to conduct this integration, because we're not trying to talk about what is going to sell, what is going to buy. We're thinking about the patient that is actually lying on a bed. That's what's in our minds when we regulate, when we project, an equipment. That's what has to be at the core of everything that what we do. So I would like to thank Marcelo, Davison, Wilson, and Anderson again. ABRAIDI, thank you very much for hosting us, and let's move on with our workshop. Thank you very much.
Em nome do primeiro workshop
On
internacional
behalf
de
of
cirurgia
the
robótica
first
e
workshop
inteligência
on
artificial
robotic
da
surgery
ABRAIDI,
and AI,
agradeço
I
aos
would like to
senhores
thank Geoffrey
Marcelo
Moraes, Marcelo Carvalho, Davison Silva, Wilson Bonato, and Anderson Pereira.
Nós vamos agora fazer
Okay, so now we are going to have a 15-minute break, and we'll be back to talk about client training on our next panel. We'll be back at 3:20. Thank you very much.
Estamos retomando a série de painéis do
Back
primeiro
to the
workshop
series of panels
internacional
on
de
the
cirurgia
first
robótica
international
e
workshop on robotic
inteligência
surgery and artificial
artificial, com a promoção
intelligence,
da ABRAIDI,
promoted by
ANVISA,
ABRAIDI
Patrocínio,
and ANVISA,
Intuitive,
sponsored by Intuitive,
Medtronic,
Medtronic, Stryker, and Johnson & Johnson.
A partir desse momento, vamos
From
abordar o
now
tema
on, we're going to talk
treinamento
about
de
customer
clientes. A
training.
moderação ficará
The
a cargo de
moderator
Ana
is
Maria
going to
Malik, da
be Ana
FGV
Maria
Saúde,
Malik from
a quem eu convido
FGV
a
Health,
subir aqui ao
and I
palco, por
invite her to
gentileza.
the stage.
Pois não. sem problema, por gentileza. A conversa será com Shelley Peterson.
The conversation is going to be with Shelley Peterson, Global Vice President for Training in Intuitive.
Para as considerações
For
iniciais,
initial
passo a
considerations, now I go over to Ana Maria. Good afternoon. It's off. Just a second. Okay, there we go. I'm the best person to talk about technology, as you can see. So good afternoon to everyone who's here. Congratulations for staying until now, because it's late. I am very happy and very honored to have been invited today. I have my mask to try to hold my own viruses to myself, but in any way, I will try without the mask. I was talking a little bit to Shelley just before we came up here. And I discovered that this company called Intuitive, actually, I was very happy and I told her, and this is not a feminist speech, but I would like to hear that the main talk is given by a woman. And she told me that let's say the C level of Intuitive, most of it is comprised by women. And I told her a little joke and I said, that's why the company is called Intuitive. Well, I work with business administration, and there is a very paper from a professor called Paulo Mota, and it's called Reason and Intuition. And it tries to demonstrate in a public business paper, it's probably 20 years ago. This article tries to demonstrate the limits of both reason and intuition. So it's clear that to develop artificial intelligence, and I saw the other day there was Mafalda comic strip saying that she's not worried about AI, she's worried about natural stupidity, actually. So we are working with artificial intelligence, with robotics, and all of these things that that actually came to be a characteristic of the 21st century. But if we don't have people who are intuitive with a lot of the social skills, what we usually call soft skills, we're not going anywhere. One of the most important ones, and I usually say this as someone who works with management and people management, one of the most important things is actually being willing to be trained or skilling, to go through skilling. Because a lot of people think that training and skilling is for other people, because I know, and that's not how life rolls. So for me, it's a great pleasure to work in this area. Just to remind you, the superintendent of this hospital, engineer Antonio José, everyone knows him as Tom Zé. He had a doctoral thesis. Oh, thank you. I'm not saying no to water, thank you. And especially on Brazilian Valentine's Day, which is today. But Tom Zé had his doctoral thesis about the implementation of robotic surgery in one of the institutes of this very hospital, Hospital das Clínicas. And it's clear what was the most important thing: education and training. Without education and training, you can buy the best equipment in the world. Nothing's going to happen. So if we want to have a smart policy to incorporate technology, other than discussing the legal aspects and normalizations, we also need to think about who is going to actually operate the equipment. So it's a great honor to have you here. It's great to introduce your talk, and I'm going to pay close attention to see if I can learn anything, because my time of plastic brain are gone, but okay.
Thank you very much. It was a wonderful introduction. Realizing that I'm one of two speakers between you and celebrating your Valentine's Day with your loved ones, I will try to be inspirational. Do my best. So the organizers, first of all, thank you for having me. I so appreciate visiting this country and being a part of this program. I think it's really important as manufacturers that we combine forces and start to talk about how we want to elevate patient care. And I want to talk about one part of that today, which is learning and training. So I think you know that Intuitive, our mission has always been to extend minimally invasive care to as many patients as possible. And we do that using three things. Obviously, our advanced systems, our end-to-end learning opportunities, which I'll dive into a little bit more, as well as value-added services. When you think about these three components combined, the end result is that you optimize workflows and experiences for both surgeons and their entire care teams. So it's a big mission, but that's what we've set out to do. So I'll dive in a little bit further. So when you think about surgery and the complexities of surgery, it's really important to consider everyone in the room and have you met their learning objectives for that phase of their learning. And so we think a lot about having an intense focus on making sure the content that we deliver is both relevant and engaging. You can create a lot of content, and if it's not engaging, the learners may breeze over it and really not pay much attention. But then it has to be relevant to what they're trying to learn. And I believe our learning innovation is very relevant to everyone who's on that team, whether they're doing their first Da Vinci case or whether they're 200 procedures in and they're tackling a very complex procedure and needing to learn specific skills to help them in that procedure. And I'll talk a little bit more about this. So to date, over 76,000 surgeons have been trained around the world to use the Da Vinci system. And as we've evolved our platforms, we've transformed training too. I think one of the speakers said it earlier today. If you aren't looking at the future, you're stale. And it's really important to think about how you can ensure your training continues to evolve and improve over time. So we think we have a pretty good mix of, virtual reality, online training, hands-on training, and procedure observation, as well as other technologies. But I think we're always asking ourselves, what's the next thing? What's the next step? And I think, as manufacturers, we should all be doing that and asking ourselves, yes, we have the core fundamentals that we need to cover of how you operate this system, but what else could we give our customers to enable them to be more successful? So I'm sure everybody remembers the pandemic. It was really very fun. When the pandemic hit us, we were still doing a very high volume of trainings around the world. And so like the other manufacturers, we had to quickly switch gears and do more virtual learning and do more online learning. Our learning management system, which is called Intuitive Learning, we had to add a lot of procedural videos because there for a few months, we were not able to get to our customers. But then as we started to say, okay, it's June 2020, we still have to train these customers. We had to find a slightly different way. So we decided to expand our training footprint and open more training centers so that customers could get there either within a short drive or maybe short train ride where areas were opening up. Europe stayed closed for a very long time. But in the US, we were able to reopen training in June of 2020. And we had our trainers flying all over the country and systems moving all over the country so that we could help our customers. The other thing we learned during that time, though, is it wasn't just a pandemic thing. Customers don't want to have to travel across the country to go to training. They don't want to shut down their practice for long periods of time. So we're continuing to evolve this and looking at areas where we can open more training centers to create accessibility for our customers. We think it's the way we democratize healthcare in some ways, right? If you are in Singapore or you're in Australia or you're in Belgium or Poland, you should have equal opportunity to training. And so that's what we're going for. We do a lot of trainings. We had 9,000 sessions in 2023, and we trained 14,000 customers. It's a huge operation. And with a huge operation comes a lot of responsibility, which is what keeps me up at night, why I have so many gray hairs. But we learn and we grow. And I think there's three key areas we need to focus on to make sure our training stays successful. One is looking at those strategic investments. How could we do something differently? Could we reach another audience? Could we reach an audience in a different way or a more engaging way? So looking at things like VR and AR and tools like that. And then where will we see these growth patterns? In Japan, we've had tremendous growth. In Europe last year, we had, I think, 45% overall growth in trainings. And so we need to be 5-10 years ahead of that, somewhat predicting how fast we'll grow so that we can make sure we've made the right investments so we're not a bottleneck for our customers. I think the second piece is really paying attention to our operational workflows. And it sounds simple, but when you train 14,000 customers a year, it's a lot of people, and you have to make sure the way they register is easy, the way they get communications about their training is easy, the way you organize equipment and specimens and all those things, which I'll get into a little bit later. So that's another key area. And we're always looking for ways to streamline processes and automate where we can, while still keeping it a very seamless experience for the customer. And then the third thing, and I think the most important thing, is quality, right? We've been talking about quality a lot today. So the quality of trainings is more important to me than anything. And we do watch that in a number of ways. We do surveys from every single training we do, and we ask our customers about their experience. We meet routinely with expert surgeons, and we meet with societies, and we ask them questions, and we tell them to poke holes in what we're doing and give us feedback. We also do quality audits of training, where we literally pop in and check on a training when somebody didn't expect it to be happening, as well as routine audits of quality records. And then we watch our Net Promoter Scores, which I'll talk about a little bit further. So how many of you are familiar with the technology training pathway at Intuitive? A few. Okay. I'll try to dive into this a little bit deeper. We do have a technology training pathway for every key performer, medical professional who works with a robot. And the idea of these pathways is, number one, that they're structured. So there's specific milestones to meet at each level of training. They're progressive. So once I, as a learner, learn my baseline set of skills, then I can move on to the next set of skills. There's, Joe, you were mentioning it earlier today, there's a lot of interfaces and a lot of tasks that surgical teams need to learn. And so what we try to do is scaffold that learning, right? So that you pick up pieces at a time and you're able to move on to mastery. I think the other thing we look to do is augment all of these trainings with the right sort of hands-on courses, virtual learning, and proctors. We have over 1,200 proctors across the globe. And we always recommend to surgeons when they're starting out, make sure you have a proctor in the room for your first several cases until you feel confident and proficient. So I'll briefly go over the pathway for surgeons. Phase one is really an introduction to the platform. This is where surgeons can look at some procedural videos, view a case observation either in person or remotely, and ask the questions, how does this fit into my practice? And does it fit into my practice? And sometimes the answer to that is no. They're able to talk with an expert and ask them, how did you integrate this? Which patients did you start with? All of those questions that need to be answered. And then our sales reps do a really good job of contracting with the surgeons to say, okay, if you're going to learn to use this robot, we're going to ask you to do a lot of work and a lot of things. And they literally sign a contract with us saying, I'm willing to do the work. So we are very careful about that selection process. Phase two is probably what you're all familiar with, which culminates in that hands-on training with a Da Vinci trainer at a training center. But again, it's this scaffolded learning. So starting with online modules, working on the simulator, working on some tasks, like suturing, et cetera, as well as going through an entire in-service with their sales representative. So ideally, when they arrive at our training center, they've got some fundamental console skills. They have a baseline of knowledge and a baseline of ability to operate the system, let's say. And then after they've completed all of these things, if they've completed them all and completed the training day successfully, they get a certificate. And most would think, okay, that's where training stops. But we don't believe that training is an episodic event. We believe training and learning is a lifelong journey. So then we move on to phase three. And in phase three, surgeons are applying the skills they learned during that technology day to their practice. They have proctors available to support them. They oftentimes have their rep there to guide them through their first cases. And then we start to sprinkle in what we call procedure cases, so what we call TR 300. I'll get into that a little bit later. But the idea of now you can learn from a peer on how do you take the technology that you've mastered today and apply that to a clinical procedure. That's not necessarily required by the governing bodies, and in fact, it's not. We just have a belief that it adds a ton of value to a surgeon if they're able to get that peer-to-peer interaction and feedback from expert colleagues around the world. And so then they move on to phase 4, which never ends. It continues forever. So the idea is I've mastered, for example, an inguinal hernia repair. Well, and I've done, 20 of those cases. Now I can move on and do something even more difficult. And then after many, many, many procedures, I may want to move on to do something such as complex as an abdominal wall repair, right? And so they're able to progress through their career with those educational supports all along the way. So residents and fellows, I was actually pulling some data for this talk, and I was shocked to learn, because I did not know the number was quite this high, that 26% of our customers around the world are learning how to use the system without us. And so they're primarily learning that through residency or fellowship. And we've been developing tools. We have a pathway for residents. We have a pathway for fellows. But it became abundantly clear to us a few years ago, especially in the US, where these programs are taking off, and programs like Hopkins are turning out fully credentialed residents that are able to use the robot efficiently. So we felt like they needed our support to help them design a curriculum, help them understand what milestones they want their residents to hit. And we don't dictate to them what it should be. We just offer them a lot of resources that they can pick and choose from to create a curriculum that works and matches with the goals of their institution. And then care teams. We're all familiar with the care team crisis that we're seeing all around the globe today. We've been training care teams for about 10 plus years, offering kind of a smattering of courses, but in the last 5 years, we've really doubled down on care team training. We think it's really important not only that they get the fundamentals of the technology, but also there's other opportunities to improve the entire operational workflow experience. So we have robotic coordinator courses where the robotic coordinator from the hospital can learn the essentials of building a Da Vinci program, how to manage schedules, how to manage workflows, how to manage standardization of trays, et cetera. And then finally, the one piece we've really spent significant time on is thinking about not just the technology for the first assist, but actually the procedure choreography. So how do the workflows go? And they come to these courses with expert first assists, and they learn from those first assists how they can best support surgeons when they're out into practice. I'll talk a little bit about learning engagements. I've talked about most of them already, but I did want to mention that you can have the best training for the surgeon and the patient side assist, right? They've gone through all these modules, they've done the simulation, they've done the in-service with their representative, they've come to the technology training. And that really works. We know it's a formula that works, but there's all these ancillary staff. There's the sterile reprocessing department. So we have a focus on training them as well and creating offerings for them so that when instruments come down, they get cleaned properly and sent back up. They're an important part of the workflow. And then finally, hospital executives. Because if they're investing in a robotics program, we want to support them to make sure they have all the tools they need to make sure they have a really good robotics program. And so we help them with things like cost containment. How do you build a program that's effective? How do you make it make sense financially for your institution? How do you measure success, KPIs? And then finally, for the academic institutions, really thinking about how they build a robust curriculum so that their residents and fellows graduate with the skills they want them to have. So when you think about surgeons, we decided we should design this like a college curriculum. TR 100 is your technology training. And then as you move on down, you progress through your learning curve. And we consult with societies and surgeon leaders around the world to say, what should be the prerequisites to learn for these courses? We use a lot of instructional design to help us with learning methodologies, but we also talk to a lot of customers, and there's going to be country-specific requirements. In Europe, they might do a low anterior resection in a slightly different way than they would in the US. And so we need to be respectful of how they handle procedures in those markets. And so we do a lot of consulting with key opinion leaders and with societies to ensure that this peer-to-peer training is effective and that it's meeting the needs of the audience. So again, a lot of different courses, a lot of different things to manage. But we do have a team of professional education managers, and this is all they do. They audit the courses, they get survey feedback on the courses, they give feedback to the key opinion leaders, and they look at those surveys very carefully. Sometimes you, no offense to any surgeons in the room, but sometimes you'll get a surgeon who wants to teach for us, and they start out really strong. And then after a couple of years, they start to lose their enthusiasm. Those are things we need to watch. We need to make sure they're very present and that they're there to help the surgeons that they're teaching. So net promoter scores are really important to us. Anybody in the room familiar with net promoter scores? Yeah, a little bit, yeah. So it's really something that industries, all types of industries look at to say, how satisfied is my customer with what I do? And a net promoter score of 70 is considered to be very good. But that's something we always ask on surveys, you know, would you recommend this course to a colleague? And then we track those very carefully over time to say, are we going up or are we dipping? And if we're dipping, oh, what's the reason? And monitoring that. So I think as medical device companies scale their training programs, this is a great way to measure quality and to talk about the quality of those programs. So I mentioned residents and fellows and how many of them are coming through. But the other piece that we've decided is really important to spend time on is collaboration with societies. So we have a lot of different collaborations with societies, primarily in the US, Europe, also in Japan, where we work with society leaders to say, what is a good, I'm going to make this up, a good thoracic surgeon look like, a good robotic thoracic surgeon look like? And they give us feedback. And in some cases, these societies have actually built the benchmarks to say, we want a thoracic surgeon to be successful at these 5 KPIs. And then we build a curriculum with them around that, work with them through an educational grant to make sure that those fellows of the next generation are well prepared to go out and practice. I talked about care teams. This is a bit of a lot of words on a slide, but I just wanted to kind of demonstrate to you all the steps that they go through and all the things that we offer to those care team members so that they can get confident and proficient on our technology. And then we also have this amazing group of individuals called Genesis. And our Genesis team is really designed to be at the hospital, in the environment, helping our customers where they need help. They do a lot of new system installs. So when a Da Vinci system lands in a hospital and they've never had one before, these teams come in and coordinate. And they coordinate with the OR directors and the managers to make sure the staff is trained, that they're ready, and they have a plan for moving the system into the room, moving it out when they're done, how they're going to manage their trays, all sorts of optimization. So they do a lot of different tasks, but they basically live in the hospital with the teams until they feel confident and proficient to move on. And so there's 2 teams on Genesis. One is our consulting team. And they really go in and solve problems for hospitals. And sometimes they solve problems that hospitals didn't even realize they had, which is super interesting. So they may say, oh, well, you've got 5 general surgeons doing hernias, but they're all using different instruments. And some of them have 5 and some of them have 3. Is there a way to standardize so we can save you some money? So cost containment is a big part of what they do and the service they provide. And then on the flip side is the training service, the sterile reprocessing department, the nurses, the first assist, and helping with those operational workflows in the hospitals. So next, I'm going to talk a little bit about learning technologies. We've seen a lot of AI and different fun things today. What I look at right now at our current state is that learning technologies are not just an enabler, but an accelerator for learning. So everything they add to the mix helps the customers acquire that knowledge and move towards mastery. We're not at the point where learning technologies are going to be able to do it by themselves. And we've seen customers. I've met a lot of surgeons, and most of them are not going to be really comfortable spending 10, 12, 15, 18, 24 hours on a simulator. Generally, they kind of want to get right to it. So we think these products can enhance learning, but we haven't figured out the way to make them standalone learning, if that makes any sense. So this is just a list of some of the learning technologies that we've developed at Intuitive. And we have some things that are working really well, and there's some things we want to do in the future that can take it to the next level. So I'll kind of go through each of those briefly. Intuitive Learning, I mentioned before, is our learning management system. It's translated into 17 languages, and we're able to assign learning plans to every member of the care team, from the surgeon to the coordinator, to a nurse, to a first assist. And these are really designed to make sure, number one, our customers can track their progress and that we can assess them on whether or not they learned the thing they were intending to learn. And then finally, they're used by hospital learning coordinators. There's a function in Intuitive Learning that allows the hospital learning coordinator to assign curriculum and track progress. So they can track progress of residents, attendings, fellows, as well as care team members, to ensure that their teams are up to speed and that they've mastered what they need to master. And then you've got SimNow. SimNow's now been featured, SimNow, that's funny, has been featured in over 300 peer-reviewed journal articles on the impact of learning the system and the platform. So it's console related primarily, and there's a lot of different use cases. We recommend SimNow exercises for new learners or naive learners who are just starting through the learning curve. We also recommend SimNow for surgeons who may be struggling in a particular area. Maybe they're having trouble controlling their master workspace, for example. There are SimNow exercises that can help them improve that skill. In addition to that, there's an entire video library or SimNow library of procedures. So you can assign, for example, a very, I'll call it rudimentary procedure assignment to a new resident on, I'm going to make up a hernia again. And it teaches them the anatomy and the basics and the steps they need to take, all the way up to more complex procedures. So it enables learners at all levels to be able to use SimNow to practice and hone their skills. Our advanced tissue models replicate human anatomy. They're fashioned to replicate human anatomy, and their interaction with energy, stapling, and suturing is very realistic, immersive, and quite frankly, very, very close to a live patient. In fact, many surgical society presidents have told us that they actually prefer these models to cadavers, because the tissue effect is much more realistic than a cadaver. And so we use these models because, number one, they're efficient. We can get training anywhere. We don't have to rely on live animal models because it's ethical. And also, finally, because it's a standardized, reproducible model. So the learner gets the same model every time, and there aren't complexities with the specimen that interfere with their learning. And then I'll just touch on remote case observations and telemetry. I think I said before, case observations are really important. They're really important for that surgeon to understand what he or she is getting into and what they are going to have to do to adopt Da Vinci into their practice. And doing it remotely saves them a lot of time. It allows them to ask questions from an expert surgeon, and it gives them that opportunity to, I'm going to use a bad phrase, kick the tires and see, hey, is this really what I want to do? So it's been great there, but also telementoring. So a lot of times a surgeon is moving through their learning curve and they've got a case that they're not so sure about. And they've done several procedures, but they just kind of want to phone a friend for help. And that's where telementoring comes in, where an expert surgeon can pipe into the room and walk them through things, help them look at maybe aberrant anatomy or something that they might be doing, or just giving them some feedback on their technique. And so I think all these things come together. And then the most important part is that if I were a learner, I need to be able to track my own progress. I want to see how I'm doing. I don't want to just, I mean, I don't know how many of you have heard from a surgeon, well, I think I did 300 cases last year, but sometimes it may not match that. So letting them get that physical evidence of what I've done, what I've accomplished, how long are my cases taking, and then using the intuitive learning to track what they need to learn on top of that. And additionally, using Hub. So using that media manager component if I'm a fifth-year resident, I can download my video and share it with my program director and get their feedback on how I perform. And so all these tools kind of culminate together to help surgeons track their progress. So I told the team earlier today, I'm kind of cheesy, I like quotes. So I found a quote from a very long time ago from a gentleman that you might all know by the name of Abraham Lincoln. Yeah. And he said, 1860s or something like that, he said, the best way to predict the future is to create it. And that really resonated with me because I think that's where we're all trying to go together. How does machine learning, how do these digital technologies and artificial intelligence come together? And then how do we as manufacturers and regulatory bodies be really intentional and careful about how we do this, how we create the next generation of surgeons using these technologies, but do it in a really intentional and thoughtful way. So I thought I'd close with that. I really enjoyed this meeting. I've learned so much, and I thank you all for everything I've learned. So thanks so much. Love to take some questions.
Eu não vou passar para as perguntas.
I'm not going to go to questions before a comment. I'm sorry, because me and the microphone, we go way back. So, first of all, she said at the very beginning of her presentation, talking about the future, and now she brought this quote from Lincoln. So I wanted to remind you of two things. This quote from Lincoln, that the best way to predict the future is to create it, I immediately remembered a song, very romantic considering Brazilian Valentine's Day, from a Brazilian songwriter called Chico Buarque. And it says, remember the future that we agreed upon. So we can't agree upon a future because the thing is, we can't control what's around us. We need to fight for it. So that's the first thing I wanted to comment. And the second thing is, last year, people usually invite me, they ask me to say, what's going to happen in 2030? I have no idea what's going to happen in 2030. But I actually found something out. Looking at what we used to watch on the show The Jetsons in around the 60s, that creature literally knew everything that was going to happen. They had a pediatric consultation from that was Elroy. I have like the long-term memory, even though I'm old. I remember that Elroy had the online consultation. Jane had online personal trainer classes. I'm not even going to get into further detail, but I think that's enough. I'm not even going to say, transportation, cars flying, and everyone is dreaming of having those here in São Paulo. And I don't know, maybe we wouldn't have cars by then, but it's important to realize that we see that and we need to fight for it. So since we're talking about education, Also, when she talked about virtual training, I'm sorry, but what came to mind was the scandal that we saw over the last 15 days of that woman who had an online training for peeling. And the poor patient actually died, even, after she got her certificate to have the skin peeling done. So we need to be really careful because many times the method, the way that the training is done, we can't really trust only in what's new. There are some things that need to be like the old ways. Even, ladies and gentlemen, sometimes we need, just to talk and write on the board. You know what I mean? Like old time's sake. So we need to remind ourselves of that sometimes, not only focus on what's new. And it's not only the way that we teach and the knowledge that changes. We've changed. So everyone who's here is here because they want to learn something. I'm sure that all of you have years of education under your belt. I'm sure. So you are among the people who want to keep being submitted, let's say, to some kind of new knowledge that you can use as you will. I had a student on a course that just finished last week. He was a representative for an international company that was a manufacturer of medical devices, and he was a manager of the marketing field. And he told me, sometimes I had to go in the field, and I would be like shocked actually when he said that, but he said, I had to go into the field because the guy didn't have training or he didn't feel secure to perform that procedure. So I had to go and do that. So this person, a marketing person, went there because he had 740 million hours of training. And as soon as the type of equipment changed, that would become obsolete. So what she used, lifelong learning, I think is the solution. The worst thing is that not we, but I am getting older. I was going to say that the population is aging, living longer. So lifelong is, longer and longer. But there's actually one more thing that she mentioned, because my handwriting sucks and I can't understand. She talked about the training audit, actually. I was mentioning that the health professionals, I don't want to talk about doctors, but they don't like to be submitted to evaluations. But those who teach really don't. The teachers, they like to evaluate. They don't like to be evaluated. That's even better. So we need to be careful with that. And then she mentioned two more points, and I think I'm going to stop talking. Otherwise, I'm doing like another talk here, and that's not what they called me for. But one of them is we need to consider, for example, communication. So the team, she talked about the team 700 times. Communication, or when communication fails, and let's say that it fails 90% of the time in any kind of organization, and in healthcare specifically, that happens a lot, this will generate safety issues for patients and workers due to lack of communication or miscommunication. So we need to be very careful because communication needs to be effective. The communication that actually has to do with getting your information and knowledge through, as well as the communication between team members. For example, the name of this session today was Educating Consumers. So people thought that they were talking about educating the population that are going to receive the robotic surgery, when in fact, the consumers or the clients in this case are the people who are going to operate the robots and operate people. So I was wondering, nowadays, we are on a transdisciplinary, transcultural age. Even in an opera, this is happening nowadays. So imagine in healthcare, imagine when you talk about something such as robotic surgery. And we also need to consider, and I'll stop here to see if we have any questions. I wanted to think about, for example, imagine the privilege when we have the Genesis team, like she mentioned. They go and they find problems that an organization didn't even know they had. Each of us, as managers and professionals, wherever we work, we don't want to have problems. We love not having problems. So who wants someone coming in and saying, we have a problem and we didn't know we had it? If we think about Deming, who was the father of quality assurance and quality business, the entire philosophy is each problem is treasure. He needs therapy ASAP. But even in this case, it is an opportunity for improvement. So I think we have this opportunity for improvement here. She is anxious, not me. She is eager to receive your questions from you, ladies and gentlemen. And I will hear and take notes because I'm going to comment everything again. Thank you so much. Go ahead. Let's get the microphone. Good afternoon. My name is Carlos. I'm a surgeon. And I am a proctor at Intuitive. I do robotic surgery in Brazil, and I've been doing it since 2013. I got the training in 2008 in the US. I actually teach for Surgery 4.0. And there is a slide that I show the Jetsons, like you mentioned. And we can see telesurgery, tele-appointments on the same screen. And everything that you mentioned is there on that class. So 61 years ago, they already anticipated the future. But even more impressive than that, a comic strip artist in 1921. Imagine the OR in the 1920s. It was a gurney surgeon with no gloves, a nurse with no mask, and some supplies and instruments that were only made of steel just to try to mimic what the Egyptians used 3,000 years before that. And on the comic strip, he created robot-assisted surgery. It's impressive. I can show you that. That was created in the 1920s because he created robotic surgery exactly, but there was no electricity. It was actually steam-powered. So it was robot surgery, but it was steam-powered just like we have today. And that was over 100 years. Well, with that said, the other part that is not as pleasant to you, Shelley, but I will kind of take my stand, if you will. I would love for Intuitive in Brazil, respecting, of course, the specificities of countries, like you said previously. I would like for you to work closer to the specialty society and medical societies, which is currently not happening. This is completely separate from medical societies and the specialties societies. Brazil, I don't know, actually, I think it's the only country where robotic surgery is actually regulated. It is regulated by an MB resolution, which is the Medical Brazilian Association and the Federal Council of Medicine. And the specialty society knows that there are a lot of standards that are used that were very learned from what Intuitive actually taught us, of course. And respecting Brazil's specificities, we have continental dimensions in this country. We need to train surgeons from north to south, and each state is a different world, not even a different country. Like training everyone in each state in the same way, getting a surgeon from the north to the south to have training would be very costly, as you have mentioned before. So in that aspect, I would recommend or request that you work closer to us with the Surgeon Society, the Specialty Society, and help us train surgeons and not kind of separating like you do in Brazil, having your own training that is not recognized by the Council of Medicine or the Brazilian Medicine Association. So in Brazil, intuitive in terms of training is completely separate. I don't know if that's intentional. I don't know if that's due to maybe not knowing the dynamics of the country in the way that training is regulated in Brazil. And I would like to hear your opinion on that, of course. Let me check if there's any other questions, because if there are, we can have a block of 2. Otherwise, while people think, she can respond to this one. We have another question. Thank you.
And please identify yourselves before asking the question.
Thank you. One of the things you mentioned around, you have a lot of training centers all around, and I'm curious if one of the things that I'm curious about is that surgeons have the time to go and do. This is a lot of training. Like we both know this, right? These systems are complicated. They have a lot of user interfaces. They require a lot of time to commit to learning. And is there resistance from the market to say, I don't have days and weeks to learn how to use this thing. I need to be able to get, I've got surgeries to do. I'm not making money when I'm off training on your thing. And are you seeing, do you guys see that kind of dynamic? And because we know that technology will allow us to supplement some of the training, but some of it you have to stand in front of the robot and actually touch it and operate it. And is that a problem that you guys see with your training?
Yeah. Could I please ask you to introduce yourself?
Oh, yeah, sir. Joe Sisa from Medtronic. Thank you.
He probably just assumed because I know him. Which question shall I answer first? Okay. With regard to your comments on surgical societies, I appreciate that feedback. And I think probably the reason we haven't spent as much time with the surgical societies in Brazil and some of our distribution markets has really been in the past more of a bandwidth problem versus, not wanting to do that. So knowing what you've said today, I think we need to find a way to make that happen. And I think it's really important, particularly with what you said, the nuances of different states and different regions. So I will definitely take that back, and we'll find some kind of a solution to ensure we're engaging a little more wholeheartedly and understanding the complexity of the problems the societies are trying to solve. I think it's well said, and it's valuable feedback. So thank you. And then Joe, in answer to your question, the answer is it happens, but it's rare. But it does happen, and I'll throw out some examples if you don't mind. When we launched the single port system in the United States, the users we were training were experienced XI users, and all of them did not want to come to training. I can get this. And what we realized quite quickly, after the IDE study, we brought our expert surgeons back, and they couldn't remember how to use it because it is a completely different paradigm shift. And I actually remember my days at Covidian trying to sell single site and teach surgeons how to operate differently. So I think we inherently understood this is a different system. The approach is completely different. The internal collisions are different. Everything's different. And so we kind of forced the issue and said, we couldn't dictate that they had to have a certificate, but we basically said, we actually want you to have a certificate before you operate. And some of our sales leaders had to be pretty firm about that, but it made sense. I would just like to make a quick comment on what you just said, just regarding this last question and answer. Here in Brazil, it would be easier to bring the surgeon for a retraining program if we were working together. And why is that? Because in Brazil, physicians have to register at the hospitals, and at the hospitals, they have their curriculum. So a pneumologist can serve lung patients, a general physician, the general surgery. They have the credentials at their hospitals, and robotic surgery is one of those credentials. So we could, using that tool, where in order to re-register for a single port, you would have to retrain, or else the hospital would not allow them to conduct that surgery. It's that simple. So it would be much easier to do that and bring the surgeon to that commitment. We know Brazilians, so that's why we regulated robotic surgery in Brazil. We know what we're dealing with, and we know that Brazilian surgeons do not have a lot of discipline, so to speak, and they do not want to retrain. And in respect and care for the patient, we actually conducted this huge work of certification in Brazil, and that is well regulated, but it's not that much respected because, you know, one of the things is that Intuitive has their own training system, and a lot of people say, well, just train with Intuitive. But in Brazil, that means part of the certification only. And if we were all on the same page, then that would be much easier, and that would increase safety for the patients and also would decrease by 1,000% my concern as a health professional worried about the training of surgeons for over 40 years. So really, answering his question and working together, we could, you know, guarantee in a much better way the safety of our patients. Well, with that, I would like to check if we do we have more questions from the audience? Yes, they're at the back.
May I just answer that question? Sorry, Carlos. Sorry, I wanted to make a comment because I think what you said really resonated. And in different regions around the world, societies have varying amounts of influence, right? In Japan, for example, all of our training gets vetted by the Japanese societies before we're allowed to introduce it. And even if there's not that much, I would say, power or influence from societies here, I agree that working together, and you can talk to us about concerns you have around safety or surgeons who maybe are not following the process that you think is important. We can do some of those things together, I think. I think it would be really, really important, especially as the market continues to grow. Thank you.
Então, vamos para a pergunta ali do fundo.
All right, so moving on to the question at the back. Good afternoon. My name is Giuliano. I'm with ANVISA. I work in the sector that regulates medical devices. I would like to congratulate you, Dr. Shelley, for such a great presentation. And just like I asked in the previous day regarding the concern of the agency regarding robotic surgery and the training and skilling of healthcare professionals, it's really great to hear that a company like Intuitive has a role of a person focusing on customer training. Just by knowing that, we understand the concern and how much that is relevant for the company regarding the use of this equipment. So just by having a global VP on customer training, that goes to show how much that is relevant and your concern of promoting the use of this equipment. So I would like to know, considering your global procedures, if there is a minimum amount of hours determined by the customer to be using this equipment, how many hours, or if there's a possibility of the users doing some advanced training considering these programs.
Mais alguma pergunta na
Any other
plateia?
questions from the audience?
Porque o tempo está terminando.
Because
Se alguém quiser fazer
our
pergunta,
time is almost finishing.
porque no Dia dos Namorados. Tá bom.
I think we've got 4 minutes. So I think I'm right. Anyway, thank you so much for your comments and your question. I really enjoyed giving the presentation and hearing from all of you this week. Your question about the number of hours is really interesting to me. And we've done sort of sampling surveys from our professional trainers around the world. There's over 100 of them. And they pretty much know when a surgeon walks in and sits down at the console, whether they're going to be able to get through the protocol or not. It's quite fascinating. But I think we look at it in a slightly different way. So you may have a surgeon who just gets really comfortable on the console very quickly. We've seen 10-year-olds get on the console and start just doing things, and it's like magical, right? Because they all play the video games.
That's intuitive.
But what we're looking at the moment is not necessarily hours, but moving more to outcomes-based learning and really understanding if we teach a thing, if we teach a task, is the learner able to complete that task? And can we score that task in a particular way? And we're looking at ways to do that, I would say, in a qualitative way right now. But I think in the future, there will be ways to do that in a more quantitative way, and a more objective way. So we're doing some projects, internal research around objective performance indicators showing, for example, if you rate this score on economy of motion, does that make you a more proficient robotic surgeon? So I think, yes, the answer to do we want to make sure we're getting really proficient surgeons out of these programs? Absolutely, that is the end goal. How fast we can get to more an AI model that predicts, did this surgeon do well in the training day? And is there a skill they need to elaborate on when they leave is kind of the model we're working towards. So the idea that at the end of the training day, at some point, you would have more of a report card and you'd say, you did really well on these tasks. And in these tasks, you struggled. So we're going to recommend that you do these exercises in order to improve your performance before you start doing procedures. It's all things we're working on in the future, using machine learning algorithms and such, but it's definitely something we've thought about. Because the hours don't seem to match up with skill all the time, unfortunately.
Momento, microfone.
Just a moment so that we can get the mic to you. Thank you. Right, so here in Brazil, there's a lot of literature on training. At the time I looked at that, there was over 1,000 papers published on the validation on robotic surgery. 147 were raised to validate training in Brazil. So what was validated in terms of hours of simulation? At least 40 hours on simulators. So that's the minimum that we have on our Brazilian regulation. To watch at least 10 surgeries online and 10 surgeries in person, and then conduct at least 10 surgeries with a preceptor. That's the Brazilian regulation based on literature about validation of training in Brazil. A lot of that literature actually sponsored by Intuitive. So there is literature about it. It is there available. And the validation that we conducted in Brazil was based on accredited data of national and international literature. We have only 2 national publications and then hundreds of international ones. And all of that was validated. And on the second equipment, for example, in Brazil, we have 3 pieces of equipment that are validated from Intuitive, from CMARC, and from Medtronic. the Hugo. For the validation of the second equipment, everything it's then cut in half. So 20 hours of simulation, 5 preceptorships. So that is already in our regulation, and that's a resolution by the medical board. Based, just to answer your question. Well, I think it's very interesting to see in a session like this that people would like to continue discussing, because we will never have absolute answers. So whenever we're talking about evaluation, and the last thing that you talked about, that you conduct qualitative assessment and that you want to try to get to a qualitative objective assessment, the one-on-one assessment has to do with the criteria that you choose. And these criteria are the ones that that person chose. So you will never have 100% objectivity, regardless if, it's regulated or not, for example. On the other hand, we have other types of regulations that are not really complied, and that shows a pessimistic side of me. But one of the things that I found kind of sad and interesting at the same time from the previous panel was not really regarding the technical issues presented, but the example of the multi-outlet, power outlet. So whenever we have problems like that, when we're dealing with safety, then we realize that we have a long way ahead of us. So if the team knows how to deal with the new technology, that's important as well. But since tomorrow is the day that we honor San Antonio, the saint of the impossible causes, I'm thinking to myself, how are we going to offer to the Brazilian citizen more access and a safer access? Because that's what we're working for, So with that, I would like to thank you all for being here. Thank you for your attention. Thank you for your time and questions. And especially to you, Shelley, I've learned so much wisdom from you. Thank you.
Thank you so much. Thank you, everyone. It was a great session.
Appreciate it. Mais uma vez, os nossos agradecimentos a Ana Maria Malik.
Once again, thank you, Ana Maria Malik and Shelley Patterson. And moving on with our workshop, we're going to talk about internal and external technical training. For that, I would like to invite Sandra Martins Doggy, Substitute Manager of the Management of Technology for Health Products with ANVISA, to be a moderator.
Dr. Sandro. Wait a minute. Estamos fazendo aqui a troca do equipamento.
We're just changing the equipment, so just 1 second.
Obrigado, seja muito bem-vindo.
Thank you, Doctor. Welcome. Now, the specialist for this topic is Mark Floyer. He's the Senior Marketing Director of Robotics Global at Medtronic. So welcome.
Por favor.
Thank you very much. Thanks for having me today. Before we get started, I want to obviously thank the organization for inviting myself and my colleagues. It's been a great 2 days of information exchange and learning a lot about the regulated bodies here in Brazil. I also want to thank the translation team. They've been doing a great job the last 2 days, keeping us abreast of all the details. So thank you very much. And I hope I don't talk too fast for the rest of the audience. Is there a clicker by chance? Thanks, Shelley. No worries, thanks. Shelley and I worked together years ago at Covidian, so a lot of us know each other. Let's figure this out here. Okay, so what I'm going to do today is briefly introduce myself in the next slide and cover a few topics around what we call internal training. This is not customer training. This is training our employees to support customers who then treat patients. So the topics I'm going to cover is the Medtronic mission and how that informs our training and why it's important. And, you know, it's all the big companies are dealing with the same opportunity here. We're going to talk about the technical training for robotics, what we do, how we do it, and why we do it. We're going to cover some of the competencies, pathways, and controls, you know, of our training teams, and then some lessons learned in the future. Unlike Intuitive, we haven't been out in the market for close to 20 years, so some of our lessons are nascent, or they've been built upon years of training other aspects of our products, and now we're incorporating robotics. So first, a little bit about me. I live and work in Connecticut, where our headquarters is located. I've been with Medtronic for 14 years, started with Covidian, and then was purchased by Medtronic. You know, this quote I actually looked up the other day. I thought it was very apropos to this, is the master has failed more times than the beginner has even tried. And I think that's training, right? I mean, we can't go out there unless we're experts in what we do before we convey that knowledge. So a couple quick facts about me. I'm married with 3 kids. Right there in the middle is actually my son. Whoops, let me go back. Is my son. He's a trainer at Orsi, surgeon trainer in Europe. So training is in the family. It's part of our DNA. I'm very proud of him, and he does well. And so let's jump into it. So first, who am I and why am I talking about training? So I run the Global Robotic Service and Support Organization, of which field service engineers are one of the 3 constituencies that we train to, right? Service engineers fix, repair, install the system in the field, and provide other support. So within my team, on this side, we have technical writing and training in one group. And I'll share why that's important. And not every group shares technical writing capacity within training. But in our group, because our source for training is documentation. So having the writers write the material with the trainers ensures that we have a seamless approach to training. Of course, the source documentation comes from our R&D teams, our use case teams, and all the engineering. And Joe talked about it earlier today, and I'll kind of relate where some of the work he does comes way downstream to my teams, and we deliver training. So there's a constant review of training materials, and my team handles the service training aspect. So first are the Medtronic missions. And, you know, Medtronic has been around for over 60 years, and we have some tenets that have been constant for that time. I think probably the most important aspect of our tenet is these 6 words. And it's really simple: alleviate pain, restore health, and extend life. In everything we do, even from a training perspective, if we train well and our training allows our customers to further service their patients in a safe and efficacious manner, we've met that requirement. And I think it's important when building a training program, and all the large companies, all the robotic companies are in the same boat here. It's hard to do. You have to invest resources, you have to invest the right time and people, you have to stick with it, and it's easy over that time. There's budget pressures, there's market pressures, there's other pressures. It's easy to deviate. It's easy to say, maybe we won't add that extra step, maybe we'll shortcut it, maybe we'll cut some budget around here. You can't do that. I think focusing on the ethics, you know, the credo of your company kind of grounds us back into why it's important to stick with it and build a comprehensive program that ends up meeting the needs of our end patients. So delivering technical training for robotics. It's basically founded on our 4 commitments for training. The first is obviously we want better outcomes for the world, and within healthcare, that's our scope. We derive all of our products and all of our training out of insight-driven healthcare. We put experiences, or we drive experiences that put people first. And I think the more important aspect of this as it relates to training is technologies that train lives. No company can introduce technology without training the teams who then support the technology in the field. If they're not accurately supporting, if they're not doing everything that's required to translate that technology into user-friendly conditions, everyone will fail and patients could be harmed. So it's very important to ground ourselves, at least from a Medtronic perspective. Now, we don't have the training footprint that Shelley shared, up to 20 years. That's a very impressive footprint. But we do have a number of centers around the globe. And Shelley brought up a couple of points that have resonated with us as well, and that training is best served locally. All right. We have partnerships with AirCAD and ORC. As I shared, my son works at ORC. But the fact of the matter is that local language, training in the local language in the local country where maybe the employees only have to drive an hour or two to get there, and they're going home at night as opposed to living in a hotel for weeks at a time, it's much more effective when you do it locally. So that's why you see a number of centers around the globe, which, and in fact, we have one here in Brazil, I'll show in a second, that accommodate internal training. So it's very important. Now, the other aspect of setting up a training program, not just the program and the people, you got to have the infrastructure to do the training right. So I think we've talked about what are the right conditions to make sure that it's realistic. So in our training programs, sometimes we collapse the OR space down to the smallest OR size that we see in some of the countries we're in. Instead of this big spacious ballrooms where we have a lot of room, we bring it down to realistic conditions and have the team train where they're in a constrained environment. And that's an example of making sure you have the right environmental controls for training, but also, does the facility support the robot? You have to have the right electrical, the right weight-bearing conditions on the floors, ingress and egress, spots for, storing all your crates. Medtronic has been around for many years. We do a lot of training, a lot of products, but the robot is big. It's much bigger than a lot of other products and capital that we offer. So thinking around the training infrastructure is a big part of building this out. And then the other part of it, and this is true with a lot of medical equipment, especially in robotics in the last 5 years, the data aspect of building a robot and the data infrastructure around the robot is massive. So the people whom we're training, whether it's the sellers, the clinical support teams, or the field service engineers, need to up-level or level up on their knowledge base of data integrity, what type of data the system is operating on, log file retrievals, and all the other information points that help us establish a safe ecosystem for the robot. So that's our training footprint. This is actually the center in Brazil. These are actual pictures, and I think it's important to call out a couple aspects of this. The first is there's a learning environment here that's consistent with what you'd see in a lot of universities. Multimedia, modern type learning environment, handicap access. I think it holds about 160 people, if I remember correctly, 160 people. The training room is configurable. You have up to 9 robotic stations where you can set up different type of training environments. And I think it's important to have flexible training areas, like I mentioned, where you can configure the room into different conditions depending on who you're training. For example, service engineers. My field engineers, they're mechanics, right? When they go into training, the robot is in pieces. We tear it apart and we rebuild it from the ground up to learn every component. So that space, we would have workbenches all around, and we'd have electrostatic mats to make sure that we're not doing anything untoward to the equipment. So that's our training, whereas this is probably more configured for customer training, right? It's a clean OR type environment. So this is our local training facility in Brazil. We're building more, obviously, as we expand our footprint, but I think most of the companies are coming up to the same point where local training is the key. Train in the local language with the local people, have the trainers sometimes fly to the location as opposed to all the employees fly to a central location. That's not always possible. We know that. Sometimes you have to aggregate a number of people and you need some of the larger training facilities, but we've learned over time that local training is best served. So a couple things that I want to talk about. Our training program will deliver a comprehensive world-class learning and development experience that really emphasizes 3 points. The first is, it ladders up to our mission, alleviate pain, restore health, and extend life. And I think I mentioned why that's important. The second part in the middle, and I think this is really the heart of why it's important. Equip the Medtronic teams with the appropriate clinical, technical, and capital selling capabilities to drive positive patient outcomes. So that's the linkage, right? If we didn't have that grounding, I'm not saying any company would do that, but with that grounding, it always reminds us that if we're tempted to take a shortcut, we can't. At the end of the day, the patient is at the end of the training cycle, and that's true whether we're training customers or internal people. So this is, again, just another reminder of what we do and why we do it. This slide is very important because this kind of emphasizes the philosophy of what goes behind our training. What are the guiding principles that has built our training program? And the first is what we call blended learning. And that's really, and I think Shelley mentioned the same thing as part of the intuitive learnings over time. And COVID taught us a lot about remote learning. So blended learning has taken the old school classroom concept and mixing it with digital, VR, augmented reality, and a blended mix that really takes advantage of each modality. 20 years ago when we trained, we sat in a classroom, we memorized, we got tested, and then we went out in the field and good, bad, or indifferent, we did what we did. Today, it's a lot more engaging. Technology is more advanced, our training facilities are more advanced. And what blended training does, essentially, is allows customizable training. Of all the people in the room here, I guarantee not everyone learns the same way. I think we all have different ways of learning. Some of us are more hands-on. Others learn better in private conditions when we don't have distractions. Others work with a mentor best. They would show one, do one, kind of trade one aspect. So we blend that all together for what we call a blended learning approach. The second aspect, and this is really, I want to call this out because this is the, whoops, I'm not good with the slides, all right, is the adult-centered approach to training. So the analogy I want to use is, and again, this is probably true across the industry, is we don't hire service engineers out of college. We don't hire clinical support people out of college. We're hiring people with experience. We're hiring adults with not just corporate experience or clinical experience, but with world experiences. And so what that means is when we do training, we have to respect the fact that the people who are coming in here are like lithium batteries. They're charged up, they have a lot of experience, they have a lot of advice on how to do things. So when we do adult learning, we have to make sure it's two-way. We're listening to the feedback. If there's an experienced person who's, some of our folks have crossed over to other robotic companies and sometimes say, hey, we learned this and maybe this approach is better. So that's an important part of what we do is to make sure that we recognize the people who are coming to our training and going to our training are responsible adults, right? They're not 22-year-old kids out of college who have no experience and are, coming in very clean. The other aspect is, oops, there I go with the slide again, is the interactive aspect of it. This basically means that all of our trainers are not, they don't just train and walk away. They're not in front of the classroom reading from a slide. They do that sometimes, but then they go and they're working with the teams, they're mentoring, and then they go in the field and they make sure that the training is consistent. And then as the recertification process comes up, the same trainers stay involved with the teams to make sure that their learnings are consistent and they're not dropping off. The one advantage we have in terms of internal training versus customer training, and we talked about that, the customer training, what's the compliance of a surgeon if they go through training? That's less of a problem when they're employees. They're goaled to complete training. There's no option, there's no failure. We're never going to send them to the field if they fail training. They have to go through it. They're motivated to do it. So in some ways, it makes it an easier prospect. But we control these employees. They're our employees. So there is one advantage there. Now, the fourth base is, in my opinion, the most important aspect of this philosophy, and that's competency-based training. And there's two aspects to competency, proficiency and competency. And I want to use an analogy there to kind of share the differences and why the distinction is important. Proficiency is basically task-based or specialized aspects of training. And I'll use suturing as an example. Proficiency training may be, I'm going to teach somebody how to suture. Regardless of the suture, you're going to do a surgeon's knot, you're going to learn how to approximate the tissue, tie a knot, understand what suturing is about, wound closure aspects, but that's it. Competency-based training is basically taking the suturing and now adding training around the multitudes of suture materials and when a different suture is used for a different procedure. Procedural training on how to use a suture in a different case. When is a polypropylene suture more beneficial than, say, a braided suture or a barbed suture, for example? And the third aspect would be, how would you incorporate suturing into the robotics training? So competency-based is taking a block of tasks, bringing them together and saying, there's a bunch of skills they have to learn and pull them together so that the aspect of the block of training is complete. It's not just one skill. So that's an important part of training. I think it kind of leads to a more complete, holistic aspect of training once they're done. So I think I know, 100% know that all training programs have to start from a source, right? We just don't make up training in thin air. As my colleague Joe talked about this morning, obviously the engineering team produces a lot of tests and verification, validation documents, of which come out of that are the user manual, user guides, the service manual, and all the technical documentations. We cannot deviate from that. Our internal trainers, and I'll use service as an example, service engineer has a process. If they're replacing a part, it's a step process. They can't make up a step. They can't go out there and just say, I'm going to wing this and do this my own way. They have to validate every step is complete, check the system, complete a number of tasks to get the system back up and running, and then document that. So every aspect of our training is laddered up from technical documentation. Any changes to the documents require changes in our training curriculum. And I'll talk about that in a couple of minutes, because that's an important part of maintaining an active training program, is you just don't stop once you build it. You don't step back and say, I'm done. That's when the hard work starts, because product changes, market changes, things we learn in the field. Something we may have trained, we think we're spot on. We talked, formative training, use case training. If you get it wrong, if you get a requirement wrong, and you go out in the field and you realize we're training the wrong thing or we're training wrong, you have to come back in and revalidate your training and rewrite your training. It doesn't mean that we're providing unsafe training. We might learn a nuance about how a clinician or an OR operates a system that we didn't consider in our lab. So that's just a normal process, but it's very important that we recognize that our documentation is our source for everything we do. And it's just an example of the setup guide. And again, a setup guide is a good example of our startup specialists, who are our clinical support teams. They can't go into an operating room and deviate from this. This is the Bible. They can only tell the surgeon, this is how the setup goes. If the surgeon wants to change it, that's up to him or her to do that. But our team is trained to a specific setup, safe and efficacious use of the system, and how the arms operate, and how have they been tested for best access. But we know surgeons will deviate, they'll modify, they'll experiment a little bit to try to organize or figure out a better approach. And that's great, because if we learn, if we understand that, we can certainly make changes to the user manual or user guides over time. But that's a slow process, not something we do fast or without a lot of consideration. So let's talk about the competencies, pathways, and controls. Because like any sort of program, if you don't understand what you're doing and if you don't measure how you're doing it, you're going to fail. So a couple things to note here. The program we offer is called the Odyssey Training Program. It's structured around the development of competencies, which are, as I mentioned, the skills and knowledge and capabilities of the individuals in the program. The training is divided into tailored programs. right? So we call them training blocks. So if you think of and I'll show in a couple of slides what that looks like, but each training block is like a different chapter in a book. You could basically take out that block of training, rewrite it, configure it if you learn new stuff and plug it back in, as opposed to rewriting the whole book. So it's modularity. It allows you to plug in different competencies that have been, I guess, as fine-tuned as possible to make sure we don't have too big of a competency we're training for. The second aspect is, the third is there's different pathways. So as I mentioned, there are 3 sort of support roles. There's probably a couple others that are hybrid roles, but the business developer or the sales rep has different training from the service engineer. We would never want a sales rep fixing a system, right? No way. I don't want a seller opening up the system and repairing it, nor do I ever want my field service engineer trying to sell a system. So their training is very structured and identified to what their role is in the organization. So there are some commonalities to the training, and I'll show where the overlap is. And then there's some very specific guided training based on the roles they're in. The course is designed to be adaptable and responsive to the organization's needs. As I mentioned, product changes over time, which should be continuous. We'll make sure that the training stays active and fresh. The content structure of the course, I talked about that, and the course requirement is that every block has to be completed and passed before you can advance to the next block in training. So, and we all know that you get some people in there who they fail. They can't get through training. There's a certain block there. We try to retrain them and get them back into, try to understand where they failed and get them back on track. But some people just don't make it. It doesn't mean they're fired or let go. It means that they're moved into another area of, say, field service, or where they're maybe handling less complicated products. I think it's safe to say that in our training program, most of the people who come to the robotic side come with vast experience in other parts of the business. They've been field service engineers for years, handling navigation system, ORM, imaging systems, and now they're taking on the robot, which is, much more complex than some of what they're handling. It's bigger, requires a higher level, in our opinion, of training and then support. So this is this is not all the competencies here, but this is an example of some of the core competencies that we've kind of grouped together. And I think it's safe to say that the 2 most important aspects are the technical and the clinical acumen. Business acumen is important, but that's an internal competency that makes sure our teams are efficient. Customer communication is obviously important. We want to make sure our teams are communicating appropriately and ethically and on label to our customers. Some of this is just, hey, if you're going to college, make sure you understand what you're in for, right? And I think that's important. But in this, so technical acumen, you can see here everything from case support in the OR to service response, troubleshooting, coaching skills. These are all very critical, and it's blended. Some of this is obviously field service. Some of this is going to be your we call startup specialists, which is your clinical support team. Your sellers are primarily focused on these areas right here. So selecting, again, this is, my trainers tell me this all the time, and I kind of believe this, but if you select the wrong competencies, you're going to have bad outcomes. So it's really important when designing the program, like you're designing the product. Training is a product, right? You're delivering a product to your people, so you have to make sure you get it right. The requirements, the validation, the verification, everything you do, it doesn't have to be 100% perfect, because we already talked about there's always adjustments. And you're always learning and changing as you go, hopefully in the right direction, but you have to make sure you get it right. And so again, this is not every aspect of the core competencies, but this represents probably 90% of what our teams go through in a training curriculum. And with training, and I think the regulatory folks in the room would love this, you have to track and document every aspect of training and certification. We just don't train and thank them and send them out in the field. There's actually, it's a little bit hard to read here, but you can see this program tracks everything from the competency, the sub-competencies, the activities and tasks. Remember the proficiencies, suturing versus, docking as an example. the type of person that's going through there, and whether the task has been completed or needs. And this is our tracking system here. So every individual who's been trained is tracked, recertified, and inspected to this standard. So this is our Odyssey program. And as I pointed out, there's three constituents or three personas whom we train. Field service, that's my team here. Startup specialists, which is your clinical support teams, and your BDs or your sellers. And if you look at our training is 10 weeks, but there's probably 10 to 15 weeks preceding this where all these individuals are learning their base skills. How to sell, how, clinical anatomy, physiology, and all that sort of stuff. So once they've leveled up to basic understanding and whatever the role is, then they go through robotic training on top of that. So what does the curriculum look like for the business developer and the startup specialist? They're very similar. And as you can see here, you basically have 4 blocks. The first is virtual technical. And that's a 2-week block, of course, where it's self-paced at home, and they're going through all the background, the parts, the product, the clinical, and all that sort of stuff. The second is a technical face-to-face, and this is where they come into one of our training centers. And it's, this is all day long. Again, I'll use the service team as an example. Day one is system operation. How do you start? So they learn how to operate the system just like a sales support person or startup specialist. They learn the system from start to finish. Then they go into troubleshooting. Then they go into repair operations. And then we have like several systems that are like the old high school shop cars where the students are all tearing it apart. And we actually tear the system down and we rebuild it. And we run it through all its competency checks. And basically what that does is it gets the service engineers to the point where they're skilled up on a practical sense. And then they go and they do virtual, I'm sorry, I'm talking about this field, the commercial teams here. So this, in this case, the startup specialists spend a lot of time in the field, up to 4 weeks, where they're actually working the clinical cases, understanding what's going on, learning how the robot operates in the operating room environment and all that sort of stuff. And then the block 4 is really the advanced technical training. And a lot of that is they've gone through basic training. Advanced technical training is unique situations, recovery scenarios, different troubleshooting or clinical scenarios where we've incorporated lessons learned from the field back in the training. So advanced training is very important. And again, the capital sales team, they're doing more virtual, and the startup specialist team is hands-on. Now we're going to talk about my team. So this is the service team. Now, one thing you'll notice is they don't go through a full 10 weeks of training because they've got a lot of skill training that precedes them even showing up to robotics. So they're already tenured, skilled service engineers before they're selected to be a robotics service engineer. So not every service engineer can ascend to that. It is a different level within our organization, so it's something that the teams aspire to as a promotional opportunity, and it's a good career track. So the difference is similar virtual technical, but the face-to-face technical is where I described the service scenario where they're in the lab, learning hands-on down to the schematics, how to maintain, support, and install the system. And then, of course, they're in the field, job shadowing, working with another service engineer who's vetted and credentialed, and they're shadowing that person, following the same procedures and policies, obviously in the regions. So our regional service teams are in an independent group, and we work with them, and they have their own management team. So basically, we train them. They go in the field and follow their competency pathway and job shadowing, and then they start taking on individual assignments and jobs. So that's the training pathway. Now, as I mentioned in the beginning, the 4 tenets or the 4 principles of our training are blended, interactive, adult-centered, and competency-based. And this is sort of a day in the life. This is what a training curriculum looks like, say, for a startup specialist. So the first is, one aspect would be system setup and startup. The Medtronic training teams blend, the VLT in-person training. We've even started using HoloLens in some of our trainings, and we've got augmented reality where service engineers can put on the HoloLens and they can see ghosted schematics inside the system itself. So if they want to pull up the service manual, they can click a button and the service manual will be there while they're working on the system. So we're incorporating new technology to be more proficient and efficient in the field. That's just an example of the blended technology where we're using different aspects of training to level up our teams. Second aspect is interactive. And this is where the trainers are physically working side by side with the students. I think in this case, they're looking at withdrawing and exchanging an instrument. Right, that's an important part of hands-on. Let me show you how it's done. Now you do it. Now you repeat it, and now let's test to it. So that's an example of interactive. And then in terms of adult-centered, that kind of incorporates the whole aspect of this. But one weird part of it that I think is an important part of adult-based training, and we call it the team dinner. And really what that is, and if you think of for those of you who've been to grad school, right, MBA courses, you're often with a cohort, you work together, you study together, you go off and you socialize together. But this aspect is kind of cool because these adult learners come back and they discuss, they talk about what they've learned. They do a down brief over a beer or two. They talk about what was effective, hey, you did this over there, show me how you did this. So training doesn't stop, when the bell goes off at 5 p.m. Our groups continue to discuss and talk about training at night over beer or dinner. And the next morning, if they have any questions or changes to or suggestions, we would certainly listen to them. And then the fourth is what we talked about, competency-based. So these are all competency-based training points, port placement and docking part 2, configuration and draping, system setup and startup, task simulator practice. So the point of this is within the training program, you're going to see different aspects of blended, interactive, adult-centered, competency-based mixed in there for a more effective training program. Now, I don't know why these text blocks moved, but what I'm trying to show here is each aspect of training, again, we just don't thank them when they're done. There are tests that they have to go through. So for block 1, there are 2 exams, and that's tested upon all these aspects, all these competencies here. That's after their 2-week online training. They have to pass before they can go to the next block in training. Block 2, again, it's another aspect of training, a 2-week practical at IRCAD. Where we have a lab there. And block 3, clinical soft selling skills, another example with a test. And then block 4, advanced technical training, suturing, sign off, et cetera, and so on. So each aspect of the training program requires a competency test, a completion of some sort of test, whether it's hands-on, verbal, or written, if you will. And then it's documented in our training system for posterity. So we talked about this, a lot of exams to cover, a lot of evaluations. So, the old principle of inspect what you expect, right? And our internal teams, they're employees. It's not like they're surgeons where we're going to struggle to get them to comply with all of our desired training. Our teams have to comply, and we test them to the point where they can repeat and scale and grow with the system. So again, it's just another slide showing the full aspect of training. So I want to pause and really talk about some of the lessons we learned in training and what have we learned over the last several years. And some of these lessons are not just robotics. These have been, Medtronic has been training for 60 years, and a lot of our training program is built on a lot of known best practices, but robotics is different, right? And all of the companies who are launching programs are learning as we go. COVID taught us a lot of things. We've adjusted with some remote trainings and technologies. Competitive forces, force us to do things differently as the market moves in the different directions with training. But I think in this case, the key lessons we learned, as I talked about, we have to continuously adapt the process. Updates, system updates, new features require refreshed training and making sure that the documentation is updated. Quick story. We had a BSI audit a couple weeks ago, and we were prepared. The lab was great. All our documents were perfectly lined. But one thing we found out is the inspector noticed that one of our training documents basically goes into a training program called Cornerstone, which is an automated program that then disseminates it down to every one of our employees who have to complete the training, and it documents it. Apparently, the document was too big. It was 100 pages and wouldn't upload into the technology. So even when it was a technology issue, we couldn't get the document out into the field within a reason. It took us weeks to kind of get it out into the field. But the inspection highlighted that's not just content that you have to be careful. It's process. You have to make sure that just because you have a program, you've got to keep up with your record. You got to make sure that any changes that occur in the system or into the ecosystem, if you will, are updated fast, incorporated into the training program. And then your trainees have a certain limited time before they have to complete training. If you miss that, and again, we learned it wasn't a big ding, but it was a critical moment for us to realize one of two things have to occur. Either we have to reduce our training documents so it's more digestible. 100 pages is going to be tough to learn for anyone, and that was a sort of a lesson to our tech writer and our trainers. So that's a good lesson that we learned, and we're incorporating it. Everyone does this, but you got to use feedback to improve, right? We talked about adult learning. When they go through training, we always survey them. We actually do an internal Net Promoter Score on our trainers and our program. We kind of measure that internally to see how our customers, our trainers, we think of them as customers too, are dealing with training. Are they happy? Were they stressed out? Were they engaged? Were they able to repeat their training? Are they recommended training to other employees in the company? All very critical for us and very important to building out the program. Another aspect, and again, I think quality and regulatory love this part of it, but continuous focus on complaint handling. Sales reps hate filling out complaint forms, right? It's a long day. They've been in the OR for 10 hours. The instrument has a failure. Our requirement is they've got to file a complaint within 48 hours, and it's got to go into the global complaint handling system, 100% compliance. So we continuously reinforce that. Complaints are important to filtering into the system so we can document and we can kind of understand what's going on with our product. And obviously, every company out there is on the same quality system requirements. But we continuously reinforce that, because if we don't, we'll drift and we'll get lazy and we won't get those complaints in on time. We won't process the complaints on time, and we won't do failure analysis. So it's all an important part of the ecosystem. Smaller classes and local training, as I mentioned, is more effective than larger classes. Incorporate technology and remote learning. I think we've talked about that. There's only going to be more Jetsons-like moments in the future where, 10 years from now, we might have a training technology we can't imagine today. Like 20 years ago, couldn't imagine virtual reality other than cartoons. And then we talked about the right competencies and testing for that. Any input that's bad input will lead to bad output. So make sure your training inputs are accurate. Make sure you align with the engineering team, the R&D teams. Make sure you're constantly reviewing information and you're constantly monitoring the effectiveness of training in the field. And then things we'd like to kind of look at the future, key opportunities, not just for Medtronic, but I think in general, all training programs are probably looking at ways that we can improve in the future. And a couple things for us is, we're looking at, we understand that a lot of customers want their biomedical engineers to be more involved. They're obviously service engineers within the hospital itself. They want to participate more. They don't necessarily want to do complex repairs, but troubleshooting, system care, system movement. So we're improving that. We're providing more and more biomedical training. In the beginning, we were a little hesitant for, safety reasons. We didn't want people using the system inappropriately or maybe changing cables or doing something and causing an issue with the system without appropriate training and certification. So that's one. The other part is we're finding that, and I'm referencing service engineering in particular, and the startup specialists on the other side, is very often with our field service engineers with traditional products, they're very rarely in the operating room. They're in the back end of the hospital, in the bowels of the hospital, doing their thing, repairing overnight. With robotics, given the complexity of the situation, especially in the beginning where the startup specialists and the customers are all learning to some degree, we've noticed that the field service engineers are often invited to be within the OR itself. They help out with some of the setup, and they're kind of in the background. So based on some of that feedback and the asks from our customer groups, we're starting to create hybrid roles where we would take a field service engineer and put him through the entire clinical training class. Competencies, everything would have to be validated, and then they go out in the field and they can act both as a startup specialist and a service engineer in the same OR. So one person for the price of two, if you will, but that gives faster response, immediate understanding of complex issues. If there's a troubleshooting event that goes on, they're immediately qualified to handle it. You know, if the case ends, maybe they can go in later on and run a diagnostic. On the flip side, we have some region-led markets where there's some geographies that are hard to get to, where maybe we don't have the infrastructure in place already. That's another opportunity to maybe cross-train somebody to do multiple roles. So if it's a distributor or a hard-to-get region, one person can manage the ecosystem until we build up the structure around that system. Again, that's part of launching a new product is you have to scale, you have to repeat, and you have to test and make sure that you're not losing your competencies. The other point three, and I think this is really important, is especially field service engineers and to a lesser degree the startup specialists. Software knowledge, data knowledge is becoming more and more important. The robot accumulates a lot of data. It transmits a lot of data. Software runs the system. Software updates are common. Adding the updates and understanding how to do that is a big part of our service team's role. Compared to, say, 20 years ago, where software was firmware and it wasn't as interactive or as dynamic, today data is everything. Data is really the complex part of the robot. And it's important that our teams learn more about that. We talked about the blending and new technology. I think that's a constant opportunity, and it's not one where we pause and say we just need new opportunity. We're always reviewing, you know, even to the point of, you know, how can AI assist us in our training? I think a couple of folks talked about, you know, can AI identify gaps in training? Can AI identify, even with, say, video cameras around the OR, you know, are there things we're missing, the training is missing? Because you only have two eyes, and if you turn around, a training could do something, you might not see that. So having a 360 view of the training environment is really important in our world, because we can go back almost like a sports play afterwards and review the replay and see, well, what did you really do there and how did the system react? So that's it for me. I want to thank you for your attention. I know we're running a little bit. I think we still have some more time here, but I'm also aware it's Valentine's Day, and it's been a long 2 days. So again, I want to thank my team who've helped me out with this and kind of helped me build the slides and the support, and thank the organization for inviting me. I can take questions if you guys want, but I just need to put my headset back on. Yeah, thank you.
Good afternoon, everyone. I was actually joking with Dr. Ana Maria. I said, I'm not even going to mediate, not even as cool as what she did, because it was a class in mediation. That's what she did for us. So I want to thank everyone. And as everyone have said, you know, thank you all for being here, and thank you for inviting me. Let's make the most of our last panel. And this is a very interesting, you know, all the panels were really interesting with not only talking about data acquisition, but like you said, the amount of new data that we are acquiring, and we need to have the ability of developing now how to deal with so much new data. And something that was surprising for me, Mark, I'm going to start with a question for you. You mentioned and you stressed that your system is very interesting because it's a training process that it's basically alive, it's living, constantly being updated based on the feedbacks that you receive. And this is just a curiosity of mine. Did any of the feedback create an improvement in the equipment or change in the equipment?
Great question. Yes, I would say, again, with a lot of product launches, perfection is desired, right? You want to get the perfect product out there, but there's a learning curve. The system is maturing as it goes on. I can't think of any very specific instances where field feedback changed the design, because a lot of what we test the heck out of the system, and we know a lot of the gaps in the system capabilities. But I would say some of the lessons we've learned from customers have absolutely affected our training early in, especially the first year. You build a program, you get out, and you work with your key opinion leaders who help guide us in some of the training. You take people through and you make significant adjustments. The biggest adjustment, I would say, is initially we started in a central location, AirCAD ORC. Let's bring everyone. It's a great facility. We'll concentrate our training there. Worked great for the Benelux region. If you're in Belgium, Netherlands, in that area, it's an easy train ride. France, but somebody coming from Japan, it's not so great. So very quickly, and again, feedback from the field. And again, using Japan as an example, when you're teaching Japanese employees, their English is okay, but it's not good enough where they can learn some of the nuances. So we have to make sure the training is in Japanese. And even though a lot of our trainers don't speak Japanese, we have locals, our global service engineers who facilitate the training with us. And we've found, again, using a couple classes where we've taken people through the class in ORC, taught in English, and they go in the field and we get an email a couple weeks later, hey, we really didn't get that or this. And so that was it was a wake-up call, because we certainly don't want people to go in the field if they don't feel 100% confident and we don't feel their competencies are solid enough. So that was a quick adjustment. We obviously have an MIC, a Medtronic Innovation Center in Japan, as an example to facilitate that. But that's one example. And I would say, the further we get into maturing the product over time, the adjustments we make are going to be smaller, probably more evolutionary versus revolutionary.
Do we have any questions in the audience?
Eu quero fazer uma pergunta.
I want to ask a question. Just a second, Dr. Sergio, please introduce yourself. I'm Dr. Sergio Madeira from ABRAIDI. Good afternoon. We have an issue. I wouldn't say it's specific to training, but it involves technical training. In Brazil, we have a training, and this is not related to Medtronic, Intuitive, or any of the companies that are actually selling medical devices. But we have an issue thinking about technical support, technical assistance. Even though it's a risk factor, in my view, this technical support is not regulated by anyone in Brazil. Technical support can be done by anyone who is, let's say, they have an engineer that is board certified, and they can open a technical support shop, let's say. So what is your opinion, Dr. Florio, on this kind of risk, considering the Medtronic equipment in general, but specifically the robots?
Great question. And it's not just robotics, but the question is centered around will third-party organizations who are not part of the manufacturer or the customer be allowed to access product and service it? And Our opinion is no. And it's a complex answer because in one sense, we want to train biomeds to help support the robot, but we certainly wouldn't want a biomedical engineer in a hospital to replace an arm. You know, that's a complex process and it requires certification and validation. We reinforce when we sell the product to a customer, and I think most of the robotic companies are the same way, the warranty, the contract, and part of that warranty contract stipulates that the system can only be operated on, not operated, but repaired or fixed by certified Medtronic personnel. If, for example, a customer, nobody's done this, but you could imagine somebody would at some point, they bring in a third-party engineer who gets parts on the open market, the gray market, and decides to work on the system. And if something goes wrong, that would violate the warranty. So clearly, with patient safety in mind, most customers I know never do that. They value the manufacturer's support, the warranty support, the hypercare support, and the things that we do, you know, maintaining uptime of the system. And Intuitive's done a great job, and we admire their service organization uptime. And we're, like a lot of leaders in the organization, we copy. You know, we look at best practice and say, how have they done it? How has GE and other companies done large capital service to, and in this case, avoided third-party organizations or non-aligned organizations from working on the system. So warranty, legal document is the key, but the other part is really knowing your customer and you're selling it to the right customer. We don't sell on the gray market. We don't sell to distributors, and we haven't seen any you show up on eBay, thank goodness. But you can imagine that time is going to come, and somebody's going to call us one day and say, yeah, one of your robots is a problem. We're like, we don't know where that robot is, and who are you? But at the end of the day, we have a responsibility to the patient, right? And if it were my choice, if a non-affiliated customer bought a secondhand robot and said we have a problem, we would do everything we could to get that robot operational at a cost. We're not going to do work for free, but we would make sure that we caution the customer and brought them under contract and made sure that if they were going to use a robot that was, again, not sanctioned by us, we would bring it up to fully certified status and then get them on a service plan.
Outro questionamento?
Any other questions? I think there's a question online.
Text question. Technology. Like my kids, they never talk to you on the phone. They text you if they're 10 feet away. It's like, just, can you call? Can you talk to me live?
Ok. Bom, chegou questionamento
Okay, so we do
aqui.
have a question from an online viewer. They are anonymous.
Veio pela internet. Tá,
It
ok.
came from the online viewers.
Que se
So the
refere
question
ao usuário
is
final.
about the final user.
Ok. Bom, tentar traduzir
I'll
aqui.
try to translate for you.
No que se, né, em referência ao treinamento para o usuário final.
Thinking
sabendo
about
que
the
não tem
training for
esse
final user, knowing that they don't have the level of knowledge
conhecimento adquirido no
that was acquired on the technical area. Do you think that that will reduce the training based on technology, or it can bring a higher level of training at the end of the day?
como vou definir
How would you define this? I believe that that was my question.
usuário final.
I'm the final user. I don't have that knowledge in the equipment or the expertise to
Qualquer intervenção
have it. So what is the technical intervention of the equipment? Do you think it would make it so it would be harder or easier to have basic training?
Good question. So when we're talking end user, I'm assuming a surgeon or a clinician who's using it. My training focus stays internal, but I'll address that question because it's very important. If in fact we have any users, any clinicians who feel they are operating the system with inadequate training, absolutely the right thing is to raise the hand. Our startup specialists are in every case. And usually there's a consult afterwards that, they observe, and if they see something, they usually intervene and say, maybe try it this way, or, whatever the observation is, whether it's technical or clinical or just the overall environmental aspect. So I would encourage, any end user, it's not a bad thing. It's actually very courageous to say, I want to learn more. We love that. Clinicians, whether they're nurse, circulator, surgeon, who wants more training, we welcome with open arms, and we'll do everything we can, to make sure we get them into the appropriate, whatever training it is, troubleshooting, system operation. The learning curve is a learning curve, and it's true for any medical product we have. And the critical part of the journey, not just for the clinician, but for everyone, is probably the first 10 to 20 cases, and we could talk about this ad nauseum. What's the right number of cases? How many have to be done? And again, I'm in the surgeon training aspect, but the more they do, and the more they do it in a continuum, we've noticed that even the technical aspects of the system, we get fewer system failures. The arms aren't banging as frequently. They're making fewer user, we can never say user mistakes. Joe's going to lecture me later. Use case mistakes that we've identified. But it's a good question, and the partnership we have with our customers, it's not a 10-day partnership. 5 years from now, if that surgeon wants to learn a new procedure or expand their robotic capability, even if they've done 500 cases, we welcome them, and we're interested to understand what have they learned, how can we help them in their journey, whether it's mentoring, proctoring, or just bringing them in for more advanced training.
Mark.
Mark, this is more of a curiosity. You were talking about, I believe that on Odyssey as well as Genesis, we have professionals that actually aren't able to pass certain blocks and evolve within the training. Do you have a percentage of that? And what is the attempt to the employee? Are they relocated? Is it informed in the beginning? Do they know from the get-go that they're going to go through testing, that they may fail testing, and then later, what do you try to, I don't know, tell them it's not the end of the world and have them do something? How can they understand and follow this process?
Great question. So, start with her.
Sorry, I'm from Medtronic. And I just wanted to know, the importance of telling someone, maybe you don't have that potential or you don't have that capability. You are not able to provide this service. We're talking about patients, lives. So what's the care you have with that?
Question, and I don't have the overall numbers of the fail rate, but certainly in the beginning, when we were understanding like who is the right candidate, again, I'll use field service, or let's use the clinical support teams. Who is the right talented individual that we hire and we bring on board? What is the right profile of that person? Is it, somebody who's been a nurse for 20 years? Was it somebody who is an engineer who, what's the background of that person? So I think we learned over time that not everyone can ascend to robotics, and it doesn't mean that if they fail, they're brought outside and fired and let go. None of that. Every employee is a valued employee, and there's a role for everyone. So as I mentioned, most of these team members are already in a job. They're already doing something, and they're being promoted into robotics, and usually that's through a vetting process where their management, they have the prerequisite skills, they're interested, motivated. They can learn the clinical or whatever they're doing. Some of our clinical specialists have been, doing stapling support and laparoscopic instrument support for decades, so they know the environment, but they don't know the robot. And so the short answer is some people are recycled. It depends on where they're failing, right? If it's a simple task, a single task, we have them retake the task to learn it. But if they keep failing blocks, then there's a question of, is the training environment wrong for them? Are they learning wrong? Is it language? Is it a language barrier? Is something as simple as This person is the most talented person in the world, but they only understand maybe 80% of English, and some of the technical languages is over their head. So I would say in most cases, we take the opinion that if somebody fails, it's my responsibility as the head service trainer and my team's responsibility. It takes a village to raise a child, so to speak, and it's true with training. But we would never put somebody or pass somebody who didn't honestly pass each competency. And if they're struggling, there's a role within the organization. Doesn't mean that they're servicing robots. They could be servicing another less complex product that's less stress. Startup specialists. If you're in the OR with robotics, especially a new robot, it's stressful because the learning curve is real. It's 8, 10-hour days, couple cases. Everyone's learning. That's a high stress job, and it's not for everyone. And which is why we often hire people in that role who've had prior clinical experience. An OR nurse is tough. You're not going to rattle a former OR nurse, and they usually come in now. They're really skilled at the environment, but we have to get their technical skills up. Whereas an engineer, they got the technical down perfectly, but understanding the difference between a radical prostatectomy and a partial nephrectomy and the arm setup is something that they have to learn and train. So it depends on where their background and their adult learning stems from and where they're sourced from. So again, we learn over time. I don't think we're failing a lot of people, but you don't want the training to be so easy that it's not meaningful, and you don't want it to be so hard that this is not Army training where you're putting people through boot camp. These are adults who understand the environment. They're learning the product, repeating it. They have to be able to train it and pass their competencies. Thanks for the question, Andre.
Outra pergunta da internet.
Okay, we have one other question coming online. In the United States, is it mandatory for the hospital to hire a service from Medtronic regarding the maintenance from the equipment?
Yeah, so it's not a law, right? But it's our business policy. We will not sell a robot without a service plan. And that service plan is not just a 1 year, it's a multi-year service plan, because part of that service plan is, the plan maintenance and a lot of things that go into it. And we'd like to share with our customers that the ideal service plan, the ideal service experience is if you're at home and you own a car, your car mechanic comes at night, does the tune-up and leaves a little note on your dashboard. So you get in your car and you drive, and every day there's no drama, but somebody's watching over your system, and that's true with our system. So we by policy, we don't sell without a service contract. We just don't. We walk away from that sale because we're leaving a system unsupported. And that's obviously over time, a part needs to be replaced. And if they don't have the right training and we're into third-party service, we would never do that. But that's a business policy.
Excellent. Do we have any other questions in the audience? Let me see if we have more here coming online. I don't think so. So do we have anyone else? All right.
Ahead of time.
Yeah. We did it.
We did it. Well, happy Valentine's Day, everyone.
Bom, agradecemos, Marcos.
All right, so Mark, thank you so much for a brilliant presentation. You provided a lot of insights regarding training. I enjoyed it very much, and I believe that our audience as well. Thank you so much.
Os nossos agradecimentos mais uma vez ao
All
senhor
right,
Sandro
so once again, Sandro and Mark Florio, thank you so much. And we're coming to the end of our first international workshop on robotic surgery and AI. The intense discussions from these days wouldn't be possible without the sponsorship from Intuitive, Medtronic, Stryker, and Johnson & Johnson. I would like to inform you that throughout these 2 days, we've had an average audience online from 150 people. And now some housekeeping messages. Someone forgot a pair of glasses in the restroom. It's here with the organization. And now we're moving on to the final remarks from our event. I would like to invite on the stage Mr. Sergio Madeira from ABRAIDI.
E também convido Anderson Pereira da ANVISA.
And also Anderson Pereira with ANVISA.
Bom, não quero
All right.
vocês neste final
So I do not want to keep you here, you know, at end of the day. It's Valentine's Day in Brazil.
não vou e também por incapacidade
And also because I wouldn't be able to summarize these 2 days of event, you know. A lot of knowledge and density of knowledge was involved. And so if we were to highlight one topic or another, we wouldn't be fair to everyone. But I would like to take the opportunity to thank a small battalion of people, Deborah, Tatiane, Davi, Sergio Rocha, Lochetti, Davi, who coordinated invisibly everything that happened here, executed in a brilliant way by Tatiana. I would like to thank Monica and her team from INRAD, and all the people from AV. I would also like to thank Hugo and the translation team. Thank you so much for your competence. I would also like to thank Emilene, Roman, and everyone from Intuitive that came to Brazil, our friends from Stratner, Gabon, Jessica, people from Medtronic, and the team that accepted our invitation, Vanessa, for the efforts with the experts from AI, people from Stryker, Patricia Gomez, Fabricio, and people from Johnson & Johnson for the same reasons, Dr. Sergio Augusto, Professor Morgan Rupre, Emerson Capaz, Gonçalo Vencina, Ana Maria Malik, Professor Sabatini, for adding value and just, you know, provide brilliance to this event. And also, you know, Augusto, Anderson, Giuliano, Iran, Marcia, Mariana, Christina, Sandro, Cassio, and Brissan, all from ANVISA. I will probably forget someone, but I tried to list everyone. Geoffrey from ABNT, Marcelo from Inmetro, Davison from Anatel, Wilson from ABRAC, and finally, all of you that accepted our invitation and decided to engage in this journey of knowledge, you know, surf this tsunami of artificial intelligence. To the folks watching us online in Brazil and in Latin America, from Argentina to Mexico, we have, you know, tens, more than 100 of people following our event. Anderson, over to you. Well, I just wanted to thank everyone again and congratulate ABRAIDI for the organization. We have learned a lot, really. Our team was actually talking about, you know, the high level of the discussions and the talks. So we've learned a lot. We will bring that back to our headquarters, and that will definitely contribute to the improvement of the regulatory sector. So once again, thank you so much. I just wanted to leave as a final message that the doors that we were able to open here will require promotion from you so that we actually advance in regulatory issues with Anatel, in Metro, and other organizations. So I hope that we're able to contribute, you know, even to training questions, issues that were raised here. Thank you so much again. Enjoy your evening and hopefully see you again in the next event.